Hello everyone and welcome to Intellipaat's Azure full course. In today's landscape, cloud computing isn't just a trend, it's the backbone of modern businesses. And when it comes to cloud platforms, Microsoft Azure is one of the largest providers. And with Microsoft becoming the world's second $1 trillion company, it's now set to invest $3 billion over the next 2 years to supercharge AI and cloud infrastructure in India, making it the largest expansion in the country's history. Also, with that, opening up tons of new opportunities in the Azure cloud space. From startups to global enterprises, everyone is moving their applications, data, and infrastructure to Azure, as it's also built to integrate seamlessly with the Microsoft workflows. And it doesn't just stop there. Over 95% of Fortune 500 companies already use Azure services. In India alone, cloud related jobs are growing at nearly 25% per year. Thus, businesses and companies are willing to pay skilled Azure professionals really well for it. In fact, according to Naukri and LinkedIn data, Azure certified freshers in India often earn 6 to 12 LPA, while the experienced engineers earn far beyond that. And that's why this course is designed to help you master Azure fundamentals, core services, networking, security, databases, and even hands on projects so you can get started by building the projects with it. By the end of this course, you won't just understand Azure, you will be confident in deploying, managing, securing the real world applications on it. So, without any further ado, let's get started.
Let's go and let's check what are the steps that you have to follow for your Azure account creation. Okay, so as I'm already having my Azure account with me, I will be just going with the incognito mode. Okay, I will be just using the private window. You can use any of your browser like Edge, Google, anything you can use. You can also go ahead with the incognito tab. So what is the very first step that you have to follow for your Azure account creation? The very first step that you have to follow for your creating the Azure account will be your. So let me just go ahead and firstly search for create Azure free account. What is the very first step that you have to do? You have to just search for create Azure free account. Okay. This will be the very first link that you will be getting. Create your Azure free account today. You have to just open it. And here is the link given for your creating the account. Fine. Now let's go ahead and let's discuss how you will be able to create the Azure account. So basically for creating the Azure account, there are two methods. Okay. The first method is known as the start free method and the another method is the pay as you go method. So what is start free? So basically start free will be your free trial account. Okay. Start free will be your free trial account. Just please ignore my writing because I'm just using a mouse, not a pencil. So start free, there are two methods to create the account. The first method is the start free method and the another method is the pay as you go method. Okay. So the very first method is known as the free trial method. Moreover, there are another method that is the pay as you go method where you have to pay for the account. Where you have to pay for account. Clear? So now again I'm repeating it. There are basically two methods to create the account, that is Azure account. The first method is known as the free trial method and the another method is known as the pay as you go method. Okay, in the start free method, that is your free trial, all the services that are present under the Azure portal, it is just going to be free for you all guys. Okay, here you just like receive some credits. Regarding the credits, I will be just going to let you know. Moreover, in the pay as you go method, you have to pay for the account, which means you have to pay for the Azure portal. You can say over here when you are just going to scroll down, this popular service is free for 12 months. It is not not valid for now because Microsoft had stopped this free service for 12 months. So you will be only getting a free service for 1 month. Okay, what you have to do after the 1 month, I will just going to let you know, but just allow some time. Moving ahead, when you will be just going to create your free trial account, okay, you will be getting the 55 plus services that will be just going to totally free, which means you will be getting 55 plus services that is totally free for you. You don't have to pay for those services. Okay. Moreover, the particular account that you had created, you will be receiving 200 USD Azure credits. You will be just going to receive 200 USD Azure credits that will be just going to active for 30 days. 200 Azure credits means you can say 15,800 from Indian currency. You will be receiving 15,800 Azure credits from Indian currency that will be just going to active for 30 days. Okay, the account that you are just going to create, it is just going to be active for 30 days. What you have to do and follow after 30 days, I will be just going to let you, but after the end of the session, at the end of the session, I'm just going to let you know that what you have to follow for after 30 days, what you can just go ahead and do it. Still here it's clear that how many credits until what date, till how many days the account will be active? Fine, let me just go ahead and let's check what are the services that Azure is providing to you. So basically, Azure is providing you 55 plus services that will be just free for your Azure portal. Moreover, you can see it over here. They are also providing you Azure Virtual Machine in Windows, Azure VM that Virtual Machine in Linux, Azure SQL Database, Azure Blob Storage, Azure App Services, Azure Functions, Azure Event Grid, and Azure Cosmo Database. DB is your Cosmo Database. Okay, how many storage and how many it is providing to you, how many storage they are providing to you. When you are just going to create the Azure account, when you will be able to create the Azure account under the Azure portal, you will be able to see all of the services. Okay, so let's go ahead and let's create a free trial account. There are two methods, as I earlier explained you, that there are two methods. That is, the first method will be the start free method and the another one is the pay as you go method, right? So first, the start free method. Let's go ahead and create the account with the start free method. That will be a free trial account. Click on start free over here. Here, you can see this is the very first page that you will be able to log in. That is your Microsoft sign in page. Okay, so if you are having any of your Microsoft account, it should be a personal one, not your organization ID. Okay, so if you are having any of your Microsoft account, you can just use your Microsoft account over here. You can just give your Microsoft account over here. If you're not having any, when you just click where you click which option, let me just go back to the particular page. Build in the cloud with an Azure free trial account. Okay, I just click with the start free. So this will be your first page. Here you can just either give your Microsoft account. If you're having any of your Microsoft account, you can just go ahead and give your particular mail ID over here. Don't just remember one thing, that you don't have to use your organization ID. Don't use your any of your organization ID. What happens? You will be able to create your Azure account with the organization ID for sure. But what will happen, that you will be just not going to have access of all the services under the Azure portal. Okay, you will be not going to have access of every services. Why so? Because organization just what does organization do? Organization restrict the services, some of the services. That is the reason that I'm just saying that don't use the organization ID. Okay, you have to use either of your Microsoft personal ID or your mail, any of the mail ID. Okay, so let me just continue with this. If you're having any of your Microsoft ID, you can just give the mail, Microsoft mail over here. Otherwise, you have to click on create one. Better to just go ahead and create a new Microsoft account. So let's go ahead and click on create one. Okay, you have to just click on create one. Let it be open. This particular page is taking time to open. Let me just share the PDF. Open the PDF only. Okay, so what you have to do with you have to just click on create one and you will be coming to the next page. Okay, the next page will be where you have to create an account. Here you can see that we are having one option to create an account, right? So you have to give the mail ID over here. Now let's come to the part which ID you can use. Okay, so you can use any of your ID. It can be your Yahoo, it can be your Outlook, it can be your Gmail. But here also don't use your organization ID. It will not going to allow you to. It will just going to allow you to create the account, but it will just not going to allow to have a access of all these services over there. Okay, so what you have to do, you have to just click on this one, the particular space that is given. You have to just click on, just give the mail ID over here and you have to click on the next. After that, the page will be coming that is for create a password. So you have to create a password for your Microsoft account. Like for say you had given the mail ID, it has been just given an example that Intellipaat Azure@gmail.com is your mail ID that is given, right? Now you have to create a password for the particular account. Remember one thing, whenever you're just going to create a password, kindly remember the username and the password. Both the things, let me just, this particular ID that you are using and the password that you are creating, okay, both are known as credentials. What I mean by the word credential is that with the help of the mail ID and with the help of the password, you in the future you will be able to log into the Azure portal. So whatever the password that you are creating, whatever the mail ID that you are using, kindly remember those ID and the password. Okay. Okay, so fine. So it's clear till here. Fine. Sounds good. Let's go ahead to the next page. After creating a password, click on next and you will be able to come to the next page. Okay, the next page is all about the verification of the email, which means whatever the mail ID that you are using, the Microsoft will be sharing a verification code to the particular mail ID. Okay, like for say example, we had just given up one mail ID Intellipaat Azure@gmail.com. So I will be receiving a 4-digit verification code to the particular mail ID that I had given. Okay, so just give the verification code over here. You have to just write the verification code over here, the space that is given to you. You have to agree to the terms and condition given over here that yes, I would like information, tips and offers about Microsoft products and services, which means that you are allowing the Microsoft to give all the information, whatever the information they are just going to share. Okay, just agree to the terms and condition, just click on next. So after the verification of code, you have to just solve some puzzles. Okay. So go ahead and solve the puzzle. As soon as you're just going to solve the puzzles, you will be coming to the next page. The next page will be just all about you. Just there will be the 2 pages. Let me just write it over here. This will be your first page and this will be your second page. Okay. This will be a very first page where you have to give all the basic information of yours and the another page where you have to use the card details. So let's go ahead and discuss both the pages one by one. Moving ahead, in about you, they will be asking about like your your first name, your last name, your address details. The address detail can be the permanent one, it can be the temporary one, your state, your city and the postal code. Okay. Moreover, you will be also getting a one option of a PAN ID. PAN ID, one option will be there, that is a PAN ID that you have to give the PAN ID details, but no need to give a PAN ID details because it is your optional one. Okay, so you don't have to share a PAN ID details, no. Moreover, you will be having one other option also of a organization. Okay, organization you will be having. So under organization, you can write it over there in Intellipaat. You have to mention under the organization, either you can mention XYZ or else you can just mention it over there in Intellipaat. Again, I'm repeating, they will be asking about the first name, your last name, your address detail, which can be your permanent address, it can be your temporary address, the postal code, the state, the city, PAN ID will be the optional one, organization detail will be your, either it can be the XYZ or a Intellipaat. Okay, moving ahead with the identity verification by phone, which means you have to share your contact details. You have to share the contact details of yours. And after giving the contact details, just below that, you will be having the option of a text me. You have to just click on the text me. And as soon as you're just going to click on text me, you will be receiving a verification code to the contact details that you had shared. Okay, there will be, I think, 6-digit verification code or a 4-digit verification code you will be receiving. You have to just verify that code. After giving all the basics information, at the end, when you will scroll down the screen, at the end, you will be having the 2 terms and condition over there. Okay, so you have to just accept both the terms and condition given by the Microsoft and just you have to click on next. Is the first this is all about the first page details. Okay, this first page details. Okay, so fine. So when you are just going to click on next, you will be able to come to the second page. Okay, so let me just go ahead and erase these things. Then after, yeah, discuss about the second page. So let me just go ahead and discuss about the second page. The page where they will be asking, like Microsoft will be asking about the details of yours, which means the card details of yours, like your card name, card holder name, card number, the CVV of the card, the CVV which means the last 3 digit of the card, and the expiry month and the year of the card. Okay. Moreover, you will be having the question that, okay ma'am, which card we can use for creating the Azure portal, right? You can use the credit card, you can use the debit card, You can also use the Visa card. You can also use the MasterCard. All the 4 cards you can use: credit card, debit card, Visa card, and MasterCard. You can use these cards, but make sure you are not using the debit card of RuPay. Microsoft never gives you the permission to use the debit card of RuPay. Okay, it does not allow to create the account. You will be just going to fetch the error. Okay, one error will be coming to your page. So you have to just go ahead with the credit, debit, Visa, MasterCard. But keep in mind one thing only, that don't use the debit card of RuPay. It is not going to accept the card details. After giving all the card details, you have to click on the next. So after giving all the details of your card, you have to click on next page, and the next page will be your sign in page. Okay, where you have to they will be sharing a verification code to the contact detail that you had given, and you have to just verify that code. Also, 2 rupees will be deducted from the particular card that you are using. 2 rupees will be deducted from the account, and it is a refundable money. By the Microsoft, the account will be deducted and it is a refundable money. Within the 24 hours, you will be just getting your money back. Otherwise, hardly it takes 3 to 4 working days. Not more than that. So the 2 rupees that is just going to deduct from your account, it is a refundable money. So don't worry about the deduction of the money. Might be sometimes it happens that it deduct 83 or 87 rupees in some cases, but whatever the amount that will be deducted, it is a refundable. Okay, so after giving all the details and everything, you have to just click on sign up. After clicking on sign up, you will be coming to the next page, the left hand side. Okay, the left hand side, this will be not the same page. Okay, there will be another page where you, in the left hand side, you can see it over there, go to Azure portal. Okay, so you have to just click on go to Azure portal and you will be able to log in with your Azure portal page. Okay, so you will be able to log in with the Azure portal page. And let me show you how Azure portal looks like. This will be your Azure portal, how it is just going to look like. Let's go ahead and discuss. This is your particular Azure portal, right? And if you just going to just look on the right hand side, you can check over here whatever the mail ID that you had used for creating the Azure portal. Okay, whatever the mail ID that you had used for creating the Azure portal, it is just going to reflect over here, over the right hand side. Okay, also, what if that I want to know more about my particular Azure portal? How many days I can use this Azure free portal? Yeah, we know that I will be just coming to the part, the particular account that you will be creating, it is just going to be active for 30 days only. 30 days, you have to the account will be activated, and what you have to do after 30 days, I will be just going to let you know. Just allow me some time. That also, I'm just going to tell you that what you have to follow after 30 days. Okay. So now let's say this is my Azure portal, right? Now I want to check about my particular account, that till which date the account will be active, at which date the account is created, whether my account is active or not. So this is the option, it is coming over here, search resources, services and document. Okay, so you have to search for subscription over here. Okay, you have to search for the subscription. Just click on the subscription and you can see it over here. The subscription name will be your free trial, or else it can be my subscription. Fine. Moreover, let's go ahead and let's check the subscription ID. So the subscription ID will be different for everyone. It will be not same for everyone. It's just like a college ID that you used to give. Yeah, right. In the colleges, you are having the different IDs, right? So this will be the same for the Azure portal also, that the subscription ID will be different for everyone. Moreover, the current cost is that how much you had used, how much cost till now you had used under your Azure portal. Fine, the current cost. If right now the current cost will be not reflecting for you guys, it will just take some time. When you are just going to start it, using the Azure portal, then only it is going to reflect over here. Fine, and the status which is active. Now here you can see it over here, the status, it is showing active, which means my free trial account is active, right? Now, also one thing will be happen then, where you will be getting one option of a disabled. The status, when it shows disabled option, which means your account is not active or not created. Okay, or say you are done with the 30 days. if the all the points, all the credits that is expire within the 30 days, then you have to go ahead with the new free trial account. After 30 days, what you have to do, I will be just going to let you know. Moreover, let me just go ahead and let me show you one thing more, that this is your subscription name, it is reflecting, right? You have to click on a free trial, and here you can see in the under the overview session, you can see all the information that my free Azure credits is just going to expire in 4 days. Okay, my current billing period will be this, that I had created the account 3rd of October, my account is created. On 2nd of November, my account will be disabled. Status, it is active, and everything it is reflecting over here. Okay, under the overview session also. Now, let's go ahead and let's discuss that what you have to do after 30 days. Now, let's go ahead and let's check what you have to do after 30 days. Let me just write it over in the notepad. After 30 days, either you can just go ahead and that cost part I didn't understand. Okay, just wait, Vinod. Let me just again share the screen, this part. Vinod, till now, the current cost, which means till now I had used this much of credits. That is your current cost. I had used this much of credits. That it is reflecting over here. You are able to see the overview session, then in that case, you can see all the informations of the account. Okay. So after 30 days, what you have to do, either you can just go ahead and switch to the pay as you go account, where you have to pay for the services, which means you can use the particular same account. After the disabled status, you can just upgrade that account to the pay as you go. Okay. And also what you can do after 30 days, you can create a new free trial account. You can create a new free trial account with the new credentials. New credentials, which means that new mail ID, new contact details you have to give, and also new card details. So for creating your new free trial account after 30 days, you have to just go ahead and create a new free trial account by using a new credentials. New credentials will be your new mail ID, new contact details, and new card details. Now, one person can't have the different ID, mail ID, and the contact details. So Microsoft is not like having any type of restrictions that you have to use your credentials only. No, you can go ahead and use any of your friends, colleagues, or any other card details or contact details or the mail ID. It should be only the different one, new credentials, which means different from the earlier one, earlier details, you can say. Hi, does Intellipaat cannot help us to get an account for 3 to 6 months as they have tie up with the Microsoft. Regarding that, Parag, Microsoft is facing some difficulties. That's why they had restricted the service free for 12 months. In the very beginning of the session, I just told you one thing, that Microsoft is facing some difficulties. That is the reason that they had restricted that particular service that will be just free for your some months. That is the reason that after 30 days, you have to go ahead and create a new free trial account. So this is all you have to follow for your account creation. In Azure, you can create a subscription and give user access to quota of fund. Yeah, there you can, but there are 15,800 credits. Now, after that, the account will be automatically disabled. So there are no like giving the access to the quota to fund, whatever. Regarding moreover, the problem is every month we have to create a new free trial account. Yeah, Parag, you have to create a new free trial account every month after 30 days. Otherwise, you can switch to the pay as you go. Like you can create a how much we need to pay. It is similar as AWS, but in AWS you are having the account active for 12 months, right? But here the account will be active for 30 days only. So I had shared you the pricing calculator link for the services that you are using under the Azure portal. You can just go ahead and check, calculate the services that for how many hours you are using the particular service, like for say a virtual machine or resource group. So regarding this, the trainer will just going to explain you what is virtual machine and what are the services. But for future, you can just go ahead and just check for the pricing calculator that how much it is just going to cost you if you are using the pay as you go method.
So typically the way I do sessions is, I don't want to bore people with PowerPoint quite a bit. So what I typically do is whiteboarding along with PowerPoint. So if you believe you need, I'd want to understand the preference, right? Whiteboarding typically keeps us more engrossed, right? Instead of just skipping through slides. There's going to be quite a few hands-on labs as well. So in those cases, I just want to make sure whoever's missed today's session, we might not have a heavy hands-on today, but I'd request you folks to probably spend some time, go back to the LMS, get your free trial accounts, etc., ready, so that you have got everything set for your hands-on. Free trial account where on the Azure portal, so you can create an account for yourself. So you typically would get a 30-day or a $200 credit, whichever is earlier, right? So it should be more than enough for the kind of hands-on work that we're going to do. Will we cover the solutions architect? Well, I believe 104 is the Azure Administrator Associate. So there would be uh, all topics that we would cover would be at level 100. Solutions architect would probably mean, along with 104, there's another certification that you'd have to pick up, right? For solutions architect, Rohit. So 104 of this session primarily covers the Azure Admin Associate only. So the first module, what is AZ104? AZ104 is a certification for Azure Administrator Associate, right? So AZ104 is a course, it's a certification primarily. And these sessions are focused on helping you train up to attend and actually take the certification. So for folks who are new, it would serve as a fundamental course on Azure as well. For folks who are in the IT world, or even if you're new to the cloud, this would be your first stepping stone to understand how the cloud is. Intent is you'd be able to go through your certification or attempt the certification to validate your skills and or to understand how the cloud works. So we've got the first module. Now, first module is typically, is heavy, right? We do a lot of understanding. So one really important thing is I'd want you to focus on is to understand the basics, because whatever we talk about in the rest of the sessions will be building blocks on top of what we would be learning or what we'd be talking about today, or actually in module one, right? So the agenda is on screen. So we'd start with introduction to cloud computing. We'd look at what Azure is, what are the different services Azure provides, how do we create an account in Azure. Now, I'm assuming that has been covered earlier. We'll do a quick walkthrough of that. What are the different ways we would be accessing Azure? What are subscriptions? What are resources? What are resource groups, etc.? We'll try to understand the architecture of Azure as such. And then we have tags, which is, it's a topic that repeats later as well, but we'll cover the basics of the tags. Okay. So before we, now that we are getting started, the first question that we have, what do you understand about cloud? What is the cloud? There's no wrong answers, right? You can just tell me it's something in the sky that gives that you see, right? It's white in color. If it's dark, it rains. Even that answer is right. Cloud computing, accessing resources over the internet. So it says infrastructure as a service, virtualization of storage, computing services, and software over the internet, connecting to a server from a remote location, service providing on the internet, delivery of compute resources, central server shared across using resources like storage. I love this one, staying on rent. Absolutely. Shared pool, pay as you go. Oh, yeah, pay as you use, providing services through the internet. SaaS, PaaS, IaaS, services available on web-based resources, infrastructure and services at one place, using it or infra over the internet. So let's say before the cloud, right? So cloud is relatively new into the industry. When I say relatively new, it's about 10 odd years old, but people are still, now it's at a place where it's growing, right? So what can someone tell me what was happening? Can someone take a guess? What happened before cloud? We're saying, okay, we've got compute available on rent. Okay, even before compute, since we've got basics, we've got a couple of freshers in here, physical data centers, Sugandha, yes. Since we've got on-prem resources, yes, physical servers, physical data centers, before cloud, intranet, okay, physical resources, virtualization, data centers, awesome. All are right answers. But now let me ask this basic fundamental question. What do you think? How are you today accessing this session? What are you on? A desktop or a laptop, preferably, or maybe a phone or a tab, right? Well, it can be anything. Awesome. Yeah. Now, Apurva says internet. We'll get there in a bit, right? Now, can you tell me what are the things that these devices, I'll call them a device, right? So, what do these devices need for you to be able to listen to me and watch this session? Internet, application, display and speaker, electricity, time, of course. What are your laptops or your devices made of? The one thing that you have is CPU and memory, right? Whether it's a phone, tab, laptop, you probably buy something like an i5 16 GB RAM, right? That's how you buy your laptops. Your phones, you'd probably buy 8-core Snapdragon with, I don't know, today's world, 8 GB, 16 GB, whatnot. If you're a an Apple guy, you'd probably say an M14 or a whatever with A14 Bionic with, I don't know, 6 gigs of RAM, whatnot, right? The premise basically is you need CPU and memory, which in today's world is your compute. Okay, is this piece clear? So whatever device you're using, no matter what, phone, tab, laptop, desktop, server, anything, that'll always have a CPU and memory configuration. And that's what you typically use to buy your devices, right? You want to upgrade your phone, you definitely want the latest processor, you'd want a higher RAM. You're buying a laptop, the first thing you'd ask is this i5 16 GB or i7 32 gigs, whatnot? Okay. So is the compute piece clear? So everybody today is utilizing compute, which is your motherboard in simpler terms, right? Your motherboard has everything, but primary specs that we look at is the CPU and memory. Okay. The second thing is, what's the second thing that you look for in your phones or laptops? Storage. Someone says, I've got 256 GB of an SSD or blah, 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 whatnot, right? Compute. And what is there? Why do you need storage? Well, you need an operating system, can be Android, iOS, Windows, Linux, you name it, right? And the last thing that you need, of course, is a network, without which, well, networks come in different shapes and forms. You've got Wi-Fi, which is most commonly used now. A few people might probably be connected with a LAN cable. You name it, right? A hotspot or whatever it is. Essentially, you need network. So, what are the three important things that are the foundation for everything? Compute, storage, and networking. Okay. Now we will expand these to scale, right? We'll expand these to scale, and that is how a data center is built. Right. Software will all sit on storage, right? So we are talking about infrastructure, Parag, right? Software sits on top of your infra, right? So three important things we need to understand are compute, network, storage. No matter which cloud, no matter what application, no matter if it's big data, if it's SAP, it's anything, they need these three important things: compute, networking, and storage, right? And the way we've got our modules structured also aligns to these three fundamental building blocks: compute, network, and storage. Okay. So now when we talk about compute, so for folks who are new to the cloud or new to the industry itself, now do you understand a few definitions that came in earlier? Said which said, hey, it's compute resources available on the cloud, or we are sharing those, we are sharing storage, or we are sharing compute, etc. So now these terms shouldn't sound alien to you. What is compute? Well, it's simple, right? It's a combination of CPU and memory. What does it do? It does processing. What does it process? Depends. On your laptop, you're probably, currently running an application like Zoom, accessing the internet, attending the session. Similarly, you folks might have used n number of apps on your phone. What are they using? They're using the compute of your phone, they use the storage of your phone, and they use the network of your phone, and that's how you get a service enabled. All right. So before the cloud, right? So cloud is pretty new. So even before we dive into the cloud, now that we've got the basics of compute, network, and storage sorted, let's understand what happened, or how was the world. I mean, even before the cloud, there were websites running, right? Someone said on-prem, someone said uh, physical data centers and whatnot. So if we want to understand what was the scenario before the cloud came in, so companies invested money to be able to buy some servers. Now, what is a server? I'll again switch this back. This is again probably a new term. So we've talked about a laptop or any device that we are using to access today, right? Which has compute, networking, and storage. What is a server? Server is compute. Yes, the one that can serve file or service. But these are typically heavy duty machines. When I say heavy duty, they run 24/7. They keep providing a service, right? Physical place where services are hosted. Well, yes, definitely. Server is, for now, let's call it physical. There are virtual. We'll get into those in a bit. Excuse me. So, physical, yeah, CPU, RAM, storage. Yes. So now, let's say you built an application. Server is again simple: compute, network, storage. Your laptop can be a server. Okay. But can you run it 24/7? Will it be cool enough? Will it not hang? Will it not crash? All of those good things come into the picture. And that, servers are built for a purpose, which is to be able to run 24/7, to be able to serve things. As I believe, who was this? They serve a specific thing. Now, it can be a web server serving a web page. There can be a database server hosting a database. There can be a file server, on which there are files, etc. Right? You can also have multiple. I mean, we'll dive into all of those later, not part of this course. But servers are nothing, just compute, network, storage. They're built for a specific thing, right? So it's not an alien term. Like I mentioned, your laptop can be a server. You can start hosting your own website on your own laptop. Okay. Now, if you were to build, let's say, a Hello World website, or you built, let's say, a shopping site, or you've built your own website, and you want to host this, right? So servers cost money, so you'd probably buy one server. Host, not install. I'll call this host. Why we call it host? When you say host a website, right? Or let's say, for layman terms, I'll just say running a website. You're running a website on this server. So for example, on your own laptop, you're running a web page that many people are trying to access. What will happen over a period of time? So you buy one laptop, you're running on one laptop, right? Uh, your user, more people are liking your website, and everybody, the number of hits are coming in. Will your laptop be able to take the load of, let's say, 10 million users? So what would you do at that point? There is no cloud. Okay. We are talking about pre-cloud world, or before cloud computing was even a thing. You can add more resources. How will you add more resources? Probably buy another server or another laptop. Server, laptop. I keep using these terms interchangeably. Right? You bought another laptop. Well, clusters are a little, we'll dive into the clusters in a bit. But let's be a little more basic, Anil. Yeah, more CPUs, but can you add an additional CPU to your laptop? Possibly not. The best thing you could do is probably buy another laptop. Let's say now your traffic has increased to 20 million. You'd buy another one and another one. But then what you realize is, let's say, 30 million, each laptop, let's say, can serve up to 10 million users, right? Your traffic is increasing, and all of this costs money, right? Laptops don't come cheap. Scaling, vertical scaling, you're talking about a virtual world, Parag. We're still before cloud itself, and even before virtualization. I think I should have been more specific. Okay, right? So you keep buying more servers, you keep investing in money, right? Now your website is up, and everyone's happy. So as and when you keep buying more servers, what is the downside to this? Now you notice that, okay, your cost is going up. So what is one downside that you see in this model? Hardware cost, definitely it's going up. We said overall cost is going up. One laptop goes down, it will take time to replace it with a new one. Agreed. So maintenance cost is higher. What else? If traffic is low, you will not use that resource. So what's going to happen? Yes. If traffic decreases, now you've basically got, let's say, 2 or 3 laptops sitting idle doing nothing, right? And this is a, a huge challenge. This was a huge challenge. So what do you think? How do you think we can solve this problem? We've come to a point where, you've invested money, you've got 4 laptops, the traffic has gone down, and your laptops are lying idle. So how can we fix this? Or how do you think we can fix this? Renting laptops. So what if, what if tomorrow you need more compute? Will you kick those websites out? It's like catch 22. Instead of buying on rent, as per the traffic, you'll add more servers. But what will happen now when your traffic is reduced and your servers are lying idle? You'll be stuck buying more laptops, yeah. And none of these devices you'll be able to consume. Now, a shared model like renting kind of works, right? So how do you rent space, right, for an application? So let me clear this. We'll go back to a little bit more fundamental conversation, which is guess maximum capacity and run ES. Well, I'm not a huge fan of guessing, but so let's say you've got laptop one. Okay. Exchange laptop with a server. Okay. It doesn't matter. All we are worried about is compute, networking, and storage capacities. So let's say laptop one, the first laptop that you bought, had a 4-core processor, okay, and had about 16 gigabytes of RAM, and let's say about 512 GB hard disk. You bought laptop two, you kind of like this configuration, but probably you are afraid that, I might need more compute, so you bought a 6-core machine and with, let's say, 32 GB of memory, okay, and even more storage. The third laptop you bought, you again did a 4-core, 16 gigabytes. Since you already had 1 terabyte of storage here, you thought, well, I'll just do 256 gigs here. Now, how do you share these? Now, this is laptop one, this is laptop two, this is laptop three. Now, if you wanted to share resources, how would you do it? So let's say your application needs, minimum of 2 cores and 4 GB of memory to run. Okay, this is app one, some other or web app one, I'll call this website app, whatever. Then there's a website two that needs 4 cores and maybe 8 GB of memory. The list goes on, right? So how do you split these, right? If something needs 4 core and 8 GB, right? If I, let's say, put this website on this laptop, is there any other application I can put on this? No, because I'm consuming all those. So what's happening to my memory? The additional 8 GB is going waste. Now, let's say if I put the same 4-core 8 GB app on laptop 2, what will happen? I'll be left with 2 cores and a lot of memory, 20, 14 GB of memory. My math is a little bad. Yeah. How can I consume this? I'd have to wait for some app to come. Maybe I can put in web app 1 also on this, right? Which can be a 2 core and 4 GB. I'll still be wasting a lot of memory, right? Now, this is in the physical 24, not 14. Yeah, sorry. Yeah, like I said, my math is a little. Why is PowerPoint? Yeah, this is better. Okay, 24. Let's say, yeah, 24. But all I can do is probably put in a 2 core 4 GB here. But I'm still wasting a lot of memory on this key, on this laptop. So how can we, so to solve this problem, right? The way it was solved was through virtualization. So what does virtualization do is, let me get rid of all of these, to be able to efficiently utilize your hardware resources. Virtualization, essentially, I'll call this, for now, I'll call it virtualization software. Okay. Now there's multiple terms for this. There is, you can typically either it's called a hypervisor or you'd call it a KVM, any virtualization service, right? Let's imagine it's a virtualization software. Now, what this does is it helps you create virtual machines. What is a virtual machine? So, virtual machine is just like a physical machine, except that you can decide, I want a 2 core 4 GB virtual machine with 30 GB of storage. You can utilize the compute, you can utilize the storage, and of course, the network bandwidth is shared across all virtual machines, right? So you can create n number of virtual machines and be effectively able to utilize the 4 plus 6 plus 4 cores. How many are these? 14 cores to the maximum possible extent, and 16, about 64 GB of memory that you have, right? You can utilize this to the best, to the maximum possible capacity. So virtualization, now we can dive deep into virtualization later, but what I want you to understand is the concept of virtualization actually helped utilize the hardware resources better and to be able to consume only specific units. You could create virtual machines, and virtual machines are the building blocks of cloud. We'll talk about that in a little bit, right? So just to show you how it looks like, let me quickly. So what I have on screen is, this is hypervisor. Okay, so this is the virtualization service that is from Microsoft. That's why it's, where is it? Where's my, all right, right. So this is hypervisor. Now what is happening here is, let me show you the specs of my machine so that you understand this better. I'll clear the drawing, or I'll rather not. Give me a minute. I hope it's visible. I know it's dark, but let's look at this. So I am currently running, okay, I'll put it here. Right. So I've got 12 logical processors. I've got 6 cores. I've got 12 logical processors. Right. I've got about what, 32 gigs of memory, I guess. Yeah. 32 gigs of memory, a couple of hard disks, and I've got an Ethernet. Right. So what you see here is compute, which is CPU and memory, storage in 2 disks or 3 disks, one is removable, and the network. Right. Now, if I want to be able to, I don't, I want only to run a website which is needing maybe 2 cores and 4 GB of RAM. The way I do that is I create a virtual machine. I'll just show you the specs of a virtual machine. It's not rocket science, right? I mean, virtualization was at one point, but now it isn't. So if you look at this, all I can do, I can assign the memory that I want to give it, and I can say, go ahead, use 8 GB. I can give it the number of processors. I can go, I can start with 1 core, 2 cores, 3 cores, 4 cores, whatnot, right? And then create a virtual machine. What happens when you create a virtual machine? It replicates exactly, or it behaves exactly like a physical machine would, but what it runs on is essentially something called a hypervisor in the Windows terminology, right? Or it's the virtualization software, whatever you're installing on it, right? So this was a game changer. Virtualization was a game changer. And what happened eventually is when people were able to effectively utilize the hardware, they started building data centers. Now, you could create a number of virtual machines, right? So with this, now considering virtualization and what are all of these? Server 1, 2, and 3, these are physical devices, right? These are your laptops. This is physical, this is also a physical device, this is also a physical device. But what happened here? This is a virtual machine. Why do we call it a virtual machine? Because this is not a physical device. It still has compute, networking, and storage, but it would probably run on one of these, or one of these physical devices can run more than one virtual machine. So for example, on my machine, I've got four virtual machines. I've got an Ubuntu virtual machine, I've got a RHEL virtual machine, and I've got a Fedora Linux virtual machine, right? So a physical server or a physical device can run more than one virtual machines. The reason we call them virtual is they are not physically present. They are actually being hosted. They are guests on the host. The host in this scenario is the physical server, and the virtual machines are the guests. It's like inviting people into your house, right? So now, considering you've understood all of this, so what would be a data center? So servers are actually stored in racks. Okay. Remember, everything is a physical server. Without a physical server, there's nothing. They are slotted together in racks. And this is how it looks like, right? I just popped the first one that came in. You see all of these. I know it's too black, but each of this, let me switch the color. Okay, so all of these are racks. Okay, each device you see in here is a physical server, right? Now the server specs can be different, right? But typically in a data center, depending on the type of application they want to run, they'd have uh, different sizes of servers, right? Server 1, server 2, server 3, whatnot. Okay, Sunil says, so for hosting that more than one virtual machine on a physical machine, we need hypervisor. Can you please? So all of these servers, right? They're all stacked in. Each of this is called a rack, right? Rack 1, rack 2, rack 3, rack 4. And what happens is they build, we'll get into clusters a little later, but all of the data centers utilize virtualization, right? Most of the data centers, you'd either find, primarily, you'd probably see a lot of VMware, right? Or you would see Hyper-V, right? It totally depends, or Zen. Now, uh, Amazon data centers run on Zen. Okay, so Microsoft data centers run primarily on Hyper-V. Private data centers, like the enterprises, they typically utilize VMware or Hyper-V. It depends on each organization or whoever sold it first, right? That's the way the world is today, right? So a private data center essentially is, let's say this is for company A. This company has bought maybe 100 servers, right? Set up on four racks, 25 servers each. They've got virtualization, they've got enough capacity, right? Maybe they are at 50% capacity today, right? They have room for 50% more to grow. And in case they want to grow, same old challenge, right? If you need more servers, you buy one more rack and you keep expanding your data center. What's one challenge? Now, till now, we were talking about individual laptops, right? What's one challenge if you are going, if you are procuring hundreds of servers? What's one thing that you really be worried about? Space and cost, yes. All of that is part and parcel, right? But what's the one most important thing? Security, space, power, cooling, management. When you buy a phone or a laptop, what's one offer that you keep getting? Warranty. You're worried about warranty. If someone's buying hundreds of servers, they are more worried. They don't want maintenance cost or hardware cost to come up. You buy a car, you buy an extended warranty. Why? Peace of mind. You buy a phone, you look for extended warranty options, right? Or the manufacturer sells them to you, right? Now, for any enterprise, that the warranty on servers lasts somewhere between 3 years to 5 years, depending on the contract that you have. And every 5 years, once the warranty is over, all of this hardware, all of this hardware will need a refresh. What does it? What does a refresh mean? You just have to kill all of these, move them out, buy new ones, right? That is a big cost, a lot of cost. Apart from for cooling, you're paying money. For networking, you're paying money. Physical security, you're paying money. Real estate, you're paying money, right? Your admin staff, you're paying money. All of this will always be a constant, but a hardware refresh cost is something that the enterprises always were scared about, even are today. Whoever's running physical data centers, tech refresh, yes. I mean, most of you who are working, your laptops get replaced every 3 years, right? As soon as the warranty on them is over, your company would possibly replace them, right? So this became a huge problem, or was also a big problem. Now, what did or how did this was the primary, the hardware refresh, and of course scalability, as Parag mentioned earlier, right? Now, if all of a sudden they wanted 50 server more capacity, the only thing they could do is buy, right? So scalability was a challenge. Hardware refresh costs, maintenance costs were a challenge, and this is where the likes of AWS or Amazon started that first. What they did was they said, "Hey, folks, you don't need to worry about maintaining your data center, right? So all of these, the cooling, the network cost, the real estate cost, the admin cost, your physical security, blah blah blah. You don't need to worry about all of this. We have any cloud provider for that matter. Okay, I'll call it cloud service provider or CSP. You'll keep hearing that term more often. Amazon started that. The rest of the folks followed. But let's say the vendor, which can be AWS, it can be Azure, or today GCP. Now you've got quite a few, right? There's Oracle, there's Alibaba of all worlds, right? There's quite a few cloud providers. Now, what they did was they built a huge data center, okay, which has a few 100,000 cores. Okay, that's how much capacity. We don't really know what specs they use. Different story, right? Hundreds of thousands of memory, tons of storage, right? Quite a few terabytes or even petabytes of storage, right? And what they said is, any company that wants to come in, hey guys, come in, use as many as you want, right? As many cores as you want, as much memory as you want, as much storage as you want, and pay me only for what you use. So you want to scale? Okay, I have large number of cores. No one discloses it, but to set things in context, everybody now uses the term cloud scale. Okay. Now, it does not mean that it is unlimited. There are still limits, right? But the way these service providers extend their data center is at a very, very, very rapid uh, pace, right? So one data center, everybody gets their own, uses whatever they want to from it, right? This exactly resembles the renting strategy that we talked about a little while earlier, right? And all data centers, everything, the basis of everything is virtualization. So you've got virtual machines, people come in, you've got virtual networks, everything is virtual. Storage is still virtual. I mean, it's still physical at any given point in time, but you can get whatever amount of storage that you need, right? So became, this came to be called the cloud. It's nothing. It's end of the day, it is physical servers running in a data center in a large scale, and people renting out or paying as, utilizing as much as they want and paying for only what they use. So does that make sense? The definition of, or the way the cloud came to be. So what we'll do now is catch up on the slides as well. I know we've done quite a bit of talking. Let's go through these, see where we are. Okay. So this is the scenario which we talked about. Your application gains popularity, your database, the user database increases, company invests more money to buy the servers, people start using the application. We also talked about increase in the load might cause your servers to crash. That's additional cost or additional maintenance that we'd have to worry about. All of this is before the cloud world, right? Animations are crazy, but that's fine. Company hires a maintenance team to fix the broken server. It's an expensive option. Uh, Again, your laptop dies. What do you do? Uh, you have to spend money to get it fixed, right? You have to again have a maintenance team all the time, right? Now, imagine all of this happening in a at a larger scale, right? We're talking about a few hundreds, few tens, or if not a few hundreds of servers, right? So this was the scenario before the cloud. Again, we talked about the second con, which is if the traffic decreases with time, it poses a risk. Well, actually, a problem to the extra servers. They are just lying there, idle, doing nothing, and they keep adding to your cost, right? Your maintenance cost and whatnot. And obviously, if you were this guy, you'd be worried as well, right? So the challenges before the cloud, we'll just summarize them into four things. Scalability. So this term you'll keep on hearing quite a bit, right? So what is scalability? In case, before the cloud world, scaling out was a challenge. I wouldn't call it scaling out. I don't want to confuse you. But increasing or scaling was a challenge because you had to buy new hardware. Procurement has its own timelines, right? Availability of stock, whatnot. A high upfront cost in your capital expenditure, which is the money that you spend in buying the servers, right? There's also an increase in operational expenditure, which is the cost or the money that you spend in paying for the maintenance, right? So two important terms. One is capex. We'll we'll hear this heavily. One is opex, right? Capital expense, operational expense. So capital expense is the money that you spend to buy the servers, and OPEX is operational expense, anything which includes power, physical security, real estate, you name it. We've talked about a bunch of things, right? Including server maintenance and whatnot, right? Slow data recovery is a little tricky. It depends on what kind of hardware you had put in, but essentially, if you were in one data center and there was a crash, right? Or if your laptop's hard disk crashed, and if there was really important data to be recovered, what would you do? You'd have to spend you'd have to spend time and you'd have to spend money to see if you're able to retrieve it again with no guarantee of it being 100% accurate, right? All these, in summary, are the challenges or were the challenges before cloud. Skip the animations, right? And after cloud, what happened? We addressed all of these four problems. How is the cloud service providers or the vendors, they've built large scale data centers. Again, I wouldn't even say large, but the term that is more appropriate is cloud scale. So you can, we address scalability. There's no high upfront cost, right? You pay as you go. Your operational expenses in terms, specifically in terms of real estate or cooling or electricity or physical security, etc., are gone. You'd still have administrative costs, right? So scalability, cost, server maintenance, slow data recovery. Scalability, we've addressed large scale, cloud scale data centers. No one tells how the capacity is managed, but as far as I know, there's scaling up the data center for them kind of takes about a week, not more, and everything is custom built. You've got a container that comes in, plugs in, and you get like a few thousand cores of RAM and few thousand cores of CPU and a few thousand gigabytes of RAM available, right? That's how rapidly they can scale. It's kind of a plug and play model like Lego bricks, right? Now, cost again, we talked about this. No capital expense, so you're not buying servers. You're just paying for what you use. right? And the bigger advantage these cloud service providers have is uh, their acquisition cost is lower. So imagine you are buying, uh, let's say, two laptops, or even forget laptops, right? You go buy five five pens, you get it at some price. If you're buying 10, the cost goes down. You're buying 100, the cost even further goes down. What would you do at that point? You go and talk to the manufacturer and say, hey, I need 10,000 pens. What's going to be my landing cost, right? So at scale, you know, as the quantity of servers they procure goes higher, their investment goes lower, right? And they start, and for them, expanding a data center becomes a lot more easier, right? And in a way, those benefits are translated back to the end consumers like you and me who are consuming compute. So today, you want to let's say, run a 32 core machine with 64 or 128 gigs of RAM for half an hour to test something, right? That's something you can readily use on the cloud. You wouldn't have to worry about hunting for a server and hunting for so much memory and disk space and whatnot. So capital expense goes down. However, there's still maintenance in terms of administration, right? You'd need server admins, you'd need Azure admins and whatnot. So that cost still remains. And we'll get into how that was solved a little later as well, right? Server maintenance, again, there's no physical server, so you don't need to worry about managing them or monitoring them continuously. And in terms of data recovery, we'll understand more in the storage section once we come to that. But there are multiple redundant copies of data within a data center on any CSP, right? On Azure, also, we'll talk about specifically how Azure handles storage, right? So these four problems that existed before the cloud computing attempted to solve all of these. And that's why today you'd see every data center or every enterprise, the closer they are to the hardware refresh, the more worried they get. And that's a really good time for the cloud service providers to come and sell their product, right? So, and that's how cloud grew. And a really good time for the cloud to grow in the recent future was COVID. Most of the customers needed more capacity. People started working from home. VPN servers got offloaded. They needed more capacity. Everybody rushed to the cloud, right? So situations aside, people or enterprises are now focusing more towards trying to balance their act. A lot of folks moved to the cloud in a rush, and then they realized um, they're paying more than what they used to pay in a physical data center. So now they're trying to strike the right balance between the physical data center, the consumption of the physical data center, and the consumption of cloud resources. Okay, let's look at these slides. Scalability, cost, server maintenance, flow data recovery, done. What is cloud computing? We just talked about this. So we are delivering or cloud computing. This is all English. I'll just read through the slides. Delivery of computing services. You've got servers, storage, databases, networking, software, analytic intelligence, and more over the internet to offer faster innovation, flexible resources, and the economies of scale. Economies of scale, we just discussed about that, right? The more quantity you buy, the per unit cost comes down, right? So that's what they mean here. Now, all of these data centers, all of these virtual machines, each of these cloud service providers, the way they give you access to your resources is through a portal, right? So you log into portal.azure.com, you're able to access and see all of your virtual machines, all of your resources, blah blah blah. You go to cloud console.cloud.google.com, it's GCP. I think AWS has a similar URL, right? So they essentially give you access to your infrastructure from anywhere, right? Over the internet, as they call it. Now, the reason they're able to do that is because all of these are virtual machines. All you need is network access, and since the compute services itself are virtual, all you need is a connection. You log into the portal, you get the access that you need. Yeah, same thing. So user, you have a cloud provider, which can be anyone. In our case, what we are looking for to learn is Azure, right? Pay as you go model, like I said, they've got vast capacity of cores, they've got a lot of memory. You pay for what you use. Yeah, funny animations. Right. Now, this will be an interesting topic. When we were talking about definitions of the cloud, right, we were looking at PaaS and SaaS. Now, I keep saying that, but for everyone, IaaS. Oh, come on, pen. PaaS, SaaS. Any guesses? Service models, infrastructure. So anything AAS now in today's world, these have been kind of misused quite a bit. Everyone uses these three. This is as a service. Okay, AAS. You've got infrastructure as a service. You've got platform as a service, and you've got software as a service. Right. Now all of these are different service models. Let's use the next slide rather. Right. All of these are service models on the cloud. So how are, you know, service models are the way in which the services are delivered to you, right? That's what we mean by a service model. Okay. Now, the other models that we look at are the deployment models, right? So deployment models are very straightforward. We just talked about them. So we talked about a private cloud. What is a private cloud? Private cloud is a data center which is owned entirely by one company. It doesn't share anything anyone, it's for exclusive use for that enterprise, right? Public cloud is where there can be multiple enterprises on the same data center, right? Of course, there is segregation in multiple shapes and sizes and different forms. We'll talk about those later, right? So public cloud and private cloud, these are, pretty straightforward from a definition perspective. A hybrid cloud is where the private cloud, a customer is using a private cloud and public cloud simultaneously, and they are connected to each other. That would be a hybrid deployment model. You understand a private cloud. We just talked about that at length. A public cloud also, we've taken examples of what a public cloud is, how it looks like, cloud scale, large scale data centers. And we've got hybrid cloud, which is a mix of a public cloud and a private cloud. Now, in terms of service models, let's say you wanted to travel somewhere, right? There's typically the most common example people use on IaaS, PaaS, SaaS is a pizza restaurant, right? Let me see if I can find that. No, man, I'll just share this. Right. So this is a good example, one that I like quite a bit. Why cannot I expand on this? So, this is a very layman example, right? So this is your, on the left, made in-house. This is your traditional on-premise deployment. So what does this mean? The kitchen, understand the color coding. Blue is something that you manage. Green is something that the vendor manages. Okay. So in a private cloud scenario or in your on-prem scenario, on-prem is basically physical data centers, right? For those who are not used to that term, we'll keep using that term quite a bit. So I just want to make sure you understand what on-prem or on-premises is. Okay. So you own the kitchen, you own the gas, you own the oven, you own the pizza dough, you own the toppings, and you cook the pizza, right? This is your traditional made in-house or an on-premise deployment, right? Right from the hardware all the way till the application, maintenance and whatnot. Everything is what you own. Now, when it comes to IaaS, right, infrastructure as a service, the vendor manages the kitchen, gas, oven. Now, how does this translate to the cloud? The physical data center, the physical server itself, the network, and the storage, they are all made available to you by the vendor, which is Azure. This is your VM, right? You've got your virtual machine. You've got toppings are, Pizza Dough is your virtual machine. Your toppings are your applications that you install and you deliver the service, which is the pizza, right? So when you say infrastructure, The physical infrastructure is owned by the vendor, right? And you just manage the uh, server itself, right? The virtual machine is a very good example of a infrastructure as a service. Now, what happens in platform as a service is you don't get to manage the server at all, right? So even the pizza dough in this scenario, pizza dough is also managed by the vendor. All you get to do is choose your toppings, add your toppings, and you cook the pizza, right? This is like walk in and bake it yourself. Software as a service, on the other hand, is just like a restaurant. The kitchen, gas, oven, dough, toppings, cooking, everything is done, and all you do is sit and eat a pizza yourself, right? Now, given these layman terms, if I ask you the definition of a software as a service, emails, yes, McAfee, Dropbox, guys, everybody would have a Gmail or a live.com account, right? Gmail is a very good example of software as a service. Gmail or any other email for that matter, right? A very good example of SaaS. So, what would be a good example of a PaaS service? It is where Swiggy is SaaS, for example, right? Your food delivery apps are SaaS service. Most of them are SaaS. We don't typically get a platform on our mobile, so yeah, I'd give you that, Jay. Most of the apps. Well, you're diving into Azure once, app services, service bus, yes. So, platform as a service, there's no specific example that I can think of unless you've hosted a website or try to build a website. You'd want to run it somewhere, so you'd choose a space which gives you a runtime and whatnot. So PaaS would typically be used by developers. That's right. WordPress server, well, it's a little tricky. WordPress, unless you're hosting WordPress yourself, right? WordPress, Shopify, all of these are now primarily SaaS services, right? They get you the entire URL and you get to consume. GitHub again will be SaaS service. Anyway, I think SQL Cloud, yes, we'll talk about those as we venture in. Uh, so infrastructure as a service in the cloud world or in the IT world, what it gives you is full access to the server. So essentially, when you see something like where if you are able to log into your server, so if your virtual machine, something like this, if you're able to log in to this, using a virtual machine becomes infrastructure as a service, right? You can install anything custom, any custom software on it. You could manage it and use it as if it was your own infrastructure. That is infrastructure as a service. A very good example of infrastructure as a service in the cloud world is virtual machines. Next, platform as a service, right? So in platform as a service, the server itself is not visible to you. You don't get access to the entire server, but you get a pre-configured server in which you can run what your application. So, for example, you want to host or you've created a .NET website or you've created a PHP website, right? You don't have to worry about installing the IIS web server or any other additional software, whatnot. Everything is pre-configured and made available to you. You just deploy your code and run, right? But you cannot control or you cannot log into that server. You cannot change the or upgrade the versions of that server, right? And one advantage is maintaining the server is not your headache. It becomes the vendor's headache. Alternatively, in infrastructure as a service, since you own the server, you have full access to the server, upgrading it, patching it, access controlling it is all operational expense that is part of your responsibility. But in platform as a service, a lot of operational expense goes down, but at the cost of customization. So if your application needs something custom, which is not available in the pre-configured servers, then that's something that you cannot do. Right? Software as a service, on the other hand, is tricky. It's just like Gmail, right? You are delivering the entire software to you as a service. You can directly go, just create an account, start using it, right? You don't care about what platform it is running on. You don't care about its scalability. You don't care about the uh, uh, physical servers on which it is running, nothing. You just consume the service, you just take a subscription, start consuming it. Just like someone mentioned, subscription of Intellipaat when we talked about what is it that we need for us to move forward, right? So whatever we are doing is whatever we are consuming is SaaS. Cloud service providers like AWS, Azure, they provide IaaS, PaaS, as well as SaaS services, right? All three of them together. So there are different service models within the cloud. CSPs are a mix of IaaS, PaaS, SaaS. Yes, we can use different services and different models. Yes, perfect. Right. So that's software as a service, right? Platform as a service. Okay. So platform as a service. Let me talk about this in a much better way. Let me show you. Right. So let us say I wanted to, I wrote a website running on, .NET. Okay. Now, when I use that, if I have to run that, basically what I'd need is IIS. Do I have IIS here? Should be able to see it. IIS is the web component, right? Yeah. So you see this Internet Information Services. Now, this any .NET website or any ASP website would need this to, for you to be able to host. Now, I am in a IaaS scenario where this is my physical desktop or let's say even if this is my virtual machine, I have to go enable this Internet Information Services, hostable web core. The moment I click OK, it is going to go ahead and install everything, right? And then I will be ready to deploy or host my website on this virtual machine or a physical machine, whatever. When it comes to platform as a service, all of these settings that I'm trying to do right now, they'll all be pre-configured for me, including runtimes, any additional software that is needed. Everything will be pre-configured, and I don't have to worry about logging into the server, patching the server, or upgrading the server. All I do is I get an endpoint, I'll upload my files, and my website starts running. All right. So deployment models, we've talked about these, at length. Public cloud, as we discussed, shared access to computing services. Users share the same infrastructure. When we say infrastructure, the physical infrastructure, right? Private cloud, XaaS. No, I haven't heard about that, Navnendu, but interesting to know what that would mean. Right. So private cloud, again, pool of resources exclusively meant for the use of a single organization. Oh, everything as a service. Okay. It can be owned by an organization or can be rented from a cloud provider, but most of the organizations never rent it. A private cloud is typically an on-premise data center running on virtualization. Hybrid cloud, again, straightforward. We've talked about it. You know, public clouds or private clouds connecting to public clouds. I think we've got an example here. Bus accessible to anyone, meant for the general public. That is an example of the public cloud. So each seat is an organization, right? So the bus has 50 seats capacity or 60 seats capacity, whatnot. Car is private cloud, right? So meant for exclusive use or owned by a single person and not meant for the general public. It's a very rudimentary example, but any, I hope you folks understood what private cloud and public cloud are when we were doing all the good whiteboard stuff. Hybrid cloud is, combination of both. So basically in those scenarios, what happens is your on-premises servers, you know, they can connect or your on-premise data center is connected to the private cloud or your cloud data center. So you're able to expand into the cloud, you're able to extend your services. There's also a really good reason why some companies still want to remain on-prem. There are multiple regulations like GDPR, few of them are, healthcare data is important, the government data is important. So depending on how flexible the policies of an organization are, they may or may not choose to put everything on the cloud, and they still want to maintain some of their uh, servers or data on their private infrastructure or private cloud. So that's the reason. More often than not, any large scale enterprise would typically be following a hybrid model. Startups are, born in the cloud, so you'd probably see them only on the public cloud. Now, private cloud scenarios, very common, government organizations, healthcare, quite a lot of banking is still private cloud. Today, we'll talk about what Microsoft Azure is, right? So, as we discussed, irrespective of who the vendor is, right? Uh, Azure, we discussed about large scale data centers, which are built, shared data centers for the consumption of enterprises or anyone public, right? So, a large scale public cloud, Microsoft's version of the large scale public cloud is Azure, right? It provides, again, you've got web scale cloud services. Again, three important things that you keep hearing more and more: compute, storage, and networking. Right. So Azure is just Microsoft's version of the public cloud. A few basic facts around Azure. It was established or launched approximately, I believe, 13 years ago, 1st of Feb 2010. It's recognized by more than 90% of Fortune 500 companies. Now, we discussed about this briefly yesterday as well. The primary reason is Microsoft has got a larger footprint in the enterprise market in terms of server licenses or Active Directories and whatnot. It's cost effective, so it's free to get started. Most of you folks would have already created your your free trial accounts, right? It also, just like every other cloud provider, offers a pay-per-use model. Multi-language support. So, this is not limited to C Sharp, Node.js, Java. So there's more like Ruby on Rails and whatnot. It's an ever-changing thing. One thing we need to always understand is, whatever is built in the cloud is constantly changing. So few of the slides you might notice, or in your assignments or hands-on, right? Whatever we're doing here or the screenshots, they might be a little different on the portal when we try to access them or try to take a look at them, right? So cloud is ever changing, right? So the language support also keeps on getting added and changed, right? Now, in terms of availability of Azure, so currently there are about 54 regions around the world. That's where Microsoft has its presence. Now, what do we mean by that? As we discussed, large scale data centers are primarily set up for consumers to use, right? So when we say cloud scale data centers, we discussed today about a few or hundreds of thousands of cores and memory, right? And large scale data centers. So in each country, let's say this is country one, right? And country two. Why do we have, or why would Azure need to be in multiple countries? Primarily is because of latency, right? So you do not want to be creating a server in the US while you might be working primarily from India. Not that it would make huge difference if it is just an individual server, but in terms of hosting applications. And apart from that, the primary reason why all public clouds expand into multiple countries is also because of compliance reasons. So, for example, GDPR, part of Europe, they always want to ensure that the data does not cross geographical boundaries, right? So that's the primary reason why you see cloud or public cloud expanding into multiple regions. For now, Azure has its data centers in about 54 region around the world. Now, this is a high level image. I think most of these, this will keep getting updated. So if you look at it now, it might be different. So we've got about 140 countries and about 54 regions worldwide. And this is something that continuously keeps getting expanded. What Azure is, again, quick recap. Azure is Microsoft's flavor of the public cloud, uh, spread across almost 54 regions and about 140 countries. And it's widely recognized by almost 90% of the Fortune 500 companies. All right. So, in terms of services, right? So, when we talk about services, what do you think are the three major services any cloud should be providing? Okay. So, compute, networking, and storage are the three primary services, along with which we have databases, which are also part. Now, I personally consider databases also part of storage, right, irrespective of how they are delivered, right? So, in terms of compute, what we have on Azure. is we'll discuss about, so each of these will be a module for us. So we'll talk about Azure Compute, we'll talk about Azure Networking, Azure Storage, and Azure Databases. Right. Now, primarily, these four sections will constitute whatever is being built on Azure. Now, let's dive into what is available in terms of compute on Azure services. So the first thing is virtual machine. Again, we discussed about this briefly yesterday, right? Virtual machines are the core for compute, right? Remember, we'll as we move on, we'll talk about how things or services were built on top of virtual machines. Okay. But primarily, virtual machines are the major source of compute. Now, the followed by function app. Function app is primarily serverless, right? It's serverless from a consumer perspective, right? So you can basically set up your code, and once you set up your code, you would only be billed for the number or the execution times of how much CPU cycles you use, right? App services are again pretty common, right? So this is app services are platform as a service offerings in compute. Virtual machines are IaaS, infrastructure as a service. Serverless is also a platform as a service offering. Now, app service, as we discussed, we'll dive deep into each of these. App service, as we discussed, provides an entire environment for us to run our applications. So if you want to run a .NET application, you can choose a .NET XYZ version. You want to run a PHP application, you can choose a PHP and a specific version. You want to run anything else, let's say Node.js applications, you can choose these. We'll take a look at these in the portal, and probably hands-on will make a lot of sense, right? And essentially, once you create these runtimes, all you need to do is upload your code onto the app service, and it starts to deliver or host your application. Now, Kubernetes is another interesting topic. It's an ocean, right? Kubernetes is primarily a container orchestration platform, right? Azure's version of Kubernetes is called AKS, Azure Kubernetes Service, and this as well is a platform as a service offering. Now, we will dive in, or we'll probably briefly touch upon what Kubernetes is at a high level further down the sessions, but we'll not be focusing heavily on trying to understand Kubernetes per se, right? So four major things. Now, a compute, like I said, is ever evolving. We'll keep getting newer services. So if you look at on the portal, things might be a little different. But what primary drives Azure Compute is virtual machines, app service plans or app services, Kubernetes, and then function app in that specific order, right? So again, virtual machines, quick recap, infrastructure as a service offerings. Now we have options to launch Windows and Linux virtual machines. You can pick and choose the size, you can pick and choose the operating system versions and whatnot. App services, again, as offering from Azure, it gets you predefined environments for developers to host and manage their applications. We'll take a look at all of these. We'll do a hello world kind of a hands-on as well, right? That will help us understand these better. And then we have function app. This is very specifically to only run code or functions. So you don't even need to worry about an app service plan or a virtual machine or whatnot. Azure takes care of all of that. We just put in our code in there, and we are charged based on the number of CPU cycles it consumes. And then finally, Kubernetes. This is a container orchestration service, as we discussed, primarily used for microservices based application. So let's say you want to run a 2 plus 2, right? Or A plus B operation, right? So this will consume some amount of CPU, let's say zero point 0.3 nanoseconds or something, right? So the time that your code takes to run is based on what you will get charged on in the function app. Now the unit they have come with that is called an ACU, or an Azure Compute Unit. The definitions are available. App service and function are similar? No. App service plan and functions are different because on app service or web app, as this is called, right? Here you create an entire environment. Now in function app also, you do choose an environment, but here you are basically delivering a website or a web service. So this will run continuously. It will wait for a request, right? It's always listening. Function app, on the other hand, only is a trigger based thing. So if someone wants to, let's say, run an addition job, right? That is when you'll call the add function. It's not something that is running continuously. So both are different in terms of their execution. Both are PaaS services, but app service is specifically for web applications or APIs or anything HTTP. Real-time example for function app, you might have seen chatbots or you might have seen translates, right? For example, there's a translate service on your website, right? And you have got or you've hooked it to an API into, let's say, Google Translate's API. Now, not now, translate is not something that everyone would use. Let's say 90% of your consumers know English, right? So no one would use them. Now, in case there is a need to use, there's no point in overloading your web application with a translate service. So in that case, you might probably call a function app, right? Function app would probably need, I don't know, maybe 5 or 10 different cycles for to get your text translated. So that's one example. Function apps are also event-based apps, right? So another example can potentially be, let's say you're running an e-commerce website. So as soon as an order is confirmed, you want to send out a notification to your warehouse to get the item package. You want to raise a request to your shipping agent to come and collect the package. There will be a shipping label print that will happen, right? So different microservices can also be, uh, these kind of trigger-based events can be leveraged in a function app. So now let's move on to the networking services that we have, right? So for anything or any application or any device to function, right? The three core things that we needed, we discussed about compute just now. Second important thing is networking, right? Now, in a shared data center, so public cloud is a shared area, right? So how do we ensure that the networks are isolated, right? This is where software defined networking comes into play, right? And of those, virtual networks are the services. So software defined networking service is what Azure has. It's called virtual networks, most commonly referred to as a VNet on Azure, right? All of these are software defined network. Just like you have your virtual machines, virtual networks are also built on top of physical networks. Okay. And everyone or anyone who consumes the public cloud, they will have their own private virtual network. And that is how isolation or network level isolation is achieved by the consumers of public cloud. So these virtual networks are are foundational elements, just like compute is a foundational or virtual machine is a foundational element for a compute. Just like that, a virtual network is the foundational element for anything networking on Azure. The second important component is load balancers, right? Load balancers, as the name suggests, they are typically used to split or balance the load across your multiple compute instances. Hotspot on your mobile, it wouldn't actually be virtual, kind of a physical network only. Just because you're not seeing the wire doesn't mean it's virtual, right? So your home routers are also physical networks primarily because there is a physical device. So if you were to build, virtual networks are something that you would see when you're doing now this is my hypervisor that I showed yesterday, right? Now in here, there's a virtual switch that you'd see, virtual switch manager. So whatever I create here, these are virtual networks. So I can have a different set of IP addresses and whatnot, multiple switches. These are all virtual network switches, right? Now, the physical network on which they are sitting is my home network, right? Connected to my router, which is, which balances the DHCP and whatnot. Okay, load balancers, hotspot again is a physical network primarily because your phone is the physical device serving the network. Okay. Now load balancers, again, as the name suggests, pretty straightforward. They are there to balance the load. Now these are also virtual, right? There was a time when there were physical load balancers, right? They would look something like, a flat device with multiple ports, and they would split. There's algorithms in there. Can Primary algorithm for any load balancer is round robin. So round robin is pretty straightforward, right? Let's say you've got three devices or three people standing, and there's one ball. I'll call it a request, right? So the first time a ball comes in, it is thrown to one. Second time a new request or a new ball comes in, it's thrown to three. Third time it comes here. Fourth again goes to one. Fifth goes to two. Sixth goes to three. Like simple terms, that is round robin, right? Load balancers typically follow the round robin algorithm, right, to serve requests. Now, why would we need load balancing? As we discussed, let's say you had a web application, right, running on uh, your laptops, right, and you want to serve, you want to split the load equally between all three. So this is where there would be a load balancer that will come into picture. Load balancers, one thing we need to understand, are probably a good read for all of you folks. Multiple network layers, right? So there's a there are 7 layers in the network model, right? And load balancers typically these work on layer 4, okay, which is at the network layer, right? So any request that comes in, irrespective of what the request is, it is transformed or it is sent to whatever is the backend of this, right? So in a round robin fashion. So one, two, three, 4, 5, 6, and so on. So one thing to understand, we'll dive deep into these. Load balancers are layer 4. We'll leave it at that. When we talk about networking, we'll dive into those. Application gateways, third important networking service that's available from Azure. And what these do is they provide us with layer 7 load balancing. We'll talk about what these are, right? And what they also give is SSL offloading. So what this means primarily is, you want all traffic to be encrypted, right? Transport layer for is application layer, actually layer 4, sorry, transport. This is what you meant. Okay. It's a transport. Uh, Layer 4 is transport. It is layer 4. So it's at a transport layer, not L3 network. L3, I believe, network is the physical layer. L4 is the transport layer. Okay. So we were at application gateway. Yeah. So SSL offload typically happen on the application gateway. What this means is, your application gateway can decrypt the traffic that comes in. You can store your certificate. So any traffic on the webs, any web traffic is currently in today's world always encrypted. So if you were looking at uh, any link today, you would always find an HTTPS in front of it, right? Which means it is encrypted. Now, the decryption of the traffic is something that application gateway can handle. Apart from SSL offloading, apart from layer 7 load balancing, application gateway can also perform the duties of a web application firewall. Okay. Web application firewall, again, uh, primarily ensures this the any threats in the OS defined in the OS top 10, right, are mitigated. So let's say there are multiple patterns. So for example, I'll send out links for OS top 10 as well. A SQL injection attack, or there's a brute force attack, or there's cross-site scripting. So there can be multiple scenarios where hackers are trying to get into your websites, right? So application gateway provides a firewall, a web application firewall, which can mitigate any of the high-risk OS top 10 items. Now, DNS zones is also a service that's available on Azure. There are two different types of it. We'll talk about them later, a public DNS zone and a private DNS zone. These DNS zones help in name resolution. So we'll talk about these in detail once we dive in into the networking hands-on. We'll create a couple of DNS zones uh, and look at DNS resolution as well. Right. CDN profiles are the last ones. CDN profiles are basically CDN essentially stands for Content Delivery Network, right? Before we dive into what CDN profiles are, right, I'll walk you through the basics when we get there. But in a layman terms, imagine this being a cache for frequently used content, right? So content delivery network. So if there are images that you use or content that you use frequently, CDN is a service that helps you cache all of that content to make sure that you are not going to the database every time and trying to load, right? So this acts like a middleman. It caches the content that is used frequently, and typically these CDNs are used to improve page response times and result in faster page load times, right? We'll dive into those details, right? Any web application firewall is expected to cater to the OS top 10 vulnerabilities. Slides again, logically isolated network in the cloud. Again, these are dedicated to our own subscriptions. What we mean by that is this is, virtual networks are how we ensure networks are isolated or in the environment in the larger scale public cloud. Load balancers, again, they're typically used to distribute incoming traffic among multiple healthy virtual machines. It can be virtual machines, it can be app services, it can be anything, right? Essentially, whatever is serving in the backend. Application gateways, again, web traffic load balancing, which is at layer 7, also does web application firewall and SSL offloads. DNS, again, we'll dive into DNS, but DNS stands for domain name resolution, domain name resolution services. What we have in Azure are two types of DNS zones, public and private. We can create our own zones for name resolution within Azure. Once we are in the networking section, we'll do hands-on on all of these, and that's going to help us understand it better. CDN profile, again, as I mentioned, the CDN solution is something that's primarily used to cache your frequently consumed images or frequently consumed content in different regions, and it assists you to load your pages faster. Storage services. So from a storage perspective, we have blob storage, file storage, table storage, queue storage, data lake, and data box. So while the services look huge, one thing we have to understand is they are all backed up by a storage account in Azure. Blob storage, you can CDN content delivery network was there even before the cloud, right? So this was more of a technology, just like Redis cache or just like any other cache. So CDN before the cloud, Akamai was primarily the leader. Even now, Akamai leads in CDN. So CDN services were there before the cloud also. So blob storage, file storage, and table storage, they are all and queue, right? The first four are typically part of a storage account in Azure. A blob storage is basically used for us to store any kind of binary data or a large amount of structured or unstructured data. So anything on any file or any content or anything, binary large object is how the name came to be, right? Blob, binary large objects. So any binary object, be it a file, a movie, an image, or whatever, can be stored in blob storage. Next one, file storage is very straightforward. So file storage is basically for shared file servers, which typically consume a server message block or an SMB protocol. So this is very specifically a Windows-based solution. Now, I believe Azure Files also is supporting NFS for Linux. So Azure Files primarily for binary object can also be stored in file storage. Yes, it can be, but the way you access it will differ. So file storage, you'd have to access it using backslash backslash. You'd be using a different protocol. If you are using blob storage, you would be able to access it using HTTPS. So there is a difference between how you access or how you get to your files. And of course, file storage is typically more expensive compared to a blob. All right. Next one, stable storage. Again, table storage in Azure is not heavily being used today, but this was Microsoft's version of a NoSQL database, right, for to store unstructured data, large amount of structured data and non-relational data. Microsoft's very initial version of a NoSQL database. Blob and table, yeah, heavily. So table is primarily is used to store structured data and non-relational data. So it's more of a NoSQL database itself. In tables, you cannot store binary objects. You cannot put in an image in there, or you cannot put in a video in there, or you cannot put in any. It's just like your uh, text content or data content that can be put in to the table. You can have a JSON file, or you can have something of that sort, right? Any NoSQL content. You can choose the data types. So the question you're asking is more like, for example, my server file share versus can I uh, put something else in my SQL data types module. Okay. For now, this is just going through or getting an understanding of what are the services that are available. Okay. Queue storage, again, this is to store large number of messages. Uh, these, use cases of these are a little tricky. We'll talk through those, right? And these messages or queue storage can typically be accessed anywhere as long as it's authenticated using an HTTP or HTTPS call, right? We'll walk through queue storage. I believe there is a hands-on on this as well, which we can, when we do that, we'll understand. But from a use case perspective, we can walk through those examples when we get to that point. Data lake storage, again, this is something which is, large scale or hyperscale, primarily used for big data analytics workloads. It can capture data of any size, any type, and has high speed ingestion in a single place. So you can consider data lake storage as more of a warehousing. Uh, it can take in any type of data. So it can be relational, non-relational, SQL, NoSQL, anything. So data lake storage and then a data box. And this is this solution is kind of very unique to Azure in terms of saying, how do you want to move your data? So if you're migrating large amounts of data to Azure, there are physical devices you can use to do that. Or if you want to get back your data from Azure, you can still send it using physical devices. So to move data to and from Azure, Data Box service, or these are offline devices which are available. And where typically you believe transferring, let's say, petabytes of data over the network is not a cleaner option. Three areas that we have discussed so far: compute, networking, and storage, and what are the services that are available there. The last section is around database. So again, database is still part of storage as far as I look at it, but in terms of how databases are delivered, in the backend, they of course use storage as well as compute, right? Now, what we have is from a database perspective, we have Azure SQL or an SQL database, the first image, right? This is nothing but a SQL server, but it's on the cloud. So Azure SQL is more of a PaaS version of the SQL database provided to us by Azure. So you don't manage a database server here. All you get is access to a database server, and you can go ahead and create as many DBs as you want in here, right? So this can scale. You can extend it. You can access it from anywhere. So basically, Azure SQL is a SQL database, but a PaaS offering that is provided. You can migrate that using, you've got multiple tools to do that. I think SQL database itself, you can use to, I think there is a migrate tool also available. What is the point of public cloud when you already are using virtual machines in the private cloud, right? So one advantage of using a PaaS database is that, the fundamental difference between IaaS and PaaS, what is it? Here, you are managing the infrastructure. Here, you don't. There's no infrastructure management. So if I want to scale, I don't need to worry about adding an additional database. I don't need to worry about high availability, whatnot. If I use PaaS, all I'll worry about is my database. and nothing else. The rest of the OS management and everything is left to is Microsoft's headache, not mine. Next, Cosmos DB. Cosmos DB is again large scale multi-region read-write database. So this is Microsoft's crown jewel for your NoSQL DB. Right? Typically, NoSQL leaders, again, this is also built on MongoDB. MongoDB is kind of the leader in that space. And Microsoft's interpretation or version of the large scale NoSQL database is Cosmos DB. Database is not part of infra. Okay, see, infrastructure is different. The services that you build on top of infrastructure are web servers, database, etc., etc. So you're talking about two different layers. Database is not part of an infra because database is a workload. What is the underlying infrastructure? It's a server. Yeah, see, infrastructure is what is infra in our terms? Infrastructure is compute or a physical device, right? What you run on top of your infrastructure is the workload. So on your VM, now I'm running PowerPoint, that is my workload, right? Uh, and it is running on my infrastructure, which is my desktop or laptop or whatever. So Cosmos DB, again, as I mentioned, Microsoft's version of a NoSQL database built on top of MongoDB. Data Factory, again, if anyone here is from the data side, you'd understand or you'd know ETL jobs, right? ETL is primarily extract, transform, and load, right? So Data Factory is a service available in Azure, which can help us move data from one place to the other, basically perform an ETL job. So it can extract the data, it can transform the data and load it into a different place. And there are pipelines that you can build here, right? So what these do is, let's say you are moving log files from your virtual machines onto a specific storage. And while you're moving the log files, let's say there is some confidential data that you want to remove in these log files. So this is where an ETL, this is a typical example of an ETL job, right? So you can extract the log files, transform them, redact any unnecessary things, and then load it into anywhere. You can load it into an Oracle DB, or you can change the schema, transform it, and then push it into another database. You can also use Data Factory to move content from from A to B. Now, A and B can be anything. A and B can be a storage account, it can be a SQL database, it can be a NoSQL database. If this is one source and let's say destination, right? So the definition of what are there in the source and destination, we'll talk about those when we get to the uh, storage module. However, one thing to understand, our hands-ons will not probably be as complex as moving things from a SQL database to anything else, but we can go through what are the available options when we do a hands-on on Data Factory. Business intelligence is different. Business intelligence is more about analytics uh, than what Data Factory does. Data Factory is primarily it helps you. This is a service that helps you build your ETL pipelines or data movement pipelines. Right? Intelligence is something that is built on top of your warehousing, depending on how much data you have, how are you cleaning up that data. Now, cleaning that data, organizing that data is something Data Factory can do for you. Now, typically, you can, if you want to run analytics or business intelligence on any of such things, you would probably prefer consuming uh, data lake storage on which you can run your machine learning models, or you can start building business intelligence on top of. Again, we just talked about data lake analytics. So again, scalable data storage, primarily for analytics and big data analytics. Now you'd probably derive business intelligence out of these. All right. So we've looked at the four different components or services that are available. We started off with compute. We have virtual machines, function app, um, Kubernetes service, and app services. In networking, we've looked at or we've talked about the available services, virtual networks, load balancers, application gateways. Storage, we've talked about files, blobs, queues, data lake storage, etc. Again, databases, they're still backed by storage. So we have Azure SQL, Cosmos DB. Data Factory and Data Lake Analytics, right? So each of these modules, right? Again, these are only basics. We are not deep diving into each one of those. Each one of those is an ocean in themselves. But from this course perspective, we are limited to understanding the fundamentals of what these services are and how to bring those up, right? And probably talk about use cases at a larger scale, how these services would be consumed. So Data Factory, these services are common for both IaaS and PaaS. Well, these are all PaaS services, right? So SQL database in here, this is a PaaS service. Data Lake Analytics is a service. It's again, you can consider this as a PaaS service primarily because there's no compute that you're building on top of it. Data Factory is also a PaaS service. Cosmos DB, on the other hand, this is also a PaaS. You can consider this as a PaaS service primarily also because you're not managing any server. Now, if it was IaaS, you would be building a server, you'd be installing Cosmos DB on top of it, and then that's how you'd be working. We'll move on. So the next area that we have, creating an account. So let me ask this question. Is there anyone here who does not or who has not created an Azure account so far? Let's see if we are able to get this done. Right. I already have one, so that's the challenge. Let me see if I can create another one. Follow me on screen. Okay. Go to portal.azure.com. Okay. So if it says you don't have one, okay, no account, let's go ahead, create one. Okay. So you'd see something like this. You don't have an account, then click on next, create a password, choose your date of birth. So once you've chosen your date of birth, it's going to ask you to verify your email. We'll probably send you an email with a code. Go ahead, check that, enter the code in here. Like this is pretty straightforward, creating an account. So I'm just trying to get into my account, get the details. So bear with me. Okay, so I have the code, put in the code. If it asks you to solve a puzzle, solve it. I say use arrows to rotate the animal to face the direction of the hand. Wow, never seen this. Okay. And once you're done, you should get a home page like this. The next thing you'd want to do is probably type in subscriptions in the search bar, right? Now you wouldn't see anything here, just kind of expected. It's okay. Click on add. And what you can do is use the start free option. Okay. So once you click on the start free option, it is going to ask you for some details, right? The first name, last name, email address, phone number. PAN is optional. You're not using this anyway for it's only a free trial account. So just fill in everything and it will ask you for a payment method, at which point do not worry. You can put in a payment method, use your debit, credit card, whatever, right? It's not going to charge you, at $200 or 30 days, your subscription will pause before it gets, before you get charged, right? So just make sure that, anyway, we'll be financially prudent on the type of resources we are spinning up, right? So once you do this step, you will see a subscription in here. right? And it will be called free trial. That is what we would need for us to get started. All right. So let's move on. We'll talk about the different ways in which we can access Azure, right? So the first one we've already seen is the Azure portal. So that's one uh, portal is or the web using the browser. That's one way to access Azure. The second one is Azure CLI. CLI stands for Command Line Interface. Azure CLI is platform independent and is cross-platform. So if you're on Linux, Mac, or even Windows, it wouldn't matter. You can get Azure CLI, and using the command line, you can access Azure resources. The last option, or I would say last option, but the last method to access Azure is again Windows PowerShell. This is very specifically for Windows-based machines. One thing that I've noticed over the years is more often than not, the PowerShell commandlet get more functionality sooner, followed by Azure CLI. I think now Azure CLI is also catching up in terms of that. But three possible ways to access, right? Portal, we've already seen, portal.azure.com. So web-based, unified console, you can create or access, you can create any resources, delete, you can manage your entire uh, pri- public data center or cloud data center on Azure using portal.azure.com. All you need to do is sign in with your account and you should be good. Now, PowerShell or Azure CLI are two different options. And for ease of use, there is a cloud shell that is available on the portal. I'll show you that quickly also, which we can use to authenticate to Azure and then do whatever operations we want to do using the command line. Okay. So first hands-on, we are at the first hands-on. What we'll do in this hands-on is set up PowerShell, try to access subscription. The CLI is cross-platform, so if you're on Linux machine or a Mac or whatever, you can still use Azure CLI. Any scripts that you write using Azure CLI can be run across on any platform. As against PowerShell, I know they're working on PowerShell core for Linux and Mac, but it's not stable, right? So CLI is typically preferred. Again, if you are using, let's say, you've written a custom script to do something on Azure, and you are probably running a Jenkins pipeline or some other pipeline. More often than not, all pipeline runners are Linux. So using Azure CLI kind of helps there. There are quite a few advantages to Azure CLI compared to PowerShell. So now let's get onto our portal. So please fire up your portals, get to portal.azure.com. Right, once you log in, you might not see the dashboard like I am, so don't worry if you're not. As long as you're on portal.azure.com and you are in your subscription, you should be fine. What I want you to do is right beside the search bar, you would find a shell icon. This is Cloud Shell. Please click on that. Once you've clicked on that, it should show you your subscription. If you got more than one, you'll see them. If you only got one, click on Create Storage. So the Cloud Shell needs a storage account in the backend. So there's nothing that you'd have to worry about. Just go ahead, click on Create Storage. Anything is fine. If you want PowerShell, click on PowerShell. If you choose Bash, we'll use AZCLI command. So either way, it's fine. We'll start with PowerShell first. So choose PowerShell first. Yes, there is a way to switch. That's the top. There's a drop down on the top left corner. Switch it to PowerShell. We just talked about the difference between PowerShell and Bash. Bash is primarily where you'd use AZCLI. You can use AZCLI on PowerShell as well. Bash is for people who are comfortable with Linux. Azure CLI is for someone who's more comfortable with command line or batch programming on Windows. The first command we'll type in is get hyphen AZ subscription. So there is IntelliSense built into this. So the moment you type get hyphen AZ, You probably see the entire command. So just type in get AZ subscription. Again, these are very, very, very basic commands. This is not rocket science. Okay, just type in this command and it should list the subscriptions that you already have. Okay. Same thing you can do on AZ also. I'll show you how different or how you can use Azure CLI on PowerShell as well as Bash, right? So the command for AZ CLI would be AZ space, I think AZ account space show. Yeah, I'll give you this command as well. Okay. So the first one that we ran, okay. So this commandlet is PowerShell get AZ subscription. Okay, this is very native or this is purely PowerShell, nothing else. This is not going to work on AZ CLI. Now we talked about AZ CLI being cross-platform, right? So AZ CLI, the command that you install is primarily AZ, and then you've got your the rest of the parameters that we pass in, right? So AZ space account space show is the command that I've put in the chat window. And that's going to get you this information, right? What account you're in, what is your tenant ID, what's your subscription ID, etc., etc. The same thing comes in here as well, right? Most of the information comes in get AZ subscription as well. Multiple ways to retrieve the same data. Now, someone who's asked what's the advantage of AZ CLI, right? So if I now this command, same command, instead of running in PowerShell, I'm going to switch to Bash. Okay. So on the top left corner, click on the drop down, switch to Bash. And once you're ready, it's the same command that you'd paste in AZ account show, and you'll get the same result. The difference is, advantage rather, is using AZ CLI irrespective of the platform, whether it is Windows, whether it is PowerShell, whether it is Windows command line, whether it is Linux or Mac, you will still be able to use the same scripts that you have written or the same commands that you have written. Okay. So that will be the the second and third way to access Azure, right? So the first thing we've already seen is the Azure portal that's right here, right? You got the Azure portal. You can look at all your resources in here. If you click on this hamburger menu on the top left corner, you'll see what all resources you can create, right? Subscriptions, resource groups, whatnot, right? You can manage everything. So this is one way to access Azure. The second and third ways, we've already just taken a quick look, right? Cloud Shell. Now you can either use Cloud Shell or you can use the command line on Windows or Mac or Linux, depending on whatever your thing is. Now, let's see if I'm logged in. So this is my machine. This will not have intelligence. What did I miss? Hopefully I'm logged in here. Let's check. Yeah, unable to retrieve token. Okay. Yes, local PC, PowerShell. Just want to show you folks the difference. Okay. I'll figure this out a little later, but I think my AZ should be logged in. Let me switch quickly. So on your local machines also, the only one additional command that you'd have to run If you are doing PowerShell, is login hyphen AZ account. And if it is Azure CLI, you can just type in AZ login. Anyway, I'll figure this out later. Don't want to waste time on this. All right, moving on. So next important topic to understand are subscription and resource groups. So one thing we've done so far is everybody has created a resource, a subscription, right? Azure free trial or what have you, right? One thing we need to understand is to use Azure, the first thing, unauthorized. I am hoping you're not using your work account, Apurva. If you're using a personal email, it should show up, cost should show up. Since you're on free trial and you haven't created anything, so I wouldn't worry much about costs right now. When we created this, what was the first thing that we did? We created a Microsoft account, right? Using any email address, right? Your Gmail ID, whatever. The next thing that we did was we created a subscription. So what happens when you create an account is you are onboarded or your account is created on Azure Active Directory. We'll talk about this later, right? And then you create a subscription. You can create n number of subscriptions using your same account. Okay. Your billing is tied to your Microsoft account that you have created using some Gmail, email, whatever, what have you, right? So your billing is always tied to your Microsoft account, under which you can create a number of subscriptions. Under each subscription, you can create a number of resource groups. Okay. Resource groups are basically a logical container to group your resources, as the name suggests, right? Under a resource group, you can create resources. And what are resources? You want to create a virtual network, a virtual machine, you want to create a storage account, anything. You always need a resource group to create a resource, right? So the first thing you need to understand is your Microsoft account, followed by the subscription, followed by the resource group, followed by the resource. Okay. So subscriptions help you. Now you would get billed per subscription. Okay. Billing happens per subscription. Within a subscription, you create resource groups. Under resource groups, you can create resources. Okay. A simple way, a pictorial way to understand this. The reason I said not so good analogy is primarily because a file can be there without a folder as well, right? But that's not the case with Azure. Any resource needs to be in its own resource group or in a resource group, not in its own resource group, but in a resource group. Okay. So end users, we create our accounts on the Azure portal, we create a subscription, and all of you folks probably would have the Azure free trial subscription. And in that, you can use all of these resources. You can use containers, compute, database storage, networking, integration, analytics, whatnot. Right. And for you to be able to create any resource, what we create is a resource group. Okay. But it's important to understand the hierarchy. So the first thing we've done is create an Azure account, right? We created an Azure account and we can create Azure account is where our billing is tied to right here. So we create an Azure account, we add a payment method to the Azure account, and then you can create n number of subscriptions. Even in free trial, you can create more than one subscription. That's absolutely fine. Okay. But again, it will not allow you to create another free trial subscription. So the second subscription might be pay as you go or something. Okay. You create multiple subscriptions. Remember, subscriptions are the billing entity. You're billed by subscription. Your invoices are generated by subscription. And also there are limits to how much you can consume within a subscription. So something like 10,000 cores. If you go beyond 10,000 cores, it will ask you to create a new subscription. Right? I can send you a couple of links on the subscription limits as well. You can just look that up. Just go Google, Bing, type in Azure subscription limits and quotas, and you'll be able to see them. Now you can have multiple subscriptions. That helps you in terms of your billing as well. Let's say in a large scale enterprise, there is a HR, finance, marketing team, whatnot. They can have their own subscription so that it is easier for, let's say, the IT admins to cross charge. Okay. Resource group, as I mentioned again, it is a collection of resources. One thing to understand is subscription is the billing entity. Okay, this is more administration than anything else, right? So on the Azure portal, if you see on your Azure account, so you're logged in with your Azure account, you search for subscriptions. So there'll be multiple. I have multiple subscriptions, right? Depending on what you can see, right? Now, under subscription is where you can have resource groups. So for me, these are my invoices per subscription. If you have multiple, so subscription is an entity, right? Is a billing entity. So in this scenario, you see I have two of them, right? So this, and unless there is a subscription, you can't go ahead and create any resource because your billing would happen at a subscription level. So for example, probably a better example of all of this is how many of you use Netflix or Prime Video or Hotstar or whatever? You buy a subscription, right? Under which you can create multiple profiles. Perfect. So that example serves best. So the first thing you need to do is buy a subscription, which is this here, under which resource groups are profiles. Okay. And under each profile, the content that you can watch or save or do is different. Correct? Just like that, without a subscription and without a profile, can you watch a movie on Netflix? Just like that, you cannot create a resource on Azure without a subscription and without a resource group. Or does that clear the definitions of what a subscription and resource group is? Okay, awesome. So now that we clear that out, this is straightforward. Resource groups, there's multiple strategies on how you can create a resource group, how many resource groups you want, how will you divide them, right? It can either be based on the workload or based on the line of business or based on the application tier. There is no right or wrong way on resource group strategy. It all depends on how the organization is looking at it.
Just a quick info, guys. Intellipaat offers Microsoft Azure course training and certification. Through this course, you will be able to prepare for AZ-104 Microsoft Azure Administrator exam and much more from the top industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of Microsoft Azure Cloud.
Once you're on Azure, on the portal, please look for the Cloud Shell. The quickest way to access that is right to access Azure is this, right? So what we're seeing on the screen is the Azure portal itself. You can explore all resources that you can create on the left side. The two other ways to access are using Azure CLI and PowerShell. The way we'll do that is you can see the Cloud Shell button right beside the search bar. Please click on that. It's going to take a while. If you are doing it for the first time, it's going to provision a storage account for you. So once you click on that, it's going to take a while and you'd get your terminal. you'd have two different options on your terminal. One is Bash, the other is PowerShell. Right? PowerShell is for folks who are comfortable with the PowerShell commandlets. Right? You can of course use AZCLI. That's a platform independent command. Uh, Platform independent command available across Linux, Mac, Windows, or even Bash, right? So quick way to access. So in Bash, what we do is run few basic commands. So if you are on the Bash screen, it's absolutely fine. What you can do is just type in AZ. I'll give you this command in the chat window as well. AZ account show, right? This is a very basic command for you to access Azure. How to go to Bash? Well, you can right beside the search bar, you have the Cloud Shell icon right here. So once you have your subscription ready, once you log into the portal, you can just click on Cloud Shell. If you are doing it for the first time, it'll ask you to create a storage account. You can just click on create. So basically, whatever you do on Shell needs some kind of storage in the backend, and that's why it provisions a storage account for you. So the command, I'll just give it to everyone, right? So AZ account show, you probably see the details of your own subscription, right? If you want to use PowerShell, you can just on the top left side corner switch from Bash to PowerShell. It would ask you to confirm switch. Once you do that, what you would see is a PowerShell terminal. So Cloud Shell, we looked at Bash, right? Now we are looking at PowerShell. Once you switch, you probably see a blue colored screen, typical of what PowerShell is, right? The command that we would probably run here is az. Let's see, we'll do a get hyphen az subscription. So it will already show you the possible commands. That's IntelliSense. Yeah, they can use get az subscription, and that's going to show you the subscriptions that you already have. So if you're not eligible for a free account, Wasi, you might have to use a pay-as-you-go account, right? If you've already consumed it. So you might have to create a pay-as-you-go account, but remember, you'll be charged for whatever resources you're building. All right. So that's that's the way you'd use Cloud Shell in here. So again, different ways. The ones that we're talking about, Azure Portal, which is the web interface, portal.azure.com, right? Again, PowerShell, we've talked about Azure Portal. Portal is straightforward. You just go to portal.azure.com. You see your dashboard. You can do a lot of interesting things. You can create resources, destroy resources, play around. Azure PowerShell, again, uh, is task-based command line. This is built on the .NET framework, but you can do a lot of things from PowerShell command line as well, right? Setting up Azure PowerShell, again, I think we've just done this quickly, right? So folks who have not done it, you can go ahead and do this again. You've got the use Cloud Shell on the top right, run the couple of commands that we have. It's very straightforward. So during the rest of the demos, right, or hands-ons rather, we've got a lot of things which you would be doing through the portal, right? But in case anyone's interested, you could probably leverage Azure CLI commands or PowerShell commands as well if you're comfortable with them, or even Terraform templates, right? It's up to you. But considering we've got a diverse audience, we'd primarily be focusing, who are new to Azure, we'd probably want to focus primarily on the portal, because once you know what you're doing on the portal, it becomes easier for you to put your AZCLI or PowerShell commands together. So Somali, after creating the Azure account, you wouldn't see the Bash or Power. Once you log in to portal.azure.com, right beside the search bar, there's a Cloud Shell button. Please click on that and you'd be able to see the shell. So the next topic that we have is around the subscriptions and resource groups, right? So I think when you've created your account, the first thing that you would have created is a Microsoft account. And once you create your account, right, you'd be able to log into the portal. What you have to understand is the structure in which Azure works, right? So apart from your Azure account that you create, which is the one that where you have your billing information tied, you would The three ways we've discussed: you can access using the Azure portal, you can access using the Azure CLI, and you can access using PowerShell. What you access, whatever commands we ran, the first information that it's going to show you is your subscription, right? If you see here, it'll show you a subscription ID. Right? This ID is essentially your subscription ID, right? And a subscription name. So for most of you folks, if you are running a free trial, you would probably see free trial in the name of the subscription. If people are using pay as you go, you probably see pay as you go in your subscription name. Now, subscription name is something that is editable, so you can go ahead and change that as well, right? But one thing to understand in terms of the hierarchy of how things are set up on Azure. So you have your Azure account. Your Azure account will be with your email address, whatever you've configured. Your Azure account will have a billing information. In your Azure account, the first thing that you will create to access any Azure resource is a subscription. The name of the subscription, like I said, it can be free trial in your case, or it can be pay as you go, or it can be anything, right? You can change it as well, right? But you will have a subscription name and you will have a GUID, right? Which will be a large, unique identifier. That will be your subscription ID. Any resource that you want to create within Azure, you would need a subscription, right? Subscription is your billing entity as well. So you get billed, it's a billing unit. You get billed by each subscription or for each subscription. So within your Azure account, you can have multiple subscriptions that you can create. You can just give any organization, it doesn't matter, Sandhya, when you're creating a subscription. Sayed has the question. Along with the portal, could you please show us how to do the same using Azure CLI? Well, I can't, Sayed, because we are pressed on time. We only have 3 hours in each session. So I can't switch between the portal. I'd have to stick to one specific way of doing things, right? Because if you run into AZCLI issues, then we can't be troubleshooting. So from a hierarchy perspective, one thing I'll just repeat: you get an Azure account. Again, what you're creating is an Azure account, but for enterprises, it's called an enterprise agreement, or there will be an EA agreement, right? So under the EA agreement, you will have subscriptions, right? Since you are an individual user, you're playing around, so that's why you're seeing an Azure account to which your billing is tied. But for enterprises, they'll have an EA or an enterprise agreement under which there's going to be billing, right? And under enterprise agreements, you'll have subscriptions, right? You can have multiple subscriptions as long as they are tied to a billing ID. Without a subscription, you cannot do anything on Azure. So once you get your subscription, at least one subscription that you need to have, under which, once you have your subscriptions, you can consume any of these resources: analytics, containers, compute. Again, the list is endless, but three primary services that you can consume: compute, network, storage. We'll keep talking about these till kingdom come. Even our modules will only talk about these, right? So you can create all of these resources. Now, one thing to understand, apart from subscriptions, right? We also have something called resource groups in Azure, right? So subscriptions, as I mentioned, they are your billing entities. Subscriptions have limits and quotas as well, right? So if people have questions as to why would I need more than one subscription, the first primary reason is in case you want billing segregation across your multiple business units within your organization, you can have multiple subscriptions, or you can also have multiple subscriptions for environments, right? So you can have one for QA, you can one subscription for pre-prod, one subscription for prod, right? Even by environment, by business unit. There is no right or wrong way. It totally depends on the way the organization is structured and the way they want to handle it. Now, within a subscription, you want to consume any resource on Azure. Apart from a subscription, what we need is also resource groups, right? So we'll get there in a bit. Again, as I mentioned, as an end user, you'll have an Azure account, which in an enterprise scenario is an enterprise agreement or EA, right? So you can't go to a company and say, do you have an Azure account? They typically have an enterprise agreement, right? Under which you can have multiple subscriptions that you can create. And that's how you start again, how many subscriptions you create totally depends on how many, how you want your hierarchy to look like, right? Now, within each subscription, one thing to understand is if you want to consume or create any resource on Azure, the first thing that we need is apart from a subscription, is a resource group, right? Resource groups are logical containers to put your applications together. Now, again, just like subscriptions, there is no fixed way in putting in your resource groups together, right? So someone can, so once you create your subscription, you create, let's say, you have to create a resource group, and within the resource group, you can create your virtual machine, for example, right? So this hierarchy is not something we can change. How do you plan your resource groups? Again, it's, a different ball game altogether. Totally depends on a structure that an organization wants to follow. One important thing to understand is from a deployment perspective, resource groups help quite a bit, right? So the usual structure typically, one example is based on the number of tiers of the application. So let us say we have a two-tier application which has a web layer and a database layer. You can create a resource group for web servers, right? A web resource group, and you can create a DB resource group. Right. In your web resource group, you can have your web servers built or your web components. In your DB resource group, you can have your DB components. One advantage with resource groups is that you can have access provided at a resource group level. If someone wants to access Azure, or you have, let's say, web server admins, you can give web server admins access only to this resource group. What this means is they can create or delete resources within this resource group only. DB admins can probably be given access to the DB resource group. So they can probably restart a database server and do whatnot. So resource groups, us, apart from giving us the ability to organize our resources, you can also give role based out. You can also use them for access control. Now we have topics around role-based access control and identity and access management. So we'll dive deep around those topics there. But resource groups also help us give access at a granular level to a specific component and help us organize. So tomorrow, let's say you want to rebuild the entire web component, you can just delete this resource group and rebuild, right? So one thing in Azure we need to understand is Azure is totally reliant on resource group deployment model, right? So any deployment in Azure is tied to a resource group. So the structure in which a resource group can be, there's no right or wrong answer. Totally depends on how we want to put things together. Moving on. Now we'll talk about the architecture of Azure itself, right? So first thing we need to understand is anything on Azure. How are we accessing Azure? How are, what was the first way to access Azure? Portal. So what do we see is happening on the portal? What are all of these? You know, you come in, you see a lot of things here. You click on resources, so you'll find resource groups. That's fine. There's virtual machines, icons, links, correct? Links. What are all these links doing? When you click on a link, what is happening in the backend, right? Any link for that matter. I click on a link. What happens? It opens another link. Or if you're opening Gmail, you type in gmail.com, it asks you for a username, password. You type in an email, click send. What are all of these? How are all of these happening? Yeah, they're moving from one page to another, but runs a script, gives an output, yes, but are all scripts? Not necessarily. It's a request to server, yes. What is powering all of these in the backend? DNS, probably at a URL level, yes. Can we go dig a little deeper? API, yep, API. What is an API? Application Programming Interface. What does this do? Returns the predefined values exposed by the applications, to and fro data, expose functionality, communication from one app to the other. Absolutely. Right. So most of our modern day applications, modern day web applications are built on API calls, right? And Azure also has REST APIs. Everything on Azure is an API call. Everything. Whether you want to create a VM, you want to deploy, you want to delete a VM, you want to modify something, anything, everything is an API call today, right? Whether it is Azure, whether it is AWS, whether it is Gmail, whether it is whatnot, you want to send an email, it's an API, right? One thing to understand is again, every just like that, Azure has something called Azure Resource Manager. Now, this Azure Resource Manager is the name of the API. Okay, this is also a REST API. Multiple. This is an API that is provided in case you want to dig in deeper more. If there are developers here, you can look at Azure REST API methods. Here's the reference documentation. I'll give you this. Basically, anything, everything on Azure is a REST API call, right? So if I show you here, let's say login to Azure, right? Authorization. So for those who are devs here, you would probably see, you have Swagger specs for everything. You can go explore them. Everything is straightforward. Everything is an API call. What is the API call? It does something like this: get, get and put post as well, right? So there is this management.azure.com, blah blah blah, how the structure looks like. But for others, as simple as that, all of these APIs, all of these services that you see are Azure services. Okay, on the left that I'm showing you. Okay. All of these are Azure REST APIs, cognitive services, data catalog, DNS, the HD Insight on Azure, everything. Whatever we do on the portal, right now, that API, the name of that API is basically your Azure Resource Manager, right? This is the mother of everything on Azure. Whatever you do on the portal, a button click or a command that you're running, the AZ command that we ran, AZ account show, the PowerShell command that we ran, eventually all of these are going to go ahead and call the Azure Resource Manager APIs only. No matter what you do, whether you run Terraform, whether you run Bicep, which is probably very relatively new infrastructure, you run an ARM template or you deploy an ARM template, right? All of these are automations or languages for automation or infrastructure as code things, right? These three are primarily infrastructure as code. You run AZCLI, you run PowerShell, whatever you run, eventually it is going to be an API call. And that API is the Azure Resource Manager. Okay. Again, this is not just Azure. This is how typically all other cloud, uh, anything that's built on HTTPS typically is an API call, or HTTP or HTTPS is an API call, right? The way the Azure Resource Manager is the basic or is the foundation for everything on Azure. Now, SDKs are built on top of these, right? Let me go to that image rather than me trying to draw something ugly, right? The Azure Resource Manager is everything, is uh, the API itself. You have authentication. Authentication is a separate module. Let's forget. I'll park this aside for now. Now, on top of this, there are multiple development kits that have been built. So PowerShell is one, Azure CLI is one. You can directly use REST clients to interact with Azure Resource Manager. So if there are devs here, use Postman, you've got Swagger definitions, you want to mess around with the API, you know, go ahead and play around, right? And then eventually the Azure portal consumes the APIs directly, right? And using Azure Resource Manager, you can create anything that you want, right? You create data store, web app, virtual machine, you can do service management, identity management, everything. So Resource Manager is the heart of Azure, right? Everything that you see is just a wrapper built on top of Azure Resource Manager. If you and that's why I said, what happens when you click on a link, right? Any link that you click on Azure, right? This is going to be an API call. The moment you say review and create a virtual machine, we have hands-ons on this, so don't worry, right? I'm just trying to show you uh, whatever inputs that you give to create anything, all of those inputs will get passed to the Azure Resource Manager. How do you pass it or how do you enter those? are just these options, right? You either do it using an input on the Azure portal, or you create an ARM template, or you use Terraform, or you use Bicep, right? All of this is just to provide input to whatever is needed for the resource manager. If you are using Azure PowerShell, you pass the input using the PowerShell commandlet. If you are using Azure CLI, you pass the input using Azure CLI. If you are doing a REST client, you can probably pass in the raw input as a JSON, right? If you are a dev, want to play around. No one's using ARM templates heavily right now. Navneet. I'd suggest if you want to focus on automation, please spend time on Terraform, right? Or Bicep. Is what I'd say. ARM templates, yes, you have a GitHub quick start link, quick start templates available on GitHub from Microsoft. You can play around with those, right? So Azure Resource Manager, that's the deployment and management service, right? That's the heart of everything on Azure. Before Azure Resource Manager, there was Azure Classic as well. Now that's hardly used. Most There's still legacy applications, or still some enterprises leveraging Azure Classic. But Azure Resource Manager is the deployment and management service for Azure. You can create, update, delete. You can do anything, everything using Azure Resource Manager. Now, different ways in which you can interact with Azure Resource Manager is what we've talked about, right? So we've looked at options like Azure CLI, Azure PowerShell, using the portal, uh, ARM templates or Azure Resource Manager templates, um Terraform, Bicep, whatnot. How do we compare ARM with AWS? Cloud formation templates. What are cloud formation templates? ARM is the same thing. ARM templates are the same thing. But if you're asking what exactly is Azure, what's the equivalent of Azure Resource Manager on AWS? I don't know the exact name, but your ARM templates and your cloud formation templates are exactly the same. Right. So again, using ARM template, now using ARM is what you can create, what you can use that to create multiple resources, delete, update, whatnot. Whatever we do on the portal, whatever commands we run, eventually is going to be a call to the Azure Resource Manager only, right? You can do a lot of things, access control, auditing, tagging. But one thing you need to understand is this architecture so that you understand how things are built. So tomorrow someone comes with some other tool, you know what it is built on, right? Eventually, it will be an SDK. Using the SDKs, they probably build it. Terraform, HashiCorp Terraform is one important thing. They are cloud. They've made things a lot more simple. Everything is a YAML definition. Whether you want to deploy Azure resources, whether you want to deploy AWS resources, just switch the provider and you'd be good, right? So any tool that comes in will eventually have to leverage the Azure Resource Manager, right? So once we create resources, you'll see them. I'll show you. I mean, we're not doing a lot of automation in here. It's going to be on the portal. This is like a foundational or a basic course. I've already provided the links. Mukesh, knock yourself out with the API on the SDK. And on the SDK, what do you want to know on the SDK? I mean, is the question. You still have GitHub links, so you can explore. So once you're on the portal, please search for resource groups in the search bar. Remember, the search bar is your friend for anything, everything, right? You want to go do something immediately, create a VM or whatnot. The first thing that you have to be comfortable with is using the search bar. So the first thing, anything that you want to create, just type that in the search bar and you'll find that in the services list. So click on resource groups. Once you click on resource groups, you'll find the create button. Again, this, to get your hands dirty, please do it a couple of times on the portal, because starting, once we get more comfortable, I wouldn't be walking you through each button click. Okay. So I don't want us to waste time on talking about clicking buttons. So the initial two or three different hands-ons, I'll be walking you through each step individually. But after that, I'd expect you to know what we are doing. Okay. So any resource that we want to create, the first thing we do is search for that in the search bar, click on that specific name. Once you are in there, every single time on the top left side, you'd find a create button. Please click on the create button. So first thing we'd have to do is type in a resource group name. Now, you would see a subscription. Anything with a red star is always mandatory. Okay, so choose your subscription. It would have already been selected for you. Type in a resource group name. Call it my resource group one. Now, resource groups need a region. Now, this was legacy, but as things improved in the cloud, the resource groups are no longer region specific. But because this was legacy, you still have to choose a region. So choose a region. I've left it as default East US. You want to explore or create it in a different region, be my guest. That's the only information that we need to provide. Tags are just key value pairs. So typically used in tagging, you can organize your things better. So for example, I'll just give a tag for now. I'll call it environment non-prod, and let's say something like department or business unit. Call it business, BUs, finance, right? Something of this sort. So the tags are nothing but key value pairs, right? They help us organize things better. And once everything is done, just click on review plus create. One thing you can see is it validates everything. Now, this validation is again happening because it is validating the input against the REST APIs. So you can see after you put in the inputs for everything, you can click on download a template for automation. This will show you. So this is the ARM template that is getting created here, right? All your inputs will come in as the parameters that you are passing in. Okay, so this is taking C parameters, RG location, the parameters resource group name, the parameters tags. All of these are the ones that you have provided here. So if you click on parameters, you can see my resource group one. This is the name that you put in that text box. Tags, environment, non-prod, BU, finance, location you've chosen East US, right? So this is how a template will look like. The scripts will give you the scripts to deploy your template, right? So if you're interested, you can do that. Okay. So once you've passed your validation, let me see. Anything is charged. Okay. Do we need to create a dashboard? Okay. To classify similar. How can we create resource? Like I said, follow the instructions. You'll get there. We'll not do that with automation for now, right? If everything's done, please go ahead, click create. Let's create a resource group. Use of the template is for automation. You want to deploy 50 resource groups. You want to be doing it manually. That's where you do automation. For automation, you need to use templates. You can use an ARM template. You can use Terraform. You can use Bicep. You can use Azure CLI. You can use PowerShell. Options are many. So since we've got in our hands on, we need to also take a look at moving resources, right? So we'll create another resource group also. Okay, so I've created my resource group one. Also, let's also create another one. Call it my resource group two. I'm just using different tags. It's up to you what tags you want to use. Once you've created, now I know this hands-on kind of asks us to deploy a web app, which is kind of interesting. So for now, we'll still go ahead and create a web app in one resource group and move it. That's just to show you that we can move resources across. But one thing I'd say is don't ask me questions around the web app now. We'll handle that in the compute section when we get there. But for the sake of this hands-on, we will still go ahead and deploy a web app. A web app is a PaaS service. So for folks, when we talked about the different deployment models, IaaS and PaaS service, the example of a PaaS service on Azure was App Service Plan, which essentially is the web app that we will be deploying. Tags is for differentiation. We'll talk about those in a little bit. So let's go ahead and create a web app. Please search for, type in web app. What you would see is app services. It was called a web app. Now it's called app services. That's fine. So just select app services. Once you select that, here you see there are multiple options in the create drop down. For now, let's just choose a static web app. Okay, so choose option two, static web app. Now, one thing to understand here, again, for any resource that you create, now web app is a resource that we're creating. What is the first thing? You see the hierarchy here. So after subscription, it will ask you for the resource group. So choose the resource group that you already have created. So choose the first resource group. And then let's give our static web app a name. Give it any name that you want. Plan type, choose free for now. So people who are using pay as you go, choose the free one, free tier. Now for functions, I'll leave everything as default. Now what I'd say is, I have connected my account to GitHub, but if it asks you to, you can choose, and you can choose Azure DevOps, or this is going to ask you for something. That's the other challenge. Choose other if you don't have a GitHub account. Like just choose other for now in deployment details. We'll not create anything else. Okay. So choose other. So just choose other in the deployment, right? I'm just choosing, I have a static web page. So I'm just pointing it to that, but ignore everything else. Just click on review and create. The purpose is not to show a web app, but basically just to move a web app around. Okay. So once everything is valid, just click on create. It will take a while. So you see in the backend, whatever is happening are all API calls. You want to see what has happened in each of these, you can see there are multiple. It will also show you what is the API that it has called, what is the resource it has created. Okay, resource creation complete, static web app created, lemon. Anyway, so once it's created, we are not uh, creating anything here. So I don't want us to play around with the web app. Let's go back, search for resource groups in your resource group one. Once you click on it, you should be able to see your static web app. Why are we creating a web app? We want to deploy an app. Actually, we want to show what the intent here is to see or validate the ability to be moving resources within resource groups, right? We are at the very basics. We are not diving into any compute module or anything, right? So the only thing we want to understand in this is how we create a resource group. How does the hierarchy look like? Because initially there were questions or concerns around, hey, what is a resource? What are resource groups? So if you create a resource in one resource group, can you move it to the other? The answer is yes, and that is what we are attempting to do in this hands-on. Our intent is to not deploy a web app and show a web page, but just play around with resource groups and resources. So now what you can do, what we want to do is we want to move. So let's say we are in resource group one, right? So this is where our static web app is. What we want to do is move this to resource group 2. Okay. So the way we'll do that is you can select the resource. Again, before people say I'm too fast or too slow, right? So what we do, once select your static web app, remember anything, on the top, there's these tabs where you can do a lot of interesting stuff. The one tab we are interested right now is the move tab. So click on the drop down on the move tab, and you would see the different move options that we have, right? Now you can move this to another region if you want to. You can move it to another subscription if you want to, right? But for the sake of this hands-on, we are only interested in trying to move this to another resource group. So let's click on that. Now it's asking you to choose your target. It's already showing you the source, which is your subscription and your source resource group. So in your target, choose the other resource group that you've created, or you can create a new one, up to you. Please click on next. It's going to validate. Now, what happens in this validation is it ensures that there's no dependencies that you're breaking while you're moving these resources. It might take a while. All right, if it's validated, it would have moved. So, folks, if you're not seeing it move, it takes a while to move the resource, and once it moves, it will probably show up here. So, we'll wait for it to happen. That's fine. Meanwhile, we can do other things as well. Right, so let it run in the background. One thing I think, if you have chosen the free um, tier, you wouldn't have to worry about the cost. We'll still delete it towards the end. So one thing we'll keep doing is towards the end of each session, we will be deleting the resources that we've created so that it doesn't, we don't get overcharged or whatever. Why do we move from one resource group to another? I've seen, usually, let's say midway, I've seen this happen in a couple of enterprises, right? So what happens is, let's say you start with hey, I want to go with a resource group model where it's business unit based, right? So, for example, I've created a resource group for HR. Any applications or any servers HR wants to create, they'll be in one resource group. So that's how one organization, one SME started. So small and medium enterprise, right? And eventually they realized, hey, this is not the right way for me to do things. I would rather have my web servers and database servers separate because let's say I want to rebuild my web servers. I want to delete the resource group and recreate it. I might have issues. I do not want to be recreating other resources, just the web resources. So in such kind of scenarios, any dependent resources or any resources you don't want to touch, or you're looking at reorganizing your resource groups, that is the primary use case for you to be able to move resources from one to another. The resource locator URL has changed, but the web app URL has never changed, right? The URL for the resource locator that you see on screen here, this is the URL for the resource itself. But my domain, my website, that URL will never change. All right, now that we've done this, uh, I hopefully everyone has done it. So now we'll look at tags and resource locks. Tags we've already just seen, right? Key value pair. So department, finance, BU, like the ones we've applied. We've got a quick hands-on on those. Now, typically, why you would use these, as I mentioned, is for you to be able to understand. Now, let's say you're a Azure admin, right? Someone says, "Hey, my server is not working." If you have to figure out what that server is, someone gives you a server name. So if you have to understand which department is it affecting, what is the cost center, what not. So that's typically how you would use your tags, right? It's just a key value pair. So for example, the way we've tagged our resource groups right now, if you go to resource groups, you click on any resource, one of your resource groups. Again, navigating Azure portal, this is important to understand, right? The moment you click on anything, you'd see all the options for that specific resource on the left side menu here. Now, these four will be common for everything: an overview, activity log, access control, etc. So if you click on tags, you see we have these tags that we have put together, right? Now, if you click on any of these tags, so if I click on BU Finance, now these are the tags that we have put together. Now, one thing to understand is these tags get inherited by the resource that is in. So in resource group 2, so you have these two tags that you have created, right? If you had. Now, in this resource group, if I look at the web app that we created, and if I click on tags, uh, I, I think I tagged it after. That's why it's not showing. Okay, never mind. So tags can help us figure out or filter resources immediately, right? So for example, once I'm on this resource group 2, now this has tags BU Finance. If I click on BU Finance, I'll see both the resource groups that have the same tag, right? So tags basically are primarily, they are very important while they sound like a very trivial feature, but tags in a large scale environment help you figure out or filter down resources, be it for billing, be it for any other purpose. Tags are really important. So tagging strategy plays a really important role, but that's more of a solutioning and architecture point. But from an administrative point, what you need to focus on is to understand what are tags and how they can help you filter resources. All right. So again, if you go to search for your resource groups, click on your resource group, and then you'll find tags right here. Click on tags, go ahead, add them. I've added BU, finance, environment, non-prod. Mm, You can add whatever you want. Let's say I'll probably add cost center one as a tag. Once you add these, click on apply at the bottom. And for the sake of understanding how filtering works, add the exact same tag on the other resource group as well. And click on apply. So once you do that, yep, tag for automation reporting. This is a lot that tags help with. So it ideally should, right? I think I created the tag later. This is interesting. Let me see. Did this tag come through? I don't know why it's not showing up for some reason. But they do get inherited from the resource group to the resource. Yeah, it's grayed out. The assign tag on top. I don't see an assign tag. You can click on tags here on the left side. So whenever you click on the resource, yeah, so don't go to the resource, just go to the resource group itself, and then you'd have tags, and you can put them in here. It should. Anyway, I'll figure. I don't think if things have changed, but just creating another resource to see if it inherits the tags. Pretty sure it should inherit the tag. Let me check. You can create individual tags on the resources themselves, but if the resource is within a resource group, it should inherit. The REST API specs. Maybe Parag, you wanted to give me another link. Oh, it says it doesn't inherit. Okay. Yeah, it is not. I think it is a policy. Yeah. Okay. The reason I thought yeah. You can inherit. So this is an Azure policy that can be implemented. Yeah. I think in most of the organizations I work with, there's a resource group tagging inheritance. Okay. By default, it does not, but you can put in a policy to do that. It should inherit now. I'm surprised. Maybe things have changed. Anyway, I'll figure out an answer for that. Far as I remember, always it was inherited. But anyway, so once we have those who have created the tags, you want to check out the filtering. So just click on any resource group. In the overview section, you'll see your tags. Just click on any tag and you should be able to see the resources that are part of that tag. Azure Windows apply to a resource. It is added to the subscription-wide taxonomy. This is fine. They don't apparently. Now, this looks like they don't. You can use policies to get that, but they don't. Okay, you're always learning. All right. So now that that is done, one other thing we'll look at is resource locks. Okay. So on any resource, once you click on it, right? Like I said, you have the actions that you can perform on that resource are available in this pane on the left side. So you would see that in the settings, you have something called locks, right? If you click on locks, now locks can be inherited, I believe, yes. So if you click on locks, you'll see it says that the resource has no locks. Now the kind of locks we can add are a read-only lock and a delete lock, right? So a read-only lock means that no one, once there is a read-only lock on any resource or a resource group, you cannot modify them, right? So if you want to change anything on that resource group or on that resource, you will not be able to. A delete lock, on the other hand, will ensure that you are not accidentally deleting anything. So what I'm doing right now is I'm creating a delete lock on this resource group. Okay. So the delete lock is added. Let me just check if we get the lock. Yeah. Locks are inherited. Tags are not. My bad. Yeah. So now you see on the resource, which is my static web app, you will see that the parent resource locks cannot be edited here. So this is inheriting the delete lock that we just applied from the resource group itself. Tag policies, yeah, policies you can apply for Azure policy is a different ballgame altogether. Now we can dive into those, but yeah, these are Azure policies for compliance. All right. So resource locks, the two types of resource locks that we talked about. One is a read-only resource lock. One is a delete resource lock. Now, once we apply this, what happens is this helps us prevent accidental deletion. So if someone was wanting to delete this resource, you can press delete to confirm. If I try to delete this, I've got a lock applied. So ideally, it will immediately fail saying, there is a resource lock. Please remove the lock and try again, right? So resource locks kind of help us in that way. So you can ensure that there's no accidental deletions or accidental changes that happen by putting in resource locks. Right? So if you want to delete it, which we would want to right now, so resource locks, right? As I mentioned, a read-only resource lock and a delete resource locks are the ones that we can apply. Uh, these prevent accidental changes or accidental deletions. But now that we have applied the lock, we've seen that we cannot delete the resource, right? And that is what helps us. Can we apply different locks to different resources? Yes. Well, that is the tricky piece, right? Inheritance will be there. So if you apply it on the resource group, like I just showed you, so on this resource group, I have locks. Why is it not showing? Refresh. Yeah. You see, this is the lock I have applied on the resource group level, and this gets inherited to my resources as well. So you cannot, if you want to do it granularly, then you might not want to apply it at a resource group level. Rather, you might want to apply it at a resource level. So because locks are inherited. If you want to remove the lock, you'd have to do it at the resource group level itself. So I can probably delete the lock here. And now I should be able to get rid of my resource group. So there's two options. You can either delete individual resources. I'd rather do that. Now you can get rid of your resources, right? So that's pretty straightforward on resource tags and locks. Tags, like I said, tags are an ocean. They have a lot of value in the enterprise, right? While they might seem very trivial. We've done a quick hands-on on this. We've also seen resource locks. All right. So quiz time, question one. Cloud computing came as a solution to which of the following problems? All of the above. Well, that was quick. All right. Which of the following service domains is not offered by Azure? IoT is available. So Internet of Things. IoT is Internet of Things. One quick way to know all of that, let's say you look for, see, IoT Hub, IoT Central Applications, and device provisioning services. So they are available. So answer is all three of them. All right. What's PowerShell? Azure PowerShell. We'll be talking more about storage. So compute, network, storage. Like I said, three primary things. Starting off with storage in module two. So what we have in storage, what Azure storage is, what does Azure provide from a storage perspective, what type of storage accounts we have, and in the storage, in Azure storage, we have multiple options that we'll discuss about. So we'll talk about blob storage, we'll talk about file storage, we'll talk about table storage, storage queues. Now, there are quite a few, the concepts that keep repeating. Now, they'd be more or less common across, from a metadata perspective. So we'll focus a bit on that. And then we've got shared access signatures. That's kind of an interesting topic. It's typically primarily around security and how would you access private storage. Then we've got the data factory and copy data tool that we'll look at. So when we talk about benefits, so again, as most of you have already mentioned these, right? I'll not be a broken record and talk about the same old things again, right? Security, again, Azure or any other cloud provider also claims, top-notch security for data that is stored. It's always encrypted. So data at rest is always encrypted, which means the physical disks in which your data is stored are encrypted. So if someone happens to go ahead and get into the data center and try to steal the disk, in which unfortunately your data might be on there, they'll still not be able to make head or tail out of it. That's what that's how encryption helps you. Encryption at rest helps you, right? And then you've got storage being encrypted, storage accessing, it gives you full control over who can or cannot access your data. So this is pretty much straightforward from a security perspective. Important thing to understand is from a uh, when you say data is encrypted, so encryption at rest is the concept that you'd have to understand here. Encryption at rest essentially means that wherever the physical disk is, wherever you have within the data center, those disks are encrypted. So if anyone tries to go ahead and steal the data or the disks or whatever, they wouldn't be able to access your data, right? So that is what we mean by encryption, right? Second thing is after security, we've got accessibility. So again, the way this is something that the cloud provides by default, right? When I say by default, this is one of the other features, right? Accessibility. So because you'd be able to access your storage from anywhere. So what we are saying primarily is if once you consume the storage, you would be able to access this over the internet, over HTTP or HTTPS calls from anywhere in the world. Third thing, pretty common, everybody keeps saying this, scalability, right? It's highly scalable in order to meet the on-demand requirements for applications. And again, we've talked about high availability. So there are options that the users are given to be able to replicate their data across multiple data centers. So what it means is also, within a region, there are multiple data centers, which are called availability zones. We'll talk about that in compute as well, but I'll give you a quick overview of that. And along with you also have the ability to go ahead and replicate your data across multiple regions. So let's say you have region 1, 2, 3, you can go ahead and, you have an option of replicating data globally so that even in case anything goes wrong, you still have an option to go ahead and recover your data from other locations or primarily any other region. All right. Never mind. All right. So those are the advantages. Again, the advantages are pretty standard across any cloud product that we use. Make sure we all understand is, so we'll talk about two interesting things. One is we've gone through the benefits, which is fine. So one is zones, availability zones, and the second thing we'll talk about is the cost. All right. So in terms of what we mean by a zone, so what is a region? So we looked at the private and public data centers yesterday, right? So public data center, I'll call this data center one. Let's say this is in not call it. Let's say South India. I think South India is one of the regions, right? Now, if you have only one data center in a region, right? That is how the cloud started, right? So there was another, let's say another region is US East. And then they have another region which is West US, right? Somewhere in those regions. Now, what was the concern here was in case a region went down, right? Something was wrong in a region. It can be any region, right? So the risk for the applications was that all applications for all customers across the region went down. So that was one of the larger risks. So in the initial days of the cloud, the way things were set up was, for people or for customers who wanted higher availability, they had to go across or they had to spread across two regions. So for example, you know, an app running in East US, they also had to run an app in the West US to make sure that even if one region goes down, they have the application being served from the other region, right? Now, AWS was intelligent enough to say, hey, within a region, I'll give you three zones, right? So what they started with was, let's say this is region one. In each region, they had three data centers. Okay. So let's consider this as a region one. Now each region had three data centers. Now the distance between these data centers was at least 150 miles apart, right? So what this ensured was, even if there is a calamity, a natural calamity here or here or here, all three at the same place is highly unlikely, right? It's all probability, right? So introducing zones. So each of these was called a zone, right? So three zones: zone one, zone two, and zone three, right? Azure calls them, all the clouds call them availability zones. Okay. So adding availability zones to the regions made them more resilient within the same region. So the risk of the entire region going down was brought to a quite a lower number. Okay. So let me do this again. I'll just clear this up, right? So we talked about public data centers. A region can be a geography. Okay. So for the sake of this example, I'll call this, let's say, you have East US as a region. So somewhere in maybe somewhere close to New York, there's a data center. Okay. A data center is one single data center, right? So you have a physical location and you've got this is a physical site, right? And you've got a public data center, or Azure is actually running the data center in this region. So this can serve people who are close to East US, right? So this is a region. In a region, you have a data center. Okay. So these were the initial days, right? So each region was just one data center. West US was one data center, right? South India, for example, one data center. Okay. These are examples, right? Now, if that something happened in New York, or if something happened in West US, maybe somewhere in California, right? If something happened, South India DCs are currently in Chennai. South India 2 is coming up in Hyderabad, but right now this is in Chennai. Something happened in Chennai, Chennai floods that came in. They can kill the entire data center, which will mean any power outage or any natural calamity would put the entire region. So, how would you avoid this, right? So, to avoid this, what they said is in East US, I will have three data centers in this region. Okay. I'll call them zones. So, this is zone one, call them zone two, and I'll call this zone three. Now, while they are in the same region, they are separated by at least 150 miles distance wise. So basically, you'd have three data centers, but they are all part of the same region, right? East US. This is also East US. This is also East US. This is also East US. But they are just 150 miles apart. So what this makes is, in case there is a calamity here or here or here, having a natural calamity happen in across 300 miles is highly unlikely, right? Again, it's all probability, right? But all the three zones or the three data centers going down at the same time is highly unlikely. All cloud providers, starting with AWS, followed by Azure, created zones within each region. Okay. So each region have multiple zones. They can be two zones or three zones, depending on whatever is the ask in the region. But Azure doesn't go beyond three. I don't mean data set, everything is replicated across. No, customer has to take that responsibility of creating. So let's say you have a web application, right? You have web servers, you have three, or let's say five web servers that you're running, right? You need to deploy one web server in zone one, second web server in zone two, third web server in zone three, fourth probably can be in zone one, fifth can be in zone two. In this case, you are responsible, or the customer is responsible to ensure that they are deploying to a specific zone. From a storage perspective, again, we'll dive into those, the options, the replication options, right? But by default, things are not replicated across. You or the customer is the owner to make sure, or ownership, customer has to take the ownership of where their data is deployed. Having more data centers reduces the loss? No, it reduces the risk. You can never skip the loss of data. Loss of data can happen, but the risk of that happening is what is reduced because of zones. How do you make it resilient across in the region? The resiliency is on the customer. Now, there are options available on the cloud, but it's not default, right? Again, everything comes at a cost. The more money you pay, the more things you get, right? Which brings me to the next topic about cost question. Resiliency is ensuring that your your application is up, or you have redundancy built in for your application within a region. Anything within a region is called resiliency. Often people confuse having availability zones as a disaster recovery option, but it is not. Okay, disaster recovery is a different concept altogether. Resiliency is availability of or redundancy across different redundancy of your application within the region to make sure that it has a higher uptime. A region can span across multiple zones. Each zone is a data center. So a zone cannot span across multiple data centers. A region can span across multiple data centers. Or there are chances of data getting corrupted. It can be during transit. You're bringing in the files over. You have copied, like, let's say you're copying 300 gigabytes of data, and probably at the last gigabyte, something has happened and your checksum has failed, right? You have to start copy all over again. So let's not get into those, but there are different ways where you can ensure ensure that you're doing a better copy job, and that's the reason why you'd build pipelines, right? That goes into a data factory discussion altogether. All right. So now let's talk about cost. Okay. So as I said, lower cost. Okay. Now cost, one thing to understand is all of the enterprises so far. Now we talked about three things, right? We talked about compute, we talked about network, three basic fundamentals, and storage. What is the cost split between these three? Let's say these three amount to 100, right? This is the 100% of your cost, right? For your infrastructure. 25, 25, 50, 40, 20, 40, 50, 30, 20. Okay. 20, 20, 60. Right? You'd be surprised to know storage eats up 70% of the cost of any enterprise, even on the cloud. Compute amounts to 20% of cost only, and networking is 10% of the cost. Okay? So this is the split. So one thing you have to understand, storage is expensive. Storage always is expensive, whether it is on-prem or whether it is on the cloud. Storage is always expensive. And on the cloud, it is really easy because you have wide amount of options. You've got replication options across availability zones, across regions, across geographies, and across multiple regions, across multiple zones in multiple regions. It's a simple checkbox that can give you a sticker shock, right, towards the end of the month for your storage bills, right? Enterprises spend, I've seen enterprises who've got shocked. I've seen people spend, their budget was maybe they had a 10 million credit on Azure, and the end of 1 year, they had spent almost 9 million on storage. Okay. So it's really important, storage has to be, have to be conservative around storage. As an admin, again, if you're, looking for an Azure administrator role or whatever, as an Azure admin, again, if you're part of the storage team, you have to be very, very, very careful about any specific checkbox that you do. You can just say, hey, I want to replicate, or I'll choose a storage replication, right? Storage costs are very heavy, whether it's on-prem or on the cloud, right? So yes, storage can be or will be relatively cheaper when compared to on-prem, compared to your physical data center, but storage is the majority of the cost. 70 up to seven, more than 70% is a ballpark. It's an average, but there are cases where it can be beyond 70% as well if people are not careful. All right. So, um introducing storage now. Basically, what we need to understand is storage um in Azure. The most, storage is a wide term, right? Now storage can have lot of scenarios. One primary, just like, one primary resource that we deploy is a storage account. Now this is the base for everything on Azure. Any storage on Azure will use a storage account. Okay, so that becomes our baseline. or our base for everything on Azure. Now, the type, once we create a storage account, what Azure, the options that are available for us within the storage account to consume are the four types that we discussed and we saw yesterday in terms of services. The first one is blob. The second one is files. Third is tables. And fourth is queues, right? So anyone who wants to consume any storage, there has to be a storage account. Just like and these storage accounts are backed by physical disks in the data center, right? The, Again, eventually there's again a virtualization layer on top of this, which gives you whatever storage that you want. So everything in Azure, when we say Azure storage, it's an umbrella term. What it means is you get cloud scale storage, you get highly available and resilient storage depending on what type of storage account you create. We'll get into those details. Okay. So storage account is the base or the root for everything. Once you create a storage account, you can consume one or more than one of all of these types of storage that is available. So you can consume blob. So if you're storing files, you're storing videos, whatnot, you can consume blob. File storage is again very specific to file shares. So if you've heard of file shares earlier or you've used network file shares at your work, they all work on a specific protocol called server message block SMB. So Azure file storage is primarily consumed as a file share. Table storage, as we discussed, this is primarily a NoSQL database. And queue storage is for storing messages. We'll get into these. So any storage account that we create on Azure will have four possible services that you can use. So you can use blobs, files, tables, and queues. Okay. So you have a better understanding of that once we create a quick storage account. All right. So as I mentioned, the first thing that we need, any type of storage that you want to consume, you have to create a storage account. With this again, storage account is a resource. Okay. Just because it says it's an account, it's not a account with a username and password. When there is a username and password, but storage account or SA in short, right? Storage account is an Azure resource. Okay, just like we created a resource group yesterday, storage account is an Azure resource that we will create. Okay, all the types of storage, again, as I said, blobs, files, queues, and tables, they will be within the storage account. And one thing to understand, since storage is accessible globally over HTTP or HTTPS, the storage account names have to be globally unique. So when we create one, you'll see, right? You can't just choose test one or test two because in all probability, it would have already been chosen. So anything, the base of everything is a storage account. Storage account is an Azure resource. The moment we create it, if you want to consume any of these blobs, files, queues, or tables, we will need a storage account. And one thing to understand is storage accounts, since they are global in nature, whenever we create a storage account, the names should always be globally unique, right? Each of these is a service that is exposed over HTTP. So we look at the structure of those as well, right? On how the URL looks like. It is typically .core.windows.net. Now this is the domain that we get by default. So you probably have blob.core.windows.net, files.core.windows.net, tables.core.windows.net. And before all of this, you would have your globally unique storage account name. Service has its own core URL. So if I created a test storage account, so my blob URL will look something like test, if this is my name, test.blob.core.windows.net. Okay. And then whatever is your container, blob, whatever. If you are using Azure Files, your service URL will look something like test.files.core.windows.net. So these are exposed by multiple services. Okay. And the backend, based on each of these service, goes to a different physical storage or the type of storage. Okay. Storage account is an umbrella term, like I said, like I mentioned, and repeating this again. You can consume four different services within the storage account. Storage account is not limited to consume only one type of storage. Okay. This is different from any other cloud, Google Cloud or anything, even AWS. They'll give you storage buckets, which are primarily just blob storage and nothing else. All right. So we'll get into that. You'll understand more. But what you need to understand so far is storage account is an Azure resource. It's an umbrella term. You get four different services when you create a storage account, which you can consume or choose not to consume. You can only consume one or two or all of them, right? It doesn't matter. You have blob storage. We'll talk about those. We'll do a hands-on with that. You can use file storage, you can use queues, and you can use tables. So now we'll talk about types of storage account. Okay. Uh, in storage accounts, now typically, I think this is only talking about general purpose, but there are two. Now there GPv2 or general purpose V2 is the advanced version. The slides are a little older, right? So the general purpose storage account or GPv2 right now. You can still create a general purpose one, but mostly people prefer creating V2. If you're asking about the difference, I'll show them to you on the portal. How are they different? It's primarily around the security enhancements and quite a few other things. So we'll talk about that. Please remind me, one of you folks, to walk you through the difference between a GP, which is a general purpose storage account, and a general purpose V2 of the storage account. Okay. Now, like I said, four different services. Blob storage, you can store any binary data, whatnot. We'll do all of this. Okay. Table storage, you use Azure files for SMB and whatnot. So I'll not keep repeating this, but apart from consuming general purpose storage account or a GPv2 storage account, we have two important things that we need to understand, which is the access tiers. Now, for blobs specifically, for blob storage, we have two different access tiers, hot and cool. And this is for blob storage only, right? Right. So basically what happens is the retrieval times, hot storage is faster, right? So you can retrieve data faster, and you would typically want to use hot access tier if you are accessing the data frequently. And cool access tier is for something where you access, where the access is infrequent, right? So example, you have a website and the images keep loading continuously. That is, and people, so a lot of users would load those images. So you'd prefer using a hot access tier. What that does is it reduces the latency of the load times because you're able to retrieve the images faster, right? If there are multiple versions of the images or there are some pages that are infrequently used, you probably put them on a cold or a cool access tier. Now, the difference here is hot access tier is expensive. So hot and cool access tiers are primary. Now, as since Nainendu has also mentioned archive access tier, there's a third one, right? The archive access tier is for long-term data retention, right? So what are the scenarios where you would use archive? Is, let us say, for compliance, you need to save 7 years worth of backups, right? Now, these for banking, again, I think it's depending on the industry, depending on the regulation, there might be the retention times might be different. But these are the scenarios where you'd probably consume the archive access tier. This is a lot more cheaper than the cool access tier, but retrieval is going to take time, right? Typically, in the on-prem scenarios, the archive access tier is similar to using tape storage for archiving data, right? So it takes a while to retrieve your data. You'd have to seek the files, and then it's a lot more slower. Cool access tier. is relatively better. It's only for infrequent data, but you would not use cool access tier in case you are running a website or you want to load images frequently. Yeah, in the real world, apart from compliance, you wouldn't use archive tier primarily. How long would it take to retrieve? Depends on the amount of data that you're storing, but archive access tier might take a couple of days. Full access tier, not as much, right? It can be a few seconds, but that's not something that will work in a website kind of scenario. Hot access tier gives you a lot more faster storage, so you can retrieve the data a lot more faster. So in the backend, it is the type of storage on which it is stored. Storage is neither hot nor cool. It is just the access tiers around the storage. So hot access tier for a storage account, for and this is very specifically to blob storage. Okay, read the letters in bold. Is very specific to blob storage. Hot access tier is somewhere is an access tier where you'd want to put your frequently accessed data. So the retrieval times and the latencies, the retrieval times are lower and the latency is lower. A cool access tier is where you would put in infrequent data, the data that you would access infrequently, and the archive tier is something where you would probably keep the data in there and you're not worried much about retrieval times. So a cool access tier is something like, let's say you've got version 1 of an image and a version 2 of the image and a version 3 of the image, right? Version 1 is something that is accessible on the website, for example, right? Version 2 and version 3 can be in cool access tier because you don't worry, no one's accessing them frequently, but you've got these uh, uh, in case something goes wrong with this image or this file or whatever, you can do a retrieval, right? So these are the scenarios where you'd probably use hot access tier for an image that is current, and the previous versions can be put down in cool access tier. All right. Again, hot access tier, straightforward. So it will give you low latency. It's more expensive. Cool tier is for less access data or archive data, but archive tier is totally separate. So take the slide with a pinch of salt, and it's best suited for data that's not accessed frequently. Right. Okay. This brings to us an interesting point. We'll do a hands-on. We'll probably answer a lot of your questions. So please, folks, get your portals ready and let's log in to the portal. This will make much more sense once we do a hands-on. The subscription was cancelled, but okay, we try another one. You can reactivate, just try a new payment method and you should be able to. Awesome. So once you're in here, like I said, search bar is your friend. Let's go ahead, search for storage account. You'll find you'll find it in services. Give you a minute. For any service that you are in, you can click on create on the top left and you'll get to the page for creation. Okay, so now what we'll do is a storage account name, like I mentioned, this has to be globally unique. So don't type what I am typing. Each one of you would have to choose a name that is unique. So it's more like musical chairs. You might probably get a name which is available in the first shot, or else it might take a couple of attempts. So for example, if I type in test, it will say that test is already taken, right? So choose a name and a number or whatever can make it globally unique. So I'm good for now. Please don't choose mine, right? You can choose a region. Now I'm fine with the default region, but if you want to explore the different regions that are available, you can scroll away Pick your poison. Will it change by the region? Yes, but it will be minute. Okay. You want to really will see the cost. You can look at Azure cost calculator or Azure pricing calculator, whatever it is. So for storage account, so East US hot access tier, general purpose V2, 1000 gigs of storage will cost you $21 per month. And then there's cost for data transfer as well. So if you leave them as default, you'll be charged probably $52 a month. Okay. Edge zone. Like I said, everything is a tangent. If you want to deploy to an edge zone, you can. So edge zones will be multi-access edge computing family. So currently, an edge zone would mean, let's not dive into that. Okay. I'd have to explain a lot more around edge zones, but skip it for now. Remember, we are in basics. We are not doing advanced, but once you start getting into architecting, that's where edge zones will make much more sense. Okay. So performance tiers that you see, standard is general purpose V2 only, right? So you cannot choose a GPV1 account or a general purpose V1 account. Okay. So V2 is the newest standard. Now standard and premium is again based on the latency. Okay. So if you choose premium, you can choose block blobs or file shares or page blobs. Now this gives you a lot more lower latency. In our, you can choose your redundancy. We'll talk about this a little later, right? So just choose standard for now. Most common scenarios, you can just use a standard storage account, which will create a general purpose V2 storage account. And now there are redundancy options. Now this is what will make your cost go higher, right? So if you expand this, what you can see here are four different options that you have. Okay. The first one is locally redundant storage, right? What this means, now if you see here, this is the lowest cost option and it gives you basic protection against server, server rack and drive failures. Okay. So a server rack or a drive failure, that's what it gets you. This is the storage is redundant locally within the zone, right? Or within the data center, within one data center. Okay. Okay. So this LRS, the replication is only within the zone or within the data center. Okay. The second option, geo redundant storage. Now this will give you replication. So it'll create, you can create your account in region 1 and it will replicate to another region, which is region 2. Now it's not that you can choose this region. Okay. There is a concept called paired regions. Okay. So if you choose East US, you can see what those paired regions are when we deploy it. Yes, you can delete a storage account. Don't worry about it. Okay. Please focus on understanding the differences between the replication options. Okay. Locally redundant storage, the storage is replicated only within the zone. Okay. And it will only give you protection against a server rack failure or a drive failure, right? So there are copies of of your data within the same center or within the same zone. That is why it's called locally redundant storage. Geo redundant storage will replicate your data across another region. Okay. So if you choose one region and if you choose geo redundant storage, the data will be replicated to a secondary region of Azure's choice, not your choice. Okay. Please understand that. And what these regions are, they are called paired regions. Okay. We'll take a look at those. The third option is zone redundant storage. So what this does is it gives you protection against data center failure. So basically in this scenario, if you deploy a zone redundant storage, your data is replicated in zone 1, zone 2, and in zone 3. Please repeat GRS. Okay, guys, please focus on this. I know you'd be itching to go ahead and create a storage account, but this is really important to understand. The replication options are really important to understand. If your focus is the exam, yes, you might probably get a couple of questions on this. So I'd request your attention on this for 2 minutes. If these are clear, you can knock yourselves out by creating as many storage accounts as you want. Okay. GRS or geo redundant storage, it gives you, when you create this, the storage is replicated across regions. Okay. If you create it in region 1, it's going to replicate the data into a secondary region as well, right? So one would be where you create the account, where you create the storage account is called a primary region, where Azure replicates it is called a secondary region. Okay. The secondary, you can only choose your primary region. You cannot choose your secondary region. If you want to understand what is the secondary region for each of the available regions in Azure, please look up paired regions. You'll find that mapping. Okay. So GRS is going to replicate your storage in each regions. One thing to understand and one thing to be very clear about in GRS is, so if there is a data center, I'll make this a region. Okay. There is region 1 and there is region 2. Okay. Region 1 might have zone 1, zone 2, zone 3. Region 2 also, let's assume, has zone 1, zone 2, zone 3. Okay. GRS not will replicate your data or create your data in only one zone. Okay. If you are choosing GRS, your storage account gets created in only one zone and it only gets replicated to one zone in your secondary, primary and secondary. Okay. Will only get you, your primary storage account will be created in only one zone and it will only get replicated to one zone in the secondary. Please understand, GRS will only have your data in one zone in primary and it will replicate to one zone in secondary. Geo redundant storage will replicate your data from a primary region to a secondary region, but they will only be in one zone. Zone redundant storage is replication within the region itself. So your data will be in zone 1, zone 2, and zone 3. It will get replicated across all three zones. Locally redundant storage, your data will only be in one zone, but it will only be, it will have 3 copies of data. Okay. Within the same zone. It is just 3 copies of your data. Within a zone, if you have 3 replicas, your data, that is locally redundant storage. Geo redundant storage is in 2 regions, 2 geographical regions, but only in one zone of each region. Okay. Zone redundant storage is within the same region and across availability zones. Okay. GZRS, which is geo zone redundant storage, will make sure that your data is in region 1, it is in 3 zones, and in region 2, it is in 3 zones. Zone redundant storage is your data is within the same region and it is replicated across the availability zones. Simple. So it is zone redundant means it is within the region, but the data is replicated across zones. Data won't be stored in zone 1. The moment you create a geo zone redundant storage, your storage will get replicated within the multiple zones of the primary region where you have created the storage and in the secondary region also. All right. So this checkbox, this makes sure. Now, when you're replicating data, one thing you have to understand is all of these replication options are to make sure that your data is not, your data loss is minimized. Or rather, your risk to, I'll not say data loss is minimized, but the risk to your data is low. of losing it. The risk of losing the data is low. Okay. Now, in these scenarios, in geo replication, right, you will not have access to the secondary region at any given point of time. Azure handles the replication. In case the primary region goes down and your data is gone, right, the moment the primary region is up again, you would be able to restore your Azure will restore your data back from the secondary region back to the primary region. But in scenarios where if the primary region is down, you still want to be able to read data from the secondary region. That is when you would use this checkbox. Okay. Now, when you use this checkbox, so earlier there were, instead of this checkbox, there was option which was called RAGRS and RAGZRS. This is read access to the secondary data. If you don't enable this checkbox, your application will not be able to read from the secondary database, or sorry, secondary copy. It will not be able to read the data from the secondary region. Okay. Only if the primary region comes up and data is restored, your application will be able to talk. If you have this checkbox on, that means the replicated data can also be read by you or by the application that is trying to access this. Like I said, it's an ocean, and these are not that simple. While they look simple, if you miss this checkbox, your application is going to die if you don't have read access. So when you're in the same region, you still have, even if a zone goes down and you're on zone redundant storage, you can still read and write to the other two copies. Now, if you need to understand this from a on-premise terminology, you can explore how RAID works. Okay, so there are different types of RAID in physical disks, right? I don't want to go there, but within the same region, you will still be able to read and write onto the other copies in the same zone. But when it comes to different regions, you cannot write to the secondary copy or read from the secondary copy directly unless you enable that checkbox. Write is definitely not possible, right? To the secondary region itself. Within the zone, within LRS and within ZRS or ZRS, whatever you want to call it, you would still have read and write access to your data within the region. Only in case of geo replication, you would have to check that box to get read access to the secondary database. Again, this is not a DR kind of a scenario. This is the replication options Azure provides you for the data. So you're not controlling it yourself, but Azure is doing it for you. Now, in case you want to have much more granular access, then you would have to write a data pipeline to continuously copy data from one storage account to the other storage account. So we looked at the services that are available to us, right? Data factory. So you can write a data factory pipeline to do that thing for you. Okay, let me make it simpler for you. Okay, so let's go back to basics. Okay, region, and then we have zones. Zone 1, zone 2, zone 3. When you create a storage account, what are we choosing here? We're choosing a region, correct? Right. So you're deploying, you're saying, I'm creating my storage account in a region. All right. Now, if I create LRS, what is happening? My storage, let's say I saved file.jpg. Okay. It will sit in one zone. Awesome. Now, when it is sitting in one zone, when you create LRS, what happens is, so there are hard disks in your data center. Zone is a data center, right? Then there is network attached storage. Okay. So your file is stored in, let's assume, 3 different hard disks. Okay. Clear so far? This is locally redundant storage. You have 3 copies of your file. Let us say the hard disk on which your one file is, this fails. You are still able to access your file from here and from here. If you add anything else, let's say I've added file2.jpg, what will happen is it will get created here and it will also get created here, file2. Whenever this hard disk is up, file1 will be replicated here and file2 will also come here. Understood so far? So in LRS, I have 3 copies of my files, but the storage is always available to me. So I am protected primarily against hard disk failures or a server rack failure within the data center. And you also get write access. That's what you need to understand. You also have write access when you do LRS. So again, these redundancy or these options, the redundancy options are to ensure or to minimize data loss. So just because one hard disk failed in my data center, if I come and tell you that you've lost your files, you wouldn't like it. So my storage, again, this goes to storage virtualization. I don't want to dive in that deep, but the access to storage for both read and write is available in LRS, but you only have 3 copies of your data. So this gives you protection only against hard disk failures or server rack failures. Without selecting this box, yes, but you are able to also write. Remember, this is only locally redundant storage. It's like the you have 3 hard disks on your laptop. Even if one hard disk fails, you'll still be able to write or read or still have access to storage. That is how LRS works. The moment you go to GRS, what happens is there is one hard disk on your laptop and there's one hard disk in my laptop, and the data is continuously replicated from your laptop to my laptop, right? Let's say your laptop is in Hyderabad, my laptop is in Chennai, or let's say some other country for that matter, right? A different region. So data continuously gets replicated from yours to mine. And in case your laptop dies, which is your entire region dies, and if you still want to read the data, you need to check that box. If you check that box, you'll be able to read the data from my disk. If you don't check that box, once your laptop is online and your storage is okay, I will copy the data from my hard disk to yours. Choose LRS for now, unless you have enough credits and you want to play around with that. So I'll probably choose LRS. That's enough. We'll not dive into the rest of the options. Well, if you choose LRS, you don't have to worry about that checkbox firstly. Okay, there are other options. If you look at those, we'll explore those quickly. So from a security perspective, you can ensure a specific TLS version. Uh, you have multiple access protocols. You can also replicate across tenants, right? This is where you see a hot tier or a cool tier. I'd probably just choose hot for now, right? For Azure files, you can enable this. So this, if you check this box, basically it'll allow you to create file shares which are greater than 100 GB in size. Okay. Now, data protection, again, let's not dive into all of this. This is an ocean, like I said. Storage in itself is an ocean. But for now, let's just create a storage account, right? Click on review. We've done nothing. We're just creating an LRS storage account. It is only for blob storage. So once you create a storage account, you can choose it there, or you can choose. So hot and cool tiers, you can switch even within the storage account once it's created. All right. So once you click on go to resource, once your deployment is complete, you should see a page that looks like this. Now we talked about 4 different services. So the 4 services that we talked about, they're right here. You see the blob service. You can see all of these options right here. Okay. So default access tier that we have chosen is hot. There's anonymous access to blobs, which is currently disabled. You can see all of these. There's soft delete options. Now, what the soft delete options mean is, in case you delete anything in your blob, right, you can still retrieve it. It's like your recycle bin. Okay, let me put it in simpler words. So blobs and containers, So this is like the recycle bin, so you can still restore it back, right? It's not a permanent delete. You can change these options, you can configure these options, right? So this is all part of the blob service. Now here, if you see, there's a file service. So this is Azure Files, right? The second type of storage that we talked about. A large file share is currently disabled. Like I said, large file share is in case you want to use a file share which is greater than 100 terabytes. Okay, so this is the file service. So you can consume this, and then there's the queue service, and then there is the table service, right? So four different services available the moment you create a storage account. Now, if you want to explore all of those, on the left side, you see these are the four services which are part of the data storage menu on the left side. You can click on containers. Containers is essentially blob storage. So what you can do if you want to play around and see how the storage works. So go ahead, click on container, create a container. This is not globally unique, so call it whatever you want. Create a container, and once it's created, click on it, then go ahead, upload a file onto it. Yeah, just any image if you have. I'll upload. You can click on upload and then drag and drop an image. I'll show you how storage works. This is like a simple activity. Just create a container, copy an image onto it. Okay. Once you click, once you've uploaded the image, you can click on that image itself, and you'll get a URL. Okay. You can copy that URL, get an image from anywhere. So if you have done what I have done, the image will not load because and you'll see an error which says public access is not permitted on the storage account, blah, blah, blah. So if you're getting the same image, now one thing we'll have to understand is the access tier. And there's a reason why I didn't mess with that earlier. Okay. So two types of access levels that are available on blob storage. Okay. One is public access level or anonymous access level, and one is public, the other is private. If you see, if you click on containers, you'll see that the container that you've created has a private access. The anonymous access level is private. So unless you authenticate, you would not be able to see the image. So for now, what we'll do is we'll just switch the access level. So you can just select your container, and there is change access level. We'll change it from here. We'll go to the overview. Let's see if we can edit this. So in the page, if you click on overview, you'd see something called blob anonymous access. You can click on disabled. So it's going to now, you can edit the configuration in here. Okay. So we'll just switch to allow blob anonymous access to enabled and save. Has anyone not done this yet? If you're able to access your image, great. But if you've done what I have done, I think the default option now it will choose disabled. So all you need to do is, so once you are in the overview, under the blob service, you would see blob anonymous access. Do you see this? Blob anonymous access, which is showing disabled. Please click on that. Once you click on disabled, it's going to show you the configuration. Look for blob anonymous access, switch that to enabled and save. So there are some things you can change after you provision the storage account, and there are some things you cannot change. One of the things you can change is access tiers, but what you cannot change is the redundancy. Okay. So once you've done that, you can do the same thing again. Go to containers. Let's change the access level now. So now you would see you can choose anonymous access to the container itself and click on OK. So now you should be able to access the image. I'll just refresh this image. There you go. Use cases for blob storage and where you would use, right? So in case you are running any website. For example, this website from Azure, it has all these images. Where are these coming from? All of these images need to load, right? This banner, these images. If you can see the image without any modifications, then you've got that configured without anonymous access. So it's fine. For those who ran into that issue, you just had to change the access level, right? Now, if you want to share this image, if I give you this storage link to everyone, anyone who clicks on that link, you'll be able to see the same image in your browser, right? So blob storage. Now, what this shows us the ability that we get with blob storage, that wherever you create the storage account, it is accessible globally, and you can put in any data in it. You can share a PDF file, you can do whatever. File I gave private, yes. Okay. So what you would have done is, if you look at, let's go back to this, to the containers. So if you give the anonymous access level as container, so it gives read access to containers and blobs. Okay. So whether your blob is private or not inside this wouldn't matter. So if you change access level here, let's try this. Now, if you switch this, let's see if you are able to load the image. So now you wouldn't be. Now, basically what would happen is, if you give access at a container level here, right, which is what we've done, where I switched what was there inside, right? So at a container level, so you have to be careful about your access levels, okay? So if you do this, if you give access to blob, anonymous read access for blobs only, then you can read this. It says blobs within the container can be read by anonymous request, but the container data is not available. Okay. So basically, it works in scenarios where you've got only one file or you want to control access at a blob level. Okay. If you give it at a container level, then any API requests can enumerate all the blobs that are available within the container. Managing access totally depends on the use case and also on how the permissions behave. Okay, so we've done this hands-on storage accounts that we've deployed. So why blob storage? I think again, we'll go through the slides. You store by large binary files. You can store audio, video, text file, whatnot. Again, access tiers are right there. Okay, we have seen access level. You can also see the access tier here. Okay, so the access tier says hot. You can switch the access tier or change the access tier of any blob to cool. I think they've now introduced cold as well. Things keep changing. Uh, and you can switch the access tier to, let's say, cool, and then save it. This is going to switch this, right? It'll take a while. And from cool, you can go to archive also. So if you switch to cool, it's already loaded, so it might not. Let me just try to load the image again. See if it makes any significant it's already cached, so don't worry about it, right? And you can also use blob storage to as a container. You can use a container for logs. So you'd already see the moment you create blob storage, you'd see that there's a container for logs. So you can store in application logs in here. So blob storage can be used for a lot of things. If you are sharing crash dumps and whatnot, you'd need a scratch space, right? So you can use blob storage for that as well, right? So these are basic use cases of blob storage: audio, video, text, log files, crash dump files, whatnot, right? So we've talked about what blob storage is. Again, I will go through the slides quickly. So you can store unstructured data. You can store it in any format, right? Any binary format. And as we discussed earlier, blob is an abbreviation of binary large objects. And you can store data of any format for distributed access. Okay. So file storage, again, file storage scenarios are a little different. As I mentioned earlier, the file storage is specifically when you want to share a common storage point across multiple computers. I'm clear. You cannot change the anonymous level access level for an individual blob. Anonymous access level is only set at a computer. Okay. So file storage is primarily for network file shares, right? If you want a common drive across multiple PCs or even Linux machines. I think now blob storage or Azure files also, you can mount Azure file storage to Linux machines as well. All right. So file storage is when you would need these kind of scenarios, right? Usually at work, you would have seen shared folders or public folders and whatnot. Those are typical examples of file shares. Now with Azure Files, you can set up a file share, a cloud scale file share using the Azure file storage. So the scenarios where you would use these are, if you want shared application settings where you want to store the configurations in a centralized location, which can be accessed either by a file REST API or it can be through an SMB protocol. SMB protocol typically is, the way you would see it is you'd access any file or a folder by using these two backslashes, right? And then you put in a server name or a file share name and then the file name, right? So that is the SMB protocol. It works on port 139 and 445. Second scenario is where you'd use a file share is as a diagnostic share. So you can have your crash dumps put in there. You can have the logs or metrics put in there in case your applications support only the SMB protocol. If they support REST, then you could probably use blob storage also for this. Again, uh, for your dev test scenarios or debug scenarios, if you've got separate tools that you would want to use, right? Exe files, or there are some binaries that you'd want to use for your debugging scenarios or in your dev test environment, you could use an Azure file share to store them. All right. So what is file storage? Again, we keep repeating ourselves. The fully managed service that's available on the as a service from a storage account. It leverages the SMB protocol, and you can mount them uh, uh, to your on-premise servers, whether they are Windows, Linux, or even Mac OS. Right. Again, benefits very straightforward, just like the benefits of the rest of the cloud. It's fully managed, so it's basically file share services available as a PaaS service, right? So you can create create file shares without having to manage a file share server, etc. Of course, it comes with resiliency, and the standard the reason why you'd use a file share is shared access any which way. So if this is, once the English is over, let's switch to the portal and let's create a file share. Okay, so now we look at file shares, which is the second thing, right? You can use the same storage account. You don't need to create another one, right? So all you need to do is go to file shares, the second tab under data storage, second option, and click on create a new file share. Give this file share a name. It will only take lower cases. So just give it a name. The tier, now there are multiple tiers available. Now here you would see IOPS. Someone asked this question, IOPS, right? So what you get with a file share is about 1000 IOPS, which is input output operations per second. And we have disabled large file share. So basically we can go only up to 100 terabytes on this, right? So pretty straightforward to create a new file share. Just give it a name, choose a tier and click create. Now there are options that it is showing all of this. I don't want us to do that because deleting becomes a pain. So if you are seeing these options enabled, I'd ask you to go to the backup and just uncheck enable backup. Okay. Do not create a backup. It's a pain to delete the vaults. So we'll do the backups hands-on once we get to the backup topic. But for now, in the backup option, just uncheck enable backup and create your file share. This takes a minute and you would see it's already created a file share. So once the file share is ready, how do you connect? So now we'll do that. So if you have this ready, again, it might work for some, it might not work for some. Totally depends on your ISP. Okay. So you need to understand this. Few of the ISPs do disable 445 at the network level. So few of the, depending on who your internet service provider is, you may or may not be able to mount the file share directly. Now, I know for sure that my ISP has blocked it. I use Airtel. I've tried it with a different option with Geo as well, but it's still the same. But let's ACT. If anyone's on ACT broadband, it might work for you. So how would you connect? Simple. Just click on the connect option right here. It's going to give you a script which you'd have to run. Okay. The moment you click on connect, you'll see a pop-up that shows that asks you to choose your operating system. So you can choose Mac OS, Linux, or Windows. Since primarily most of us here on this call are using a Windows machine, leave everything for default, everything as default. The drive letter is what it will get mapped to. The drive is going to, or this file share is going to get mapped to on your machine. So you can leave it as Z for now. Click on show script and you will see a script that is generated for you, which you need to run. Once you've copied that, once you're on the screen, you would want to launch PowerShell ISE. So just type in, click start, type in PowerShell, and you will see something which says PowerShell ISE. You can click on that and it will show you something like this. Once it shows up, copy or paste your script in here. This is not rocket science. This is the script that is coming. All you need to do is just run the script. If your ISP has not blocked 445, it will connect. If your ISP has blocked 445, you will see what I am seeing on screen. Yeah, host is unreachable. So I know for sure that my ISP has blocked it. Yeah, if your ISP hasn't blocked it, guys, you can just open Explorer and you would see that there is a new drive that is mapped, which will be Z drive. And what you can do is copy a file from your machine shared onto that file share, and then we'll check if it is coming up on Azure or not. But for those who have connected, copied, the way you can validate it is click on browse on your portal when you're on the file share, and you should be able to see the file that you've copied here. Yes, you can map it directly to your machine, or you can map it directly to the server. You can map it anywhere. That's how easy it is to create a file share on Azure. Good. Sometimes the simplest explanation is the best explanation. And not everything is rocket science, okay? The cloud is not rocket science. It's just compute network and storage. It's just different ways of doing the same old things. I don't see Z drive in PC. It means that you have not mapped your drives, Sandhya. Did the script run or did it error out? If you saw these kind of errors, that means it says connected. Okay. If it says connected, you should see the Z drive unless you've chosen a different drive letter. There is no UNC path, right? So you'd have to map via a script. A UNC path means that you have a server, but what we are consuming is a cloud service. So you can map it using a UNC path. This is the UNC path. It's available in the script itself. This is the UNC path for your file share. The username and password are also here. It will be localhost, your storage account name. The password is the account key. We'll get into details about what the account key is, but if you want to map using a UNC path, you can use this. You can access it via web and also locally. OneDrive is again a similar solution. So basically what they use is file sync. They use the SMB protocol to deliver the file to you. A file share specifically is totally different. Uh, it's very specifically running on the SMB protocol only. File shares versus what you're talking about, cloud storage, those are two different aspects. So if you access it via web, you're doing it via the REST API or you're accessing it like you're accessing blob storage. You can mount it. The mounting so to mount it, you'd basically install an application. What that does is it downloads all of those blobs and it saves it as files on your machine. Okay. So you would be, if you are using a Dropbox agent or a client or a OneDrive client, That is basically the bridge between your blob storage on the cloud versus the way you are seeing it on your PC. Again, before we move on to tables, I'll probably walk you through a couple of concepts. Okay. So one thing you would want to see is if you go to blob service, I talked about the way you access things, right? So if you look at the image that we have, you see this URL that is structured. I'll copy this and put it in Notepad, make it bigger. So you see the structure of the URL. Okay, this is your storage account name, and then you have blob.core.windows.net. This is your container name, and this is your file name. Okay. Now, similarly, if you look at the service URLs for your file shares, it'll be file. Okay, and in the script, I think that is where you have it, right? So if you see this, the UNC path, the way it is mapped, I'll copy this over onto Notepad. You see the UNC path for this. This is again your storage account name, and then you have file.core.windows.net, and then your file share, right? So your storage account, like I said earlier, this is your umbrella storage. So you can have multiple services. So if you want to use only blob, or you can use blob, files, queues, everything under one storage account. Okay. So these are the service URLs. So just by looking at the URL, you can tell what kind of service is being consumed. Okay. If you click on the file share, you'll probably see it. Yeah. So this is the share URL, file.core.windows.net. Let's see what happens if you put this here. See, it's not going to open it up, even if you use that share URL, primarily because you're trying to access it from a browser, and that's not the protocol or the port that the file share supports. These are the ones that will be widely used. Okay. So you can give multiple permissions here. You can configure identity-based access. So you can configure identity-based access here. You can connect this to ADDS. I think Azure AD is now being called Microsoft Entra. So names keep changing, but this still is Azure AD. There's no use of that URL. Don't worry about it. It's more about understanding about the service. If you just need to switch this to the UNC or /backslash, and that's how you'll be able to access the file share. You can configure NSGs for file shares, but that's too advanced, right? Now you can enable identity-based access for someone who asked how you'd control permissions. You can set the default share permissions also on the file shares. Again, soft delete is there, security. There's a lot of settings that you can change in these as well. Right. The next concept that we have is around tables. So we'll go there. Okay. So table storage, as I mentioned, thinking about blobs. You wouldn't configure NSGs for this. You can consider or you can configure NSGs or public access at a blob level primarily because that will be public access, right? For file shares, you still need to mount it as a drive, and for that you need credentials. So there's no NSG per se for your file share itself, but for accessing the storage account over HTTPS, you can configure specific firewalls, more like NSGs. If you want to have this access privately, then you basically create a private endpoint and do that. But that's all advanced. Let's not get into that. But you would still be able to do firewalling. High level at here, you can select specific virtual networks. Uh, you can enable access from all networks, or you can create a private endpoint connection. You can also add a custom domain. So there's a lot you can do on your storage account in terms of access. Okay. Now let's switch to table storage, right? So tables, again, as I mentioned earlier, tables are primarily, or the Azure table storage is primarily NoSQL database in the cloud. right? Now, there are multiple data sets. Typically you'd use NoSQL database, or the way you are putting in or getting in the data, you can query them a lot more faster, right? That is the reason primarily why you'd use a NoSQL DB. You can store flexible data sets and a number of entities. Okay, what's important to understand from a storage, from a table perspective, is that a table storage is typically a key value store. Okay, so the best way to understand that is to go ahead and create a table, right? So let's do that. We can create a test table, for example. Go ahead, create a table. And now there is a URL also that you'll get for the table once you create it. Okay, I'll copy this URL. I'm not able to copy it. Okay. But if you see the URL closely, you'll see it says table.core.windows.net. Okay, so that's how you'd identify the different services. So the what are the many properties which are common, and an easier way to identify what service you are picking up. Now, what we'll do with this table is, let's go ahead and create a couple of entries. Now, there is way to do it. Before we get to Storage Explorer, there's still ways where we can browse through this table and try to create entries in it. So once you created a table, what you can do is click on Storage Browser on the left menu here. Once you click on Storage Browser, you'll be able to see all of these, the options: blobs, file shares, queues, and tables. Click on Tables, and you should see your test table, or whatever is the table that you've created. And once you click on that, now you would be able to see or add rows in here. Okay, so they don't call them rows in tables, right? So they call this, so similar to a database row. What you have, or what you can create, or what you can add, is an entity. So if you click on add entity, the moment you click on, or before you click on add entity, what I'd like you folks to observe are these three things. So there is a partition key, there is a row key, and there is a timestamp. Okay, so these three things together, these three are mandatory uh, entities, or mandatory columns, let me put it that way, for your row. So a combination of partition key, row key, and timestamp will be your primary key. Partition key and row key. A timestamp is also added for you to be able to query, right? So these three properties, these are the three system properties that are common for every entity. Now, if I translate that into a database term, it is basically saying these are the three columns which are system generated for each row. And you have to, I mean, they're not system generated, but these are mandatory columns for each row. Okay. So this is the typical way in which a NoSQL database is created, right? Now, if you want to understand this better, let's go ahead and click on add entity. Let's click on add property. I'll call this property a name, a string. Okay, so the partition key is 1, row key I'm adding as 1, name as string, I'll add in my name here, and then I'll add, let's say, location, string, Hyderabad. You can add as many as you want. Okay, switch it to, so the data types are limited here. You can get string, there's Boolean, there's datetime, double, GUIDs, a 32-bit integer, a 64-bit integer, and a Boolean or a binary value. Let's say I'm just adding it. It needs a base 64. Forget this. Say Boolean 1 needs true or false, right? So you can create whichever ones you want. Irrespective of the rest of the properties, what I'd want you to understand is the reason why querying tables is faster. Okay. So keep your eye on the partition key and row key. Okay, so as of now, I've given 1 and I'm inserting a record. Okay, now this is my first record. Now what I'll do is I'll add another one, partition key as 1, but row key as 2, and then I'll probably add the rest of the. Okay, one thing you can observe here is the partition key and the row key cannot be same. You can have multiple row keys within the same partition key. Does this make sense? If you try to add the same thing again, for example, 1 and 1, it will not be able to add it. Okay. So the combination of the partition key and row key in tables constitutes your primary key or is analogous to your primary key in a relational database. I mean, I don't want to compare it with relational, but uh, an analogy, right? Even if I try to do 1, 2, it's a composite key. Yes, you can look at it that way, right? So now if I say 1, 3, okay, and I insert a record, okay, I've inserted a blank one, but that's fine, right? Now I'll switch the partition key and I'll add another record. So these can be the same. Location can change, whatever. Just add some junk. The partition key. Now, the queries are typically faster because within the same partition key, you'd be able to query things or you'd be able to query the data a lot more faster. Okay. So a table in our scenario or in this scenario, in Azure tables, a table primarily is a collection of entities. What are entities? Entities are the records that we've added. Okay. That's the basic, the first concept. Second thing to understand is the primary key in Azure tables is a composite key which consists of the partition key and row key. Well, it's not exactly a relational table primarily because you don't have to worry about joins or complex joins or other things. That kind of concept does not exist here in NoSQL. So if you want to query something, join a couple of tables together and do that, that does not exist here. And the second thing is if you are querying large amounts of data, let's say for analytics or whatnot, it's easier to query the data within the same. So you can run parallel queries on the same table in multiple partitions. That's the advantage. Okay, you can probably explore the differences between a SQL and a NoSQL DB, right? SQL databases or relational databases, on the other hand, they are, they work on joins. There's a concept of a foreign key, and it's all relational data. Whereas here, it's not that. Now, using a partition key, basically, you would be able to load balance also here. What we mean by load balancing is running parallel queries, right? Now you can run parallel queries on multiple partitions at the same time if you are using an NoSQL DB. You can still people don't use Azure tables much unless your ask is you're doing you're cost conscious or you want to stick to tables. There's quite a few use cases where Azure tables were there. When Azure tables launched, it was consumed primarily because it was one option for people to start consuming a NoSQL database. Okay, yeah. What is Azure Table Storage? Again, quick recap. It's a NoSQL key value store. You can put in large amounts of structured data in there. You can store structured, non-relational data. When would you use this? Again, scenarios. If you want to use, store in large amounts, when I say large, it's like terabytes of data to serve web scale applications. One possible use case, you're trying to use data sets which don't need complex joins or foreign keys. And in case you want to be querying data quickly. So for example, you've got device data, if you're running IoT kind of scenarios and whatnot, where your sampling rate is maybe once per second or multiple times per second. right? And you want to query such large amounts of data. So you would probably, and the data is coming in from, let's say, hundreds of thousands of devices across. In those scenarios, if you want to query them, all of that data can be put in multiple partitions. You can run massive parallel queries, right? And that's where, compared to a relational database, a NoSQL database or Azure tables for that matter is going to uh, be a better scenario. So data lake storage again, data lake storage, you can use a Cosmos DB. Again, data lake storage can take in data in any shape, size, or form, right? Now, ideally to ingest uh, good data, proper data, you'd probably want the data to be ingested through a data factory or a data pipeline or an ETL job, right? So, the scenario that you going to be more of a data architecting kind of a scenario where you would want to bring in or clean up the data up front or write a proper ETL job, ingest all of that data into a warehouse or data lake storage, and then start running analytics on it. Data lake storage would be preferred, right? Now, when you use data lake storage, you can have, you can choose what type of content is coming in to that. I'll show you the data lake storage and the option that you have. I'm not much of a data guy, so I can't dive deep into or speak much about data lake storage itself, but we can explore that on the portal to see what type of storage would typically come in. Now, you definitely use storage accounts in the backend, or you would use let's say Cosmos DB, which eventually would use storage in the backend, right? So for those, your files and everything would probably stay in a managed storage, which eventually will still be consuming a blob storage in the backend, right? So just like we talked about uh, PaaS services being built on top of IaaS services, there are a lot of services that are built on top of storage accounts. So if you are using Azure SQL, for example, or you are using you're using things like Cosmos DB, or you are using PostgreSQL, in the backend, it is still going to be storage account, and it's primarily consuming premium blob storage in the backend, right? Storage concepts, again, these slides are pretty straightforward. URL formats, we've already talked about those. Accounts, again, accessing storage, you do it via storage account. Table, we've talked about the table, concepts of the table. It's a collection of entities. An entity is like a database row. And the properties, we've talked about the three system properties: partition key, row key, and a timestamp. And entities with the same partition key can be queried more quickly. That is how you are able to run massive parallel queries. From the keys perspective, we've talked about this. Every entity has a primary key, which is a composite key, including the partition key and the row key. We just saw that here, right? So the partition key and the row key together form a composite primary key, and you can run queries against each partition key. So multiple parallel queries can be run. To partition a table to support load balancing, that's the concept that we talked about around being the ability to be running parallel queries as well. It is used to identify the partition that an entity belongs to. Straightforward. Row key is to be able to uniquely identify a record within a partition. And again, this is what we already discussed. Partition and the row key together form the primary key or a composite key uh, for the entity or the record itself. I think all we have is hands-on. We've already taken a look at the table. And I assume you folks have created it. I don't focus much on tables and queues. People hardly use them, but they're still available in case you do get questions in the exam. But from an enterprise scenario perspective, these are hardly consumed, right? Storage queues. So for queue storage, as I mentioned earlier, right, the hands-on is a little tricky. So storage queues, again, why would we use them? These are primarily used, again, as the name suggests, you would put in messages so that other processes can read and process those messages. So, for example, I think I don't have a better example than the one that's on the slide. Uh, A message might contain the email address of a newly signed up user. Another process can come, read that message, and probably send a welcome email, for example, right? So again, these are typically for large number of messages, large scale processing. One advantage again that comes without saying is you can access the queue from anywhere because it's all HTTPS based. The concepts are pretty straightforward. Again, the URL format, you can see it will be queue.core.windows.net and then the name of the queue itself. Uh, Queue can contain a set of messages. The queue name should be in lowercase. These are the smaller things that will probably help you in the exam, or there might be a question here and there around that. The messages, the important block to understand though, is that a message can be in any format, but it cannot go beyond 64 kilobytes. Now you can, and each message has a time to live as well, right? So you can configure that. So a message, if it is not consumed by a process within, let's say, X amount of time, the message can expire, or you can set the message to be expired. So the maximum time to live is any positive number is allowed. If you put in -1 in there, it means that it would not expire. The default time to live is 7 days. These messages are for asynchronous activities, right? If anything is a synchronous activity in an application, you probably pass the baton on, right? But for any async operation to happen, you can post a message in the queue and another operation can come and read the message and then consume it. So, for example, let's say when an order comes in, you want to print a shipping label, right? So you can push that onto a queue and say, okay, print this label, print this label. Now the label printing can happen asynchronously, right? And maybe once in an hour you can check if, let's say, the time to live for that print message is 1 hour. If it hasn't, and if that has expired or if it hasn't been consumed, it's going to expire, right? So any asynchronous activities like these can be put in queues, and it'll essentially be applications or microservices or any other apps that can go ahead and consume these messages, right? And that's where you'd use queues. So while the but what we do is let's go ahead and do a hands-on ourselves, right? It's pretty straightforward. So you can click on queues, just like where we clicked on tables, right? In the same storage account. Let's go ahead, add a queue, test queue. And once you click on the test queue, you can see there's adding a message, dequeue a message, and clear the queue. So what we'll do is, so this message text, it can be in a JSON format, it can be in any format. Only thing we need to understand is it needs to be lesser than 64 kilobytes in size, right? And then you can set the expiry uh, time. So you can put seconds, minutes, hours, or days. The default is 7 days. You can also choose to say message never expires, right? Now, what happens when you create this is the message just sits here. It's got a ID, right? So I'll add a couple of messages here. Let's say, for example, print two. Now I am expecting, let's say, a label printing application to come and read these messages, and it is going to print whatever is the text in here. Service bus messaging is different. Service bus messaging is totally separate. This will have topics, subscriptions, transactions. These are all event driven, right? You can obtain a message, transactions, you can do these. The service bus will work, is a lot more powerful as compared to queues. Okay. So in here now, if you want to dequeue, what you would do, the moment you say dequeue, which message do you think is going to get consumed first? So I've created print one first and print two next. So it will remove the first element. What is the first element in here? So in the order of insertion, the message that was in there first vanished, print one. And then if I dequeue this will vanish as well. So I don't have any more messages to be consumed, right? So that's how queue storage works. First in, first out, yes. It will not always guarantee first in, first out. That may be true depending on the number of messages. But I don't have an answer to that question. But I believe based on what I just saw, I can just still say it's first in, first out. But let's keep that option open, or if someone can do a quick research, that will help. Yes, it has to be associated to an application, right? So someone's posting a message, someone has to go get that message or pop that message, right? Like I said, you can use queues in a asynchronous environment, not for a synchronous activity. Primarily, that is where you would consume at least Azure queues. Where you're talking about WebSphere, Message Broker, you're talking about Service Hub, Service Bus, Event Hub. Those are totally different altogether. Those are event-based, trigger-based, and they are built for a different purpose. Well, you can use a REST API. Again, if you want to understand that, like I said, please look at the hands-on lab. Uh, you can deploy the messages, you can post messages using a JavaScript, and you can consume messages also from JavaScript or basically any other uh, thing, right? You would access the storage. You can access Azure storage and post a message in a queue. All you need is the queue name and whatnot, and the access keys, of course, to access. And you would be able to post it. You should be able to post a message, add a message, and you should be able to pop a message, which means dequeue a message or consume it. Take a quick look at what Storage Explorer is, and then explore the SaaS tokens. So coming to Storage Explorer, so in our hands-ons earlier, we've seen, we created a storage account, we kind of played around with that, right? So Azure Storage Explorer is it's today's session is 1.5 hours, uh, Bala. So tomorrow will be 3 hours, right? So Storage Explorer is a standalone app. We can play around with storage within Azure. Across multiple subscriptions, across accounts, and also it gives us the ability to add a storage account without the need to sign into Azure, right? So one single application that helps us manage Azure storage. Now, in case there are questions around, hey, who's going to use this application, then it is primarily folks who manage storage or storage admins who can use this application. Alternatively, there are developers who can use this application to maintain the content within the blob storage, right? Right. So again, it's a free to use standalone application that we can use. It is like a client, but it's more of a desktop client, right? Now, you can definitely use REST APIs to programmatically access blob storage or things like that. But from a standalone application perspective, Microsoft provides us Storage Explorer, which we can do a lot of things with right now. When it comes to understanding what we can do with it, so in terms of blob storage service on the storage account, we can view, delete, copy blobs, folders, upload, download, manage snapshots. Quite a few things which usually you're able to do using the portal. You would be able to do it using the Storage Explorer. Queue storage, again, as we looked at queues earlier. Yes, please go ahead and install it, Deepak. Queue storage, you can look at the most recent 32 messages. You can view, add, dequeue messages. You can clear the queues. From a table storage perspective, again, we've created tables or we've created entities, right? So you can now query entities with OData or using Query Builder. You can add, delete, create entities, import and export tables and query results. And from a file storage perspective, again, pretty straightforward. You can navigate uh, through the directories. You can upload, download, delete files. Essentially, whatever you would expect to do as a storage admin, you would be able to do it using Storage Explorer. So what we'll do is go ahead and install Storage Explorer. Post that, what we'll do. Okay. So once you've downloaded and installed it, it's pretty straightforward. Next kind of installation. So what you can do right after is log into your portal. Okay. So you can log into your portal, and what I'd ask you to create, go ahead and create a storage account. I already have one, so I wouldn't create one, but please go ahead and create a storage account. Should take about 3 minutes to wrap up. Why are we downloading explicitly? Yes, so it is not available to the fullest extent of capability within or on Azure portal. Right now, on Azure portal, what you can see is storage browser. Right now, this is kind of the web version, but it is limited in terms of what you can do. Right, so when it comes to tables, you can look at tables, but when it comes to querying or things like that, you wouldn't be able to do it from here. On blobs as well, right? While you can take a look at these, you can play around, you can do most of the things on the browser itself, uh, not needing Storage Explorer. But Storage Explorer is purely in terms, it's a little more powerful than what is available on the web. Now, what we'll do is we'll attach, or we'll look at ways to attach Storage Explorer or attach the storage account. Okay, so let me sort this out. Let me disconnect this. So the first thing we'll do is you can see once you launch Explorer, I'm assuming you folks have the storage accounts also ready. So on the left side, you'd see a connect menu, which is this. So go ahead and click that. Once you click, you'll see the options. It'll say connect to Azure Storage. So the way we'll do it is we'll choose storage account or service. Once you click on that, you'll see the connection method. Let's choose account name and key. And once you click on next, it'll ask you for providing information, which is the display name, and account key. So display name is straightforward, whatever name you want to provide this. I'll just call it testing storage with key. Any name is fine. It's not unique. The account name is the storage account name itself. So whatever is the storage account that you've created, we will use the same name. And the last option, which is account key, the way we will fetch it is once you're on your storage account, on the left, under the security plus networking menu, you would see access keys. So you can click on access keys, and it's going to show you that there are going to be two keys. We'll choose any one. So click on show for any key, the button here, which says connect, or it looks like a plug, right, on the left. It's right here. Yeah. If you click on that, if we sign in, see, if you sign in, you'll be able to see the entire subscription, right? So that's one way of doing it. So you'll see all the subscriptions and you'll see the storage. So that's one way, but that's kind of understood. So the way we'll want to do it is using the account name and key, so that we are able to show that even without needing your account, right, you'd still be able to provide or access the storage accounts. Once you click on that plug kind of account, you'd see it'll ask you to select storage. Sorry, select resource. And in that, choose storage account or service. Use account name and key, option 3, and click on next. Now it'll ask you for 3 things. Provide a display name. Any name is fine. The account name is your storage account name that you have created. So you can use the same name as the account name. Now the account key, this is how we are connecting. So the account key, the way to fetch it is once you go to the storage account, let me navigate to my storage account. Once in your storage account, You'd have to create one of these. That was our ask, right? Let's go ahead and create a storage account. In the security plus networking tab, you will find access keys. Now remember, access keys are the master keys to your storage account, so you'd have to keep them safe, right? And that's why they don't show them here. So with these keys, you basically get root kind of access, right? Admin kind of access. Now on key one, click on show and copy the key. Once your key is copied, paste it in the account key section and click on next. So I'm on the summary page. Okay. All we need to do is connect and you're going to see all the services, blobs, files, queues, tables. So you can upload. What I want you folks to do is upload anything, upload an image on here and attempt to get the URL. Please go ahead, drop in an image in here. So just click on upload and just upload an image in here, right? Basically, this is to show that, how you're able to play around with storage, right? So now that you're connected, one thing you would have to realize is, you connected without the need of signing into the portal, right? So now we have connected using the keys. Just drop in an image, right? Upload an image. Any image is fine. Upload an image, create a container, upload an image. I know you've done this already earlier, right? So it should be straightforward. Just put in an image. So once you upload a file, right, it's going to be as good as doing it through the portal, right? You can right click on the image. Once you've uploaded it, you can see you can do a copy URL, and let's attempt to open that on the browser and see what we get, where we get. Okay. Okay. So so if you're not able to see the image, no issues, park it there. We'll get to the resolution of that using shared access signatures in a bit. But the intent here is that you can play around with the blob storage. You can play around with queues. Again, you can go ahead and create a queue, right? Just right click, create queue, and it's going to create one for you, right? Whatever we did on the portal previously, you'd be able to do from here. Same goes with tables. You can create a table, insert data. The other interesting thing is you can query the data. There's a no data, there's a query builder here. So yeah, so tables again we've seen. So blobs, just like you were able to upload, you'll be able to delete, you'll be able to create a new container, you'll be able to copy, clone. Once you right click, you'll see a lot of interesting things here, right? Same goes with file shares, right? You can create a file share just like that, create a new folder uh, within the file share, right? Now, mounting, unmounting, we've already taken a look at that, so I'll not worry about it much, right? So basically, across all four services, you would be able to play around with them by attaching the storage account using a key. One thing to understand is that the key provides admin level privileges, so you can add, delete, and do a lot. It's a lot more powerful. It's like your admin account, right? Now, what if you do not want to provide admin accounts? Is what we'll look into uh, with shared access signatures. The second option, which you can explore, is to sign in using a subscription or sign in using your Azure account. I'd say we'll park it. It's nothing different. The way you do it is using the same approach. Click on the connect dialog box, right? The plug. And instead of the storage account or service, you choose a subscription, right? Now, once you do that, it's going to list out the subscription that you have, access to all subscriptions, and it's going to look the same. Okay, so I don't want to spend time on that. That's pretty straightforward. So take that as an assignment or a hands-on, and you can do it later, or you can do it now. It's up to you. Okay. The next thing, like I said, we'll discuss about is the shared access signature, right? Now, what is shared access signature and why we'd use it? Not found. Yeah, that's fine, Karuna. That's fine. Right. That is what we want to fix in the next topic that we're talking about. So if you're not seeing the image, absolutely okay. Right. So where, there might be scenarios where you do not want to give the keys to the kingdom to anyone or open up your entire container and set its access level to public, right? Because there might be data you don't want them to see while they might be part of the same container. But this is where a shared access signature or SAS comes in, right? It's a token. So just like you have an access key, right? Now using the access key, people can do a lot of powerful stuff, right? So they can create, they can delete. Yes, kind of, right? Almost. It's not just the timing, but it's also about the kind of permissions, right? So the shared now access keys that we retrieved, right? These access keys are these will authenticate. This give you admin level permissions, right? This key will give you admin level permissions, and that's why there are two keys, right? Usually for an enterprise, they also rotate their keys. Someone has their own key, etc. Right? So if you want to give an application access or you want to give someone access, but you want the access to be limited in terms of permissions and limited in terms of uh, timing, right? This is where the shared access tokens or SAS tokens come into play, right? Now, the way we can generate those is, both ways. If you want to explore that using the portal, you can do that. Or if you want to do it using Storage Explorer, you can do that. It's all the same, right? So if you are on the Storage Explorer, right click on your image and click on Get Shared Access Signature. It's going to ask you an access policy. Forget the policies. We're not worrying about them. Just leave it as none. So there is a start time and an end time, expiry time. Okay. And if you see the permissions, right? For now, we'll just give read. But what you can see is you can give read, delete, add, delete version. You can create a permanent delete. There's multiple permissions you can provide, right? For now, we'll only give this SAS token a read permission. Okay. Once you are on this page, all you need to do is click on create. So once you click on create, it's going to show you. So this is the token itself. Okay. It starts with SV is equal to something, 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 all gibberish, right? Now, the way this is used is right after the URL. So what I'd ask you to do is copy the token. You can copy the URL and be done with it. That's fine as well. Read permission to the image. Yes. So read permission to the blob, not necessarily the image, Sri. So what we are doing here is we are generating a token for that file that we've uploaded. Now, in the same URL where initially it failed, the way we pass the token is a question mark right after the file name, and then you paste the token. Still fail. Oh, I have to. Okay. And then it's going to load your image. Alternatively, just go ahead and copy the entire URL. That is fine. It works that way as well. It's not rocket science. So copy the entire URL along with the token. You can paste it, and that's going to load the image. One thing we'll have to understand is now we have been able to read the image or read the blob without changing the access level to public, right? Now, generating SAS tokens you can also do from in here, right? Storage Explorer. If you are doing it on the portal, again, I'll just show it to you quickly. It's straightforward. Again, right click, generate SAS. It's the same page that you'll see, right? Only additional thing you'll see is the signing key. It will be one of the two master keys, and the rest is just straightforward. In terms of permissions, you'll see the same permissions that you can provide. and you can generate a token from here. Okay, so what I'll do is, see, on the portal, the way you generate a SaaS token is again pretty straightforward. Just right click on your image, click on generate SaaS, right? And this is going to generate the token, right? It will give you this page which shows, so SaaS token has a start time and an expiry time. So for now, leave it as default, and there are permissions as well. So choose the permissions that you want for this token. For now, I've just left it as read. When you generate the token, right, you'll see token and URL both are generated. So you'll see that there is just a token, right, which acts like your password. This token is valid only for a certain period of time, which is the start time and end time, right? Now, in terms of the URL, what I mentioned earlier was, let's say if you, this is my image URL, right? But this image is not opening because I do not have permissions. So how would I provide those permissions is right after the image, the way you can use the token is after the image name, at the end of the URL, type in a question mark. That means you're passing in as this as a query parameter, and then paste your SaaS token, right? So that is going to, in your URL, you have a token to access the image. It's like, passing in the password as a query string. Okay, so real-time examples, right? Now, there are multiple scenarios where you'd use a SaaS token, right? Now, if we were using, let's say, an app service environment, and your web application needs access to storage, right? Now, in an enterprise, you probably give one single storage account or multiple storage accounts. It's fine. But in terms of access control, SaaS tokens kind of work in a good in a good way, where, let's say, on your app service plan or your PaaS uh, web app, you're hosting multiple applications and they need access to storage. You create one container for each of the applications to store their images or their files or whatever. The way the application will access the blob storage is using a SaaS token. Now, the SaaS token can be set to expire in 30 days, 60 days, or also up to 1 year, right? Also, in scenarios where you're using blob storage as persistent storage for Kubernetes containers, for example, right? There, the way they would access storage is using a SaaS token. Alternatively, simpler example, your website has got, let's say you want to allow people to download a file starting from 5 p.m. to 6 p.m. That's like the most crude, simplest example that I can provide. Right? You can just generate a SaaS token, give the URL, and they'll be able to use it only for that particular time. Can we generate SaaS tokens through PowerShell? I think you can. I haven't. I will AZCLI. I have. PowerShell I haven't, but I'm sure you would be able to do that using PowerShell as well. Okay. So that's the bit on SaaS tokens. We'll do a quick recap. Shared access signature, again, it's a token that grants restricted access rights to storage resources. Now you can generate, using the SaaS token, you can have specific permissions on files, on blobs, on queues, on tables, right? Now these tokens can be used to provide access to the clients who are consuming the resources in the storage account without the need of sharing the account keys, right? Remember, account keys are the keys to the kingdom. So except storage admins, no one's expected to use those, right? What is SaaS and blob storage? Again, just as we saw, it's a secure token that allows us to specify the time span permissions that are needed on the blob or a container. The sample of the SaaS token, like you've seen, right? It's a question mark, SV or SP is equal to, and then it's the entire token, which includes the permissions, it includes the time span, and it includes whatever that you have provided to the token, right? Hands-on, I think we've already seen this, right? Generating a SAS key and then using an image. Okay. So let's move on to data factory. So data factory, initially we were talking, we talked about the possibilities of or scenarios in where you would use data factory, right? Now, this is basically a data integration service where you can where it create multiple workflows. So if there's anyone here on from the data side, you would know what an ETL job is, right? So you could have extract, transform, and load kind of operations, right? What you can do with data factory is create workflows that can move data from one source to another source, right? Which is what this image is kind of trying to explain here. So multiple sources of data, now these can come in from anywhere. These can be any type, right? With these sources, with multiple data sources, you ingest the data. Now preparation of the data, once you prepare, so 4 steps, we'll walk through all of these individually. You ingest data, you prepare, you transform and analyze, and you publish, right? A simple example would be in the storage context itself, right? So let us say you were creating a geo-replicated storage, or let's say you have chosen 2 regions on Azure. One region is India, the other region is US. And you have your website, your application, I wouldn't call it website, but your application running uh, primarily in the US with a DR in the, or not even a DR, but another copy in the India region. Now, how would you copy? Let's say your website is using or your application is using lots of files and images which are in a blob storage. A blob storage which is created or a storage account created in the US, there's a storage account created in India. Now, how would you copy data between these 2 storage accounts? Yeah, simple. Okay, easier way for you to understand this is there is okay. A very layman example would be there are files or there are photos on your phone, and there are photos that on someone else's, or you want to get these your pictures need to be in sync on 2 phones. These 2 phones are sitting are in the hands of one person in the US and one person here, which is you. So how would you ensure that the gallery is always in sync? Anyone wants to take a guess how you would achieve that? Yes, share OneDrive access. That is doing the replication for you, right? So that example, basically what is happening is you're both reading from the same source, right? You're signed into OneDrive, the other phone is signed into OneDrive. So basically you are reading only from one copy, right? But if you wanted to make sure that it's not the same copy, this account is different and that account is different. Yeah, Dropbox, again, it is a cruder example primarily because in that scenario, what is happening? Let me draw this out, right? So the scenario that oops, it's white in color. Give me a minute. Okay. The scenario that we talked about, there is a phone one, there is a phone two. Okay. Now someone said OneDrive, you said Dropbox, right? This is one account. If both of you are reading from this, you take a picture here, this will upload here, and it will show up here because you are using the same account, right? Now, what I want is this is user one, this is user two. He takes an image, picture. Okay. I want that picture to be available here. This guy takes another picture and he hides it or he tags it as personal. That should not show up here, right? How will I make sure that happens? Let's say his OneDrive account is different. His OneDrive account is different. They're all running their own OneDrive accounts. How will you sync the data from here to here? ETL pipelines, right? So basically what you need to do at this point, right? Now, this problem or this scenario is where typically you'd create a workflow. What do you want to do? You want to copy You want to bring in the data from one place. What you would say is a simple pipeline will look something like this, right? If I put together a flow, let me see if I can find a cleaner slide. Bear with me. I'll use this. Okay. So a simple workflow that we'll write so everyone can understand. First, once the image is taken, right, take a photo, take a picture. Once the picture is taken, I would rather say instead of take a picture, I'll just say go to the gallery. I hope at least even for freshers, the loop should be easy, right? So what I'd say is for each picture in the gallery, again, I'm trying to, English or code looks very same, okay? So don't think I'm writing. It is a for each loop for those who people who know, right? For each picture in the gallery, I'm saying, is it marked personal? Sorry, personal. So if the answer is yes, do not copy. The answer is no, I'll just say copy to destination. Does this make sense? The flow? It's a very simple workflow, right? Just saying in the gallery, look at each picture. If the picture is marked as personal, do not copy. If it is marked as personal, sorry, if it's not marked as personal, copy it to the destination, right? This is a very simple example of a data pipeline. Now, if we take it deeper into a technical context, there can be a blob storage in two different regions, right? With multiple containers, each container having multiple blobs, right? Now, what you want to do is keep them in sync, or you want to copy specific data, right? Based on some property, right? What is the property here? In the example, is it marked as personal, right? Similarly, in enterprise environment, there can be multiple other conditions. There might even be scenarios where instead of using the image directly, you want to transform that image into something else, right? Maybe you want to zip it or you want to clean up personal data in it, right? Now, for an image, it's probably a little difficult, but usually in terms of logs, right? You'd see if there is a lot of plain text where there might be some cleanup that you want to do. There is a person's name or there is an email address that you want to clean up before pushing the data, right? Those are scenarios where all of that can be performed using an ETL job where you extract, transform, and load. Okay. Now this is where data factory comes into play, right? So you can ingest data from multiple sources, you prepare the data, you transform it or analyze it, and then publish the data, right? Again, while these look multiple steps in terms of an ETL pipeline, right? But what is actually happening is extraction, transformation, and load. Okay, it's simple. Now, the previous workflow that we wrote, extraction was pulling the image. Now, we weren't doing any transformation per se, but we were doing a configuration. SSIS is integrate. Well, SSIS is very specific to SQL Server. Here, the data source can be anything. You can have an on-prem data source. You have a node. You have SQL. You name it. You've got Azure Tables, Oracle DB, whatever. It doesn't matter. Azure Data Factory is really powerful. Data cleansing, you can. It depends, not natively. I mean, I'm not a data guy to answer that question, Syed. It's probably a little deep, but let's see. But I believe you can do data masking, right? Even in a couple of organizations I've worked with, you can cleanse the data or you can clean up the data. Now, there are Typically, third-party tools that do it for you, like Cribble or whatever, right? There are multiple options, but Data Factory does do that for you. It depends on how you do it. We'll take a look, right? So again, we'll not dive deep into any other major feature with Azure Data Factory. Well, Data Factory is global, right? I mean, yes, SSIS is very specifically. I haven't used SSIS per se or Data Factory, right? But what I would say is what comes with Data Factory is the ability to be able to use it in the cloud and scale it, right? If you're using SSIS across multiple sources, you'd need as much infra that you'd have to set up. Again, this is low code or no code kind of a scenario with the Data Factory. I'll show you that with a quick sample pipeline, and maybe you can judge yourself if SSIS versus Data Factory, what would be better. Okay. So one tool that we have is the copy data tool. Now, this is a very, the storage example that I quoted. Uh, you can use copy data tool for it. Again, copy data tool can be used for multiple sources and multiple destinations. What it does is actually build a pipeline in the backend, right? So what I'll do is we'll go through a hands-on of this to understand. Data Factory will be covered in, well, again, Venkat, what we are covering here in this is only up to a level 100 across all the tools from an Azure admin perspective, right? Um, I think from a data perspective, there are different courses that can dive in, right? But for now, we just stick to level 100 across all the storage, networking, and compute, or specifically Data Factory. Now, we don't want to start engineering data pipelines here, right? That's not the intent. We just want to understand that there's a tool that's available and what are its capabilities, right? You can, of course, explore Data Factory whenever you have the time. So what we'll do is let's go ahead and create a. So we have one storage account, right? Which is there. Let's create another storage account, which will so one is our source and one is our destination. Since I already have one, what I'll do is I'll create another one quickly. So you folks can also go ahead and create one for yourself. What we want to do is use the data factory to copy data between storage account 1 and storage account 2. Now you can schedule that to run every 24 hours, every 6 hours, every 10 hours, right? That is uh, beyond the part. But what we'll look at is how do we create a pipeline? Actually, the copy data is a template, right? So we'll take a look at that. What we'll do is search for data factories. When you type in data, you'll see data factories. And here we'll create a data factory. So you can click on create data factory. Let me know once you folks are on this page. Again, information is straightforward. Choose your resource group and provide a name. We wouldn't be doing anything else, right? Just the name. Choose the resource. It's already taken. So this has to be globally unique. To choose your interesting. Okay. Click on Launch Studio, and that's going to take you to Azure Data Factory. You'd see it's a different portal, right? The URL says adf.azure.com, which is Azure Data Factory. Okay. So here you would see what all you'd be able to do. So you can ingest, orchestrate, transform data. Well, you can also run your SSIS packages in the cloud. Okay, so data factory to creation is done. Okay, so once you have created it, just click on go to resource, or on in your resource group you can just click on the name of your data factory. So in my case, in this resource group, I have the data factory here. You click on it, it will show you this page. And on this page, you would want to click on Launch Studio, and that is going to bring you to another. Yeah, Basavaraj, you need to give it a unique name, a globally unique name, just like your storage accounts. Because data factory is accessible from everywhere, you need to give this a globally unique name. So choose a unique name and you should be fine. Choose special, choose a name that's not common. I mean, for storage accounts, whatever name, just like the way you've chosen the name of a storage account, just like that, you'd have to choose the name of your data factory. Storage account and data factory are not related at all. Storage accounts are totally independent of data factory. So if you delete storage, data factory will not get deleted. Remember, data factory is an ETL. It's a data pipeline that you're writing here, right? So this has got nothing to. Your storage account is just one of the sources of data for the data factory. After creating data factories on there, click go to resource and then launch. Click on Launch Studio, and then you would be on the page that I am on. How about deleting the resource group? Is data factory deleted? Yes, it is. All resources in the resource group get deleted if you delete the resource group. Okay. So once you're on this page, what I want you to do is click on ingest. Once you click on ingest, you would see on the top left, it says copy data tool. Now this is basically a built-in copy task that we are using. Now the built-in copy data, so built-in copy task is what we'll create, right? Now you can play around with this for those who are data freaks, knock yourselves out. You can do a metadata driven copy task, and a lot of interesting things. What we'll do now is a simple built-in copy task. And see, if you look at this, the task cadence or the schedule. So you can create this to run on a schedule, which is every 24 hours or, you know, every minute, every hour, every day, every week, every month, whatever, right? And you can choose to specify an end date so that that schedule gets over. There's a tumbling window that you can also specify, right? But we'll not do all of this. So this one will only do a run once copy task, right? So we've got a source. Our source and destination are both blob storages. Okay. So choose built-in copy task, choose run once now. Tumbling window is straightforward. I mean, you would create a schedule and then you can add in a delay, and you can set up the maximum simultaneous runs, right? And retry policies as well. So you can do a little bit of research on the tumbling window, but this kind of increases the number of uh, parallel copy tasks for you. Okay, so choose run once now and then click on next. Now in the sources, you can see there's a lot of data sources available, right? While you can even copy data from AWS to Azure, right? In your sources, you'll see RDS for Oracle, RDS for SQL Server, whatnot, all of this. You can bring in metadata from Google Ads, from Google BigQuery, Greenplum, HBase. I mean, it is a huge list, the data sources. Now for us, all we need is blob storage as our source, right? Now, whatever we are creating, remember, from a data factory perspective for the pipeline itself, everything is external, right? So when you choose Azure Blob Storage, you need to tell Azure Data Factory how it should connect to blob storage, right? And that is where you create a connection. Now, there are two ways for this. If you see authentication type, someone asked about a real-time use case for SaaS tokens. You can specify a SaaS URL in these scenarios also. However, for now, we will be using account keys only, right? So I'm creating a connection. Why am I creating a connection? Because I need to tell Azure Data Factory how to connect to blob storage. Okay. So I'm just giving it a name so that I understand source blob connection. Now I'm connecting via the auto resolve integration runtime. Now this is primarily because I'm connected to Azure. I would want to use the same runtime, uh, uh, same integration runtime to connect to the Azure infra. If you have different files, you would use the SaaS token on the container itself, not on the individual blob. But if you want to give it for individual files, you can, right? Okay. So now what I'm doing is I'm choosing the account where I have the blob storage and my storage account, right? So because this is also an Azure product, there is integration between adf.azure.com, right? Remember, we are not on the Azure portal. This is a totally separate service, right? And just choose your subscription and your storage, choose the account key. We are using the account key now. If you want, you could use a SaaS token also, but we'll keep it as this for now. Click on create. It's created. Now, what it is asking for is what is it that you want to copy? Okay. So we'll choose the specific file only for now. So once you click on browse, it's going to show you the root folders. So you can select the folder and select the file. Okay, and I am clicking on OK. One thing though is with blobs, it's a little tricky. Okay, I'll walk you through that in a bit. Next important thing is to remember to choose the checkbox for binary copy. Remember, our files are all binary, whether it's an image, a file, uh, an Excel file, or a Word file, or an exe file, or whatever it is, right? It is a binary. So choose binary copy, right? Now, the remaining things will leave as empty. I don't want to this. It's just one single file, so we don't want to have concurrent connections, etc. Right? And then we click on next. Now, it is going to ask you for a destination data store. Now, one interesting thing around blob storage is that while the blobs can or will get copied, I will go through the properties again, Ajay, in a bit. While the blobs can get copied, the containers cannot, right? So what we have to do is create a container with the same name on the destination storage account. Okay. Create the same, create a container with the same name. Now, if you are doing this programmatically, you can go ahead and create that and not worry about all of this. But since we are doing a hands-on using the portal with little to no code, and it's all UI driven, so I would ask you all folks to create the container with the same name on your destination storage account. And now we have to specify the connection for the destination storage account. So in that, what we choose is again the subscription and the destination storage account. Let me create this. So in the source, now I'm on the source page. So in the source, you can click on browse and choose your container and your blob, Basavraj. Once you do that, you would be fine. The properties that we are choosing is, once you choose the file or the folder, Now, what we have done is we have chosen the blob. In options, please choose binary copy. We don't want to compress for now, so I'm ignoring that. If you don't choose binary copy, the data will not get copied because we are using an image and an image is binary in nature. We are using recursive copy. So source and then destination is the same. Now destination will give the same path, right? So I've chosen the same destination container. We need a container. Now the container name is up to you. File name I'll ignore. You can also transform the file name, but we'll ignore that. Copy behavior will not touch any of these, right? Just choose the destination container and click on next. Now, this is going to create a task, right? And what you can do is you can do a data consistency verification. You can enable logging. You can enable staging of this, right? We are not doing any of these. We'll just skip all of these, click on next. Now what I'll do is I'll actually, this is not needed, but I'm just showing you where, how the pipeline, now what this does in the backend, right? This creates the pipeline. Now you can create multiple pipelines here, right? You can add activities, you can create a data flow. So this is what um, Azure Data Factory actually gives you, right? You can drag and say, okay, after copying the data, run an Azure function, or then, do a batch, a custom batch job, or go ahead and add variables, append variables. Someone had a question around SSIS packages. You can execute SSIS packages as part of this pipeline, right? Here, so Data Factory makes it's a lot more complex, or not, I wouldn't say complex, but it's a lot more flexible for you to do whatever additional tasks that you want to as part of your pipeline, right? Now, what this was created was pretty straightforward, right? So there's a source. You have given the source data set, and the settings are all here. There are user properties. So you can take a look at the pipeline. Transformation you can do here itself, right? Within the pipeline. So now what we have taken a look at is, I'm just showing you what was the output of this, what the inbuilt copy data tool created. In the end, it's still, this is the YAML file for this. I think JSON. This is a JSON. Yeah, this is a JSON. So this still is the code. Now you can maintain the pipeline code. Now, when you build a pipeline, you can add multiple triggers for this. You can just say add a trigger now. You can edit a trigger. Then you can say this is what we have done. Source destination. These are the properties. Now on completion, you can say, oops, run a batch script. Now transformation can happen here. I'm not a data guy, Ajay. Sorry, I can't give you a transformation example, but you can find them on GitHub if you want to. Okay, all good. So this is just the basics, right? We have just hardly even touched the tip of the iceberg of what Data Factory is capable of. But you can definitely go ahead and explore. If you are a data guy, you can look at multiple integration runtimes. There's Purview integrated. You can pull in data pipelines from sample ones that are available on GitHub, Ajay, so that you can, if you're interested, you can play around with those. All right. So next topic for us is Azure Data Box. Now I know we briefly talked about this in the introduction sessions, right? Now this is very unique service that's available from Azure. Now what this does is assist customers in shipping the data physically, right? So in case there is large amounts of data that you want to upload to the cloud, more often than not, it becomes a network nightmare because you might choke the network or it might take a lot of time, and more often than not, it's expensive, right? So Azure Data Box is a service where you can transport large amounts of data to Azure in a cheaper and reliable way, right? The way it works is you place an order on the Azure portal itself, right? It's very straightforward. I'll show you this again. You'll not order one, but so you've got Azure Data Box. When you create an Azure Data Box, so it'll ask you what do you want to do, right? Import data or export data. If you say import, you choose your subscription, you choose your resource group, right? And the destination Azure region, South India, whatever, right? Then you click on apply. Now these are the prices, right? This is the types of data boxes you get. So data box is not available for the subscription type. It is not available for my subscription type, but that's fine. So you get a 35 TB box, data box disk, or you have an 80 TB, 800 TB, or you can do a 1 TB input onwards. So there's you can keep going on more and more from a sizing perspective, right? So what you get is up to 5 disks per order, blah blah blah. This is all the facility that is available. This is only available in the US and EU, data box heavy, right? These two are in preview. So actually, this was the only service that was available earlier. Preview features are hardly used as of today, right? So data box, the moment you create that request, what's going to happen is, what you're doing is step one, which is placing an order, right? What will happen right after is step two, which is receiving the order. Once you receive those disks, you copy the data, you return it, you return the disks, and what Azure does is upload the data for you, right? Now you can do an import and export both using Databox, right? And that is what will make sure that you're not spending a lot of money on trying to upload such large amounts of data over the internet. Right. Now, use cases are pretty straightforward, right? One straightforward use case is you would use this for one-time migration kind of scenarios, right, where you move large amounts of data at once. Second is again similar, but an initial bulk transfer, which can be followed up with multiple incremental transfers over time. Third option is, of course, periodic uploads. So, you have, let's say, on-prem data that is being backed up. You want to move those archives. You don't want to upload them, but you want to archive them on Azure. You probably order a data box, and because it's not mission critical data, right? So you can order a data box, get those backups in onto the data box, and ship them to Azure. They will ship it to you. They won't come to you. They'll just ship the. So Deepak has a question. It's asking, after placing the order, will someone from Azure come to get the backup? So basically, what will happen is once you place the order, Deepak, Azure is going to ship the disks to you, and you are going to upload the data from your data center to those disks and send them back to Azure. What Azure is will do is upload them in their data center, so they'll start showing up on your storage account. Ashish has a question. Says, can this be used to transfer data to client from a SaaS provider? No. As long as you are on Azure, yes. But to any third party, answer is no. So only if you are consuming services on Azure, so where you can push or upload your data to your storage accounts, and if you want to export the data from Azure, let's say there is a lot of data on Azure that you want to bring back on-prem, but you don't want to download it, right? There is 800 terabytes or maybe 1 petabyte of data, whatever. Those use cases for export, you can use Databox. Yes, it is a physical device. That's what we're talking about. I mean, those disks get shipped to you, so it is using a physical device. If somewhere the disk got lost or broken, what will happen then? Well, see, this goes without saying, right? All of these disks are secure. They are encrypted. They use hardware encryption is also on them. So if they get lost, your data is not lost. right? Or your data is not stolen. Well, if they get broken, again, data box comes with military grade devices. They are drop protected, whatnot protected, and that's what uh, and they're so Azure takes care of that. So it's not that they'll break just because you drop them. Again, those are not just disks. It's like a big box that comes which has a network port and a power port. That's it. Copying will take time, but not as much time as uploading 800 terabytes over the internet, right? So there is that trade-off. You are selecting the resource group, yes. So they will upload the data to a storage account in that resource group only. So they ask for the resource group to make sure that they'll create the order there. So they'll show you the data box there, right? And you, when you upload the data, it will also ask you what is the destination storage account you want it in. So it's all automated, right? It's not someone is going there, dragging and dropping the files. It's all automated. So once you select all of these details, the data box will come. And once it goes back to Azure, it will ensure that no one else can upload the data unless, it cannot be uploaded to any other storage account apart from yours. We talked about LRS. We talked about GRS. We talked about GZRS, RAGRS. We've explored all of those, right? 4 types, yes. Why storage replication again? It's crazy. The slides are here, but we discussed that, so that's fine. So we discussed storage replication. Quick recap. Again, I don't want to go through these English, but high level, you need storage replication to ensure your data is not lost, right? It's as simple as that. The types of replication that we've discussed, you can go through the slides if you will, but I'm not a slides fan. Data replication options, yes. LRS.
Just a quick info, guys. Intellipaat offers Microsoft Azure course training and certification. Through this course, you will be able to prepare for AZ-104 Microsoft Azure Administrator exam and much more from the top industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of Microsoft Azure Cloud.
Import export service is another similar services data box. Yeah, right. Now, again, here the sizes are quite are a little different. When it comes to using import export service versus data box, right? And import export service, you can use your own hard disks as well as against data box, where data box they ship their own, Azure ships their own disks, right? So again, the use case is very straightforward. It's very similar to what you do on a data box. So to avoid transferring data over the internet, you can use a physical disk which we ship to Azure data center, and they'll upload the data. The primary difference here is in an import export service, it is going to be our own disks as compared to data box, where it's going to be Azure owned disk. So the primary difference, as I mentioned, a data box, Azure ships their disks, and import export service is where you can use your own physical disk to send the data to Azure or bring the data back from Azure, right? So a few use cases here. You can import, again, properties, right? Than use cases, right? You can import large amounts of data, very similar, but this is very specific to blob storage and Azure file. Now you can use this to transfer the data from blob storage to disk. You can export the data as well. So if you want data back to your on-premise environment from Azure, we can do that. Now, the primary difference, as I said, you can supply your own disk drives as against the disk drive supplied by Microsoft. If you're using data box, that's very specific to terabytes of data, and there's no option of choosing your own service. Now, Relatively, import-export service is a lot, comparatively a little cheaper as against using the data box, right? Now, use cases are again very similar to what you would use data box for, right? But data box, however, it's more large scale, right? So if you look at what's happening on the use cases for import-export service, primary use case, data migration to the cloud. Now, if you have CDN as well, you can use import-export service, which means you can upload. Now we'll talk about CDNs and how they cache content, etc. But essentially, for content distribution, you can use import-export service. Again, backups. You want this to be a frequent thing, right? You can subscribe, or you can put it on a schedule. Now, the backups are typically, the reason why you would use import-export service is for retention purposes, right? So if there is a compliance ask that says, hey, you need to retain the data for 7 years, or you need to retain monthly backups for 4 years, right? So in such scenarios, you can ship them on the physical disks to the Azure data center, and you could upload them to a blob storage and archive it. Data recovery, again, in case there is large amounts of data that you want to recover from the Azure data center back to on-prem, that's one of the export services for which you can use the import export service. Okay. So job flow is pretty straightforward, just like the way we saw the job flow for the data box. So we start by preparing a hard drive. There's a tool which you can use to prepare the hard drive and encrypt the drive with BitLocker. And then you create an import export job on the portal. After that, you ship the drive to the Microsoft data center. The carrier delivers it. If you've put in data in it, you transfer, your data is transferred to Azure. If not, they upload the data that you have requested. The drive is packaged and it is sent back to you. There will be shipping charges and other things, right? So apart from that, they'll charge you for the hardware, but not for egress. But if you were using, let's say, instead of the import export service, or let's say you were using internet to upload, that is where definitely there's going to be egress charges as well as ingress charges. Okay. The data flow is pretty straightforward, right? You create the hard drive, you prepare the hard drive, you upload your data, ship it, the data is transferred. Security, like I said, you are encrypting it with BitLocker here, right? So there are encryptions that are available, right? They do not come with a stringent physical, they're not as physically secured as probably a data box is, but then you would want to, as long as there is encryption, that kind of takes care of uh, the safety or the encryption of data itself, or security of the data itself. So now we'll move on to the next topic, which is Azure File Sync. Now you can hybrid kind of makes much more sense here, right? So on-prem data center, and then you have Azure, on which you are using, let's say, a storage account, and you're using Azure files, right? Now from your on-prem, now let's say there's a file share that you've created here, like a network drive, call it shared folder or something, right? Now this shared folder, you want to make sure that if there are applications trying to access it from cloud, or if there are applications trying to access it from on-prem, you want lesser latency, right? In that case, or in such scenarios, you can use Azure File Sync. So what it would do, right? So if application is writing something onto the same shared folder here, right? It created file one. This file one gets replicated here, right? Now this file one can be consumed by an on-prem application as well. An on-prem application, if it creates file two, it gets synced to the cloud and it will show up here. So if there is applications or users trying to get that file from the cloud, instead of going through instead of traversing over the network to on-prem and then back to the cloud, Azure File Sync will help keep the on-prem file share as well as your file share on the cloud in sync, right? It's as simple as that. Yes. So between on-prem as well as on the storage, on the cloud, we'll keep the file share. It will keep the file shares in sync. So it's a simple sync service File syncs, Azure files, if you use, it's a lot more performant as compared to what non-prem file share can be. There are local caches that continuously syncs with Windows Server. You can use multiple sites can centralize their files onto Azure files, right? Irrespective of the location. So again, the advantage is global access, right? So that's the reasons why you might prefer to use file sync. So what is ingress cost and egress cost? Okay. So let me put this thing here, right? So you have your physical data center or your on-prem data center, right? And you have, we'll call this Azure, and you have your storage account sitting here, right? Now, how are they connected? We'll talk about that in networking, but typically they are either connected using an express route or a VPN. This is private connectivity. If it's a storage account, it is still public connectivity. You can use Storage Explorer or whatever and push data onto this, right? You can use storage account keys, etc. So ingress cost is typically the charge that the cloud service provider will charge to when you are pushing data onto a storage account. Now, in terms of ingress, when we get to networking, you'll understand what the ingress charges and egress charges are. So any data coming into the cloud is charged per gigabyte. Any data going out of the cloud is charged per gigabyte. Okay. So these are, anything that is coming into the cloud is ingress for the cloud. Anything going out of the cloud is egress for the cloud, right? Uh, so this is what we mean by ingress or egress charges, right? If you look at the pricing of storage accounts, you will see that the storage accounts will have ingress is free, so you can push as much data as you want, but egress is chargeable, right? It's not a huge amount, but when you look at it in larger numbers, it's going to have a significant dent, right? So usually what happens is you are charged based on the number of read or write operations, right, on your storage account, as well as how much data is egressing you. So you'll be charged per gigabyte. I think the charge is somewhere around 2 cents or something, or less than that, 0.002 cents or something per gigabyte. But so to say, it's not free, right? Ingestion is free. You can push data, but you can't. You'll be charged when you take it out. Okay, that's how intelligent the cloud service providers are, and this is the norm across the board. Okay, so the backup service. Now this is backup works with a resource which we call recovery services vault, right? So this is a native service that is available on Azure. It can back up a lot of things apart from just storage. What we're talking now is very specific to the storage, or to very specific to the blob storage, right? So when you use this, you can back up the data and you can recover the data at a granular level. So anything on storage you can back up. So you can back up Azure files, you can back up blob storage, right? You can choose the frequency of the backup, and at any given point in time, you would have the ability to restore the backups as well, right? Now, typically enterprises will always want backups, be it for compliance, be it for recovery, be it for any other potential reason, right? Now, backup options, instead of going ahead and purchasing a third party solution, what is available on the cloud, what is available, snapshots are different. Snapshots are not backups, right? Snapshots are a point in time static state, right? So snapshots work typically based, for your images or your hard disk, right? Backup on the other side is different. You can consider it as a point in time data recovery option, right? Now, when you're taking snapshots, you have to be careful. Snapshots typically are leveraged only for operating system state change, not specifically for snapshot is like system restore, yeah. But snapshots are only for operating system changes, right? So if you're updating your OS or upgrading, or you're running a Windows update or whatever, that is the scenario where you possibly take a snapshot. Backups, on the other hand, have got nothing to do with the operating system. They have got more to do with the data in, right? To ensure data consistency, you would want to take backups and not snapshots. Again, remember, rule of thumb, never snapshot a database server, right? And don't expect it to, when you restore the snapshot, don't expect the data to be there. It's going to be inconsistent, right? So the recovery services vault is the service that is typically used to configure backups, right? We'll do a hands-on and you'll probably feel much more comfortable around that. But what we were talking is about the difference between a snapshot and a backup, right? Snapshots are only at an operating system level or at an operating system stage, right? You would not want to take a snapshot of a data disk or your database or a snapshot of the files, right? That and expect if you restore, don't expect the data to be consistent, right? So snapshots and backups are two different things. You have to treat them separately. Okay. The options that you have on backups. So two things, or actually three things. The first one is using AZ copy. Now we have native backup solutions with the recovery services vault. We'll take a look at those. All right. Now AZ copy is a command line tool. Now you can use that to copy blobs from one account to another account, right? We can run a simple command to do that. We'll do right. Now blob storage can create snapshots, right? These are snapshot of individual blobs, but not the account. Okay. But remember, these snapshots are not stored in a recovery services vault. Now you would want to do this individually for a specific blob, but that's not something that typically is used in an enterprise scenario, right? While that ability is available. So let's say you have an image today, you are changing to V2 of the image. You can take a snapshot. I mean, you rather than a snapshot, it is easier, straightforward. Like I said, if you are upgrading let's say you're patching an operating system, you're patching a server, you would take a snapshot of it, right? On the last known good state, you'll take a snapshot of that server and you will proceed. Where will you take a backup? You don't, you would take a backup. A backup is typically a cron job or a scheduled job that will run, right? For example, a database server or the application files, you would want to take a backup every 24 hours of, typically what enterprises do is they schedule backups, pull backup every 24 hours. And there can be log shipping. If you're talking about databases, log shipping can be every 15 minutes or every 20 minutes, right? So backups and snapshots serve completely different purposes. Like I said, before you do any major change or upgrade to the infrastructure or operating system, you would take a snapshot, right? But you would never snapshot a database server itself. You'd only you would snapshot a database server, but not the data disks, right? Only the OS disk, just to make sure that anything that goes wrong, you have a snapshot to recover from. Backups, on the other hand, are entirely different, right? Again, how frequently you take the backups, how frequently you do the log shipping, etc., entirely depends on two primary parameters, which are recovery point objective and recovery time objective, RPO and RTO in short, right? So if you are okay to lose 15 minutes of data in case of a disaster, then your RTO, recovery point objective, is 15 minutes. And what that means is that at any given point in time, you would be able to restore data which is at least or at best 15 minutes old, right? Recovery time objective is how long it takes to get you that up and running. So if you take, while if you have a 500 gigabyte database or a 1 TB database, then the recovery time from, fetching the backup and restoring your database can be 3 to 4 hours. So are you okay with that? So that is the time taken to bring the service up and running. That is called a recovery time objective. Right now, there can be multiple designs depending on the RTO and RPO that gets defined for a specific service. Yeah. So backups, right? Again, like I said, when you're looking at an enterprise, now what we are talking about right now is level 100. These are fundamentals. Okay. There's a lot of services that get built on top of whatever infrastructure you build on the cloud. So you can start with a virtual machine. You know, first thing you do is network, right? You sort out the network, you sort out your workloads, you sort out compute, right? What you need from compute. It can be web application, virtual machines, whatnot. And then there is security that comes across the board. Then there is logging, and then there is monitoring, then there is security, and then there is alerting, right? So all of these put together is what will help an enterprise work in the cloud, right? What we are learning now are just basics. So though that is the thing around snapshots. The third option again is archive storage. Now this is used quite rarely, as the name suggests, right? It's the lowest priced storage tier. Now you can just mark it as archive, and it's going to go into a tape storage in the backend, which is like the cheapest option. But this is only in case where you don't expect the data to be available as soon as you need it. Okay. So what we'll do is we will implement the backup service. Back to implementing the backup service. So now we've got three options that we will play around with, right? One is just switching the access tier to archive, right? So that's like a very simple thing to do. We'll still do it. I mean, I'm not three or four quick clicks won't hurt me. So three things that we'll do, right? We'll create, we'll change the access tier to archive. Now that's like a 5-minute thing. I would worry less about it. The second thing is interesting. So we'll do a snapshot, right? If your fingers are itching, please go ahead and play around. But before creating a snapshot, I would want you folks to hold on. There are two ways to do it. One way is directly through the blob storage. The other way is using a recovery services vault. So I'd want to show you both those before you pick your poison. Okay. The third one is, we'll use the AZ copy command, right? From a source blob to a destination blob. So based on what you're seeing right now, we need to create two storage accounts. Okay. One is a source storage account. One is a difference, one is a destination storage account. Real time? Well, in an enterprise, you'd either use Terraform primarily in today's day and age. Few customers are still on ARM templates. Few customers are upgrading to Bicep. But anyone who's not done this yet? See, command lines, while they look scary, they are actually very intuitive, right? I mean, they're self-explanatory. So if you just read the command that I've written here, I said AZ storage account create the name. I gave it the name. Resource group. I said which resource group it has to create. I told which location I need it in. What is the SKU I want? LRS, GRS, whatever. Kind is always storage v2, right? And I said allow blob public access as false. Okay, so once these are ready, uh, right, created storage accounts, upload a blob on one of them. So I'll just drag and drop a browse for files. Let me- I'll use this only for archive. Now, once you have uploaded the image, one way to switch this is very straightforward. On the same page, just click on three dots or right click, whichever works for you, and then do a change tier. Now it's going to show you hot, cool, cold, and archive. Right? You can switch to the archive tier. What you'll see is the message that says setting the access to archive will make it inaccessible until it's rehydrated back to hot or cool, which may take several hours. Right. Now, one thing to understand is archive tier will work as a backup option as well. Okay. So all you have to do is switch this to archive, click on save, and it will be done. Now, I'm not doing it specifically because I want to use the other two methods, right? So if you want, you can switch this to archive, upload another blob. That's fine. Okay. So that was the first uh, hands-on that we had. Second one is we'll create a snapshot of the blob storage itself, right? Now, this is where I'm not a fan of clicking a couple of buttons for the sake of it, right? So I'm not going through with the archive tier switch, right? But now what we'll do is we'll take a snapshot of the blob storage, right? So for that, what we'll do is we search with backups, backups, backups. Where's my containers? Can't I find? This is at a file level, yes. So at the blob level, you'd have the tier. So you can change the tier at the blob level. So this is blob level snapshot, right? I mean, you can click on view snapshots and this will show you blob level snapshots. There's nothing here. You can create a snapshot, but what I was looking at is actually enabling backup. But we'll talk about that quickly. This is blob level snapshot, right? This is again, not anyone would use this. I mean, I would rather use versioning, right? So, and practically as well, right? You wouldn't take snapshots of blob itself because the moment you upgrade this, I would rather have multiple versions of this, right? And I would want to use or promote a specific version, right? So if I upload the same image again, for example, so if I say upload and let me use the same file again. It hasn't changed. Okay. So it not. But if I change anything and if I upload a file with the same name, I'll create a different version of this, right? So snapshots, blob snapshots are not something that is heavily used. Now, what you can do is when you look at snapshots, you can, those snapshots can go and sit on you can change the archive tier for this, for this snapshot, you can switch this to archive. So what this means is basically you've taken a backup or, you've taken a snapshot and you've put it in the archive tier. But typically in an enterprise, in the real time scenarios, right, what happens is you'd have multiple versions and you'll keep the last 3 or 4 versions available for whenever you need it, right? So these are the two options. The other, I think, which is the interesting one that I wanted to do, is the AZ copy. I'll show you how to use for Azure files what you can do, which is using the recovery services vault. But for now, we'll just be very specific on blob. But when we do create the vault, I'll show you how to take care of the Azure files backup, right? Now, AZ copy. Now, what I'd want you to do is use the Cloud Shell. That's kind of pretty straightforward. Uh, so use the Cloud Shell. I don't know if I have AZ copy installed. Let me check. I think AZ copy is again one single. No, it's not there. Try. Anyway, never mind. We'll use the Cloud Shell. So click on the Cloud Shell button and then it needs a storage account. So please go ahead and create a storage account. The Whenever you're ready with the terminal, we'll just do a quick command. Ready? Okay. How to create versions? Try to upload the same file, and you'd have to enable versioning on the blob storage, and you would be able to use versions. Okay. Now the command is very straightforward, right? So just let's just see if you have AZ copy on it. Just type in AZ copy and enter. You should see something like this, right? Which means that you have AZ copy available, right? Now, what we want to do is copy. So you can see that the second option is copy itself. So now what we'll do, again, this is the way you would want to learn any other command line, right? So now I do AZ copy and then enter. There's a huge list that comes in. Now these are all the possible parameters right? Now you can also use CP instead of copy, right? So if you scroll all the way up, sorry, it's long, I'm scrolling too much, right? There you go. So what you see is it's telling me AZ copy. The way you use this command is AZ copy space copy, give the source, the destination, and any flags, right? Now here itself, you would see how to, there are multiple examples here. You want to upload, use a SAS token. If you want to, you can use multiple other options, right? Let's see, is there an example for us? So now what we'll do, so we know the source and the destination, right? The source and destination for our scenario are the source storage account and the destination storage account. Okay. So what we'll do is, let's copy the names of the storage accounts. So the first thing I'll do is go to my source storage account. And since it's very specifically blob storage, all of these, I'll actually copy the name from here, the entire URL, right? So I'll copy this URL. Okay. Now the command we'll put together is az copy space cp, and then I'm pasting this. So this is my source file, and then destination. The destination, I will just not use the file name, but I'll just use it till the container. Now I don't have a container there, so I'll have to go create one. So on the destination, we do not have the container. So we will create that quickly. The reason for that is, again, blob storage is tricky. If you don't have the container, it's going to cry foul and say, hey, it's not there. Okay, so I've given the source and I've given the destination, then enter. Failed to perform, no cache token found. Please log in with az copies login command. Okay, it doesn't have the keys. So what we'll do is az copy login. So if you're on bash or PowerShell, it doesn't matter. You will have az copy command, right? So what you use is az copy space cp, and then your source file and your destination location is what you need to specify. That's it. But you will run into an error. So what we are doing is az copy login first. So the instructions are right here, right? To sign in, open this page and enter this code, right? So that is what we are doing to sign into AZ Copy. Oh, I'm on a different tenant altogether. Okay. So this is the case with me, but you don't need to specify the tenant. Okay. You just have one tenant, just use that. That's fine. My case is different. I have access to multiple tenants, and that's why I'm using this. You are facing the tenant issue, then you are probably have access to more than one account. So you can do an AZ account show, right? It will show you the list of the accounts that you have. You can copy the tenant ID, which is the home tenant ID. The only thing that we are talking about now is to use the AZ copy command, right? And what we're trying to do is get you to fix if you are running into a tenant ID issue. So bear with me. Commands, again, there's no new commands. We'll only use one command, which is AZ copy and space copy command. I'll just show you how that works. I'll put in the command together and I'll send it to you. Like I said earlier, right? If the easier way to learn any command line is the moment you type in AZ copy, it is going to list the available options, right? What do we want to do? We want to copy. You see this option, copies source data to destination location. So next, what did we do? I just typed in AZ copy space copy, right? Then it said, hey, this is not how you use the command. The usage is like this. So AZ copy, space, the source and the destination and any flags, right? Now you can use aliases. So instead of copy, you can use CP or you can just use C or you can use the entire copy word. Okay. So what we are trying to put together is the command, which is, again, I'll type it here, AZ copy space C. Now the source, right? Where do we get the source? We have the blob URL, right? That is our source file. That is what I'm pasting here. This is my source. What is the destination? Destination is your second storage account. Okay. In the second storage account, we have created a container to copy this file. All we need is the URL till this container. You can get it from here, right? The properties, you can get it. This will be the destination, right? So source and destination will be based on whatever you are doing. So it needs a trailing wildcard. So the first thing you'll do, that is how you build the command. But if you run the command, if it is giving you a tenant issue, right? If it says, if you see an error which says something like this, no cache token found, sorry, no, not this. Yeah. If it says when you try to sign in, if you get a tenant error, what you would want to do is type in this command, AZ space account space show. Again, this is not a new command. This is what we've already used in our introduction sessions, right? Once you run the command, you will see something which is the home tenant ID, right? Now, the reason you might run into this error is if you are using an email address where you already are part of some other tenant as well, right? Now, that can be possible because of one of two reasons. You might be using a Microsoft service already using this email address, that you're signing in with. And that's why AZ copy is finding multiple tenants that are that where your ID is. So that's why it wants you to specify that ID of the tenant that you want to log into. So use AZ space account space show. So yeah, then it will get you the tenant ID. You have multiple tenants. That's why you're not able to log in. You would need to specify the tenant ID. To get the tenant ID, use AZ account show and use the home tenant ID. So the way you would do that is this: AZ copy space login dash dash tenant dash ID, and in the quotes paste your tenant ID. So Quasi, your command is wrong. I'll repeat again. The command you have to build is AZ copy space your source URL space your destination URL. Okay, I've just pinged it to you. If you're just saying AZ copy space source, it will not work. What we'll do, I was waiting for someone to say that. No one's saying that, but that's fine. So what we'll do is we'll generate hash tokens for each of those containers, right? One is for the source and destination. And this time you'll have to be careful while generating the SAS tokens. So can someone tell me what permissions we'll give on the source SAS token? I'll generate the SAS token at the container level itself, right? So on the source, I'm just giving read permissions, okay? And I'll generate the SAS token and URL, right? I'll copy the entire blob URL this time. Okay, so what I'll do is AZ copy space copy, and I paste the entire SAS token. You are able to log in, great. Now the same thing, but this time on the destination, what we will do is when you generate a SAS token, remember what happens, what do you do in the destination? You write, okay? So what I'll give is, you give read, write, access, read and write access, okay, on the SAS token before generating it. And then I click on generate token, and the entire blob SAS URL I'll copy from here. I'll paste this. So my source is done, my destination is done. And I'm just adding a recursive flag. So what does recursive do? It will loop through all files if they are there, right? So, and then enter. Now, what does it do? Fatal. What did I do? What did I miss? source, I give the destination and recursive. So let's keep recursive. Source and destination is still not able to read with the SAS token. No, you need to specify what the token is for, right? Let me quickly look at the syntax. Well, you can do blob to blob. That is like pretty straightforward. Uh, what am I missing? Straightforward approach. Nothing wrong with the command that I can see. Or maybe it's not able to list my read access one might be wrong. Let me generate one more at the blob level. You might be right, Anil. Let's do that real quick. Let's generate a SAS here at the blob level and copy this URL. What we'll do is replace this. No, it still doesn't like it. Okay, maybe it needs quotes. So let me use quotes instead. Okay, I'll just type it in again. Az copy space C source is this, and destination. I think that's why it kind of didn't like it. Yeah, sometimes the small things get you. Okay, so the the source and destination need to be in double quotes. Okay, so I stand corrected. Az copy space C in double quotes, enter the source URL with the SAS token, and in double quotes, enter the destination URL, and you should be fine. Okay, so once you do that, this is a final job. Number of files transferred 1, total number of transfers 1, transfers completed 1. So it's all successful, right? So the way you'd build the command, and it's been a while, is the same, right? Az copy space copy, and then the source and destination URLs need to be in double quotes, and that's going to save you from these errors. Uh, if you have completed, then it shows you that it is done. It says 100%, one done, blah, blah, blah. So we'll move on. We'll talk about CDN, right? So when we were discussing things earlier in the intro, we talked about what CDN is, right? It's short for Content Delivery Network, right? Now, we also talked about scenarios where you would need a CDN, right? So if you've got a user, you've got your application or a primarily web app, and this has a lot of content, images, image one, image two, image three, multiple images. And if you have hosted, right, what you want, the reason you'd use CDN is, let's say there are multiple users in multiple countries, right? So one in India, one in Europe, one in the US, right? And one in maybe Australia somewhere, right? Now, for all of these folks, right, when they try to access your web app, the content, if you're hosting your web application in one region, I'll probably call this US, right? Now, this person will be able to load the images faster as compared to someone coming in from the EU, someone coming in from India, or someone trying to access from Australia or any other region. What CDN does, so for all of these images, again, assuming you've got this on your blob storage, again, sitting in the East US location, right? So how does your URL look like? You've already seen that, right? So if your website is using the blob storage URLs to load the images, anyone who's trying to access the page from a different location will see latency, right? In terms of how long it takes for the image to load. Now, this is where typically for global websites, what you would use is Azure CDN. So when you use CDN, what happens is, so the CDN will be tied to the blob storage, right, to cache the images. And instead of using the blob storage URL, you'd use the CDN URL on your images. So the way it would work is, if a user is trying to open the website, he will first hit the CDN, right? The CDN will go talk to the storage or blob storage, right, and pull the image. Now, what it does, CDN, over a period of time, now you can choose rules. So in the CDN, you can say, based on the number, you can define rules like if there is a specific image that is coming in or being accessed frequently, that can be cached here, right? So the images will be cached in the CDN. The users get the images served through the CDN, so they don't have to make an entire round trip to the blob storage and back. Instead, they go to the CDN. The CDN, based on the rules that you have set, will cache specific content, right? Images, videos, whatnot, and it will return it back to the user. Now, for EU, again, based on the user behavior, you can set up what content that needs to be cached. For India, it can be different content. For Australia, it can be different content. So that is what CDN does. It works like a cache, right? It will cache the frequently used images, right? The reason you'd use that is, again, different based on each scenario. Now, typical usage, why CDN, as we've just talked about, right? It'll provide alternate server nodes for users to download resources. It's typically the static content like images, right? Now, CDN is a global service, right? So it's spread across. So for example, if I'm on this website, this web page that I'm just sharing, right? So there are images like this is this Microsoft logo coming in and things like that. If I click on this, for example, right, there are all of these images that get loaded, right? Now, Microsoft.com/ENIN, now I'm just, specifically coming in, Microsoft.com can be accessed from anywhere. And based on where you're coming from, these images can change, or there can be common images, right? So common images like all of these need to get loaded and they need to load fast, right? So for these kind of websites, now even if you open Amazon.com, let me open Amazon.com, right? Now what you'd see is, you see all of these images that are coming in. All of these images will go and sit in a blob storage somewhere, right? In Amazon, it's going to be an S3 bucket or whatnot, right? If I open Amazon.in, different sets of images, right? Now, all of these images, even in India, right, it need not be global. Let's say I'm accessing this from Hyderabad. I need a location that's closer to me, which will serve these images to me, right? And that's how the websites load super fast. Or you basically decrease your latency, right? Now, while the CDN nodes are split across multiple uh, countries or multiple geographies, the CDN nodes are also available across multiple zones or multiple regions within the same geography, right? So in India, there is Central India, there's South India, and there are there's North India, right? So Across these regions, you will have the CDN nodes available, right? So CDN, the way it helps you is assists you in caching the high bandwidth content so that people or users experience lower latency for the application that they are consuming, right? So the use cases are straightforward, right? The examples that we just saw, where the content gets loaded onto your web pages or your websites, right? It can be global, it can be within the same geography, or it can be at least a couple of geographies together, right? The way it works, CDN is this is global. So when you're creating a resource, unlike a blob storage where you're choosing a specific region, CDN itself is a global resource. So it's available, the nodes are available across all regions on Azure, and it is not region specific, right? You can deliver high bandwidth content using the content delivery network or CDN, Azure CDN. You can cache objects, as I mentioned earlier. And what it does, the way it works is it will deliver the content from the closest point of presence to the user, right? So if I'm in Hyderabad, when I load Microsoft.com, the content possibly comes from the point of presence closer to me, which can be Chennai. Someone in the North India is trying to access, the content will be served from Mumbai instead of making a round trip all the way to the data center where the actual blob is stored, right? So CDN acts as a cache and helps you load your static content faster. Now, CDN can also be used to accelerate dynamic content, but that's primarily on network optimizations or route optimizations, but not actually content optimizations, right? So what we mean by that, in short, is I'll just draw an image on the whiteboard to make it clearer. Let's say there is a user sitting in Hyderabad. Okay. Now, there is a data center in Chennai. There's a data center, let's say, in Mumbai. Probably there's a data center in Delhi, right? Now, dynamic content is accelerated by the way saying, when I try to access a web page, the content gets served. So the routing, what happens is, let's say, even if the dynamic content is based in this region, right? This is the content location, right? How do you get to a data center? The typical route is from the user, it goes to the internet service provider. From the internet service provider, he's going to route it to over the public network to a data center in Hyderabad. From the data center in Hyderabad, it gets routed to another data center X. And then eventually, after a couple of hops, it gets to the data center of Azure in Delhi, right? So there are multiple hops to get to this content, right? If the user is in Hyderabad. Now, route optimizations, the way they work is instead of doing multiple hops on a public network, what CDN can do or what CDN does is for the user who is in Hyderabad trying to access an Azure resource in the north, central or the north uh, India region on Azure, the first thing it will do is it will send the traffic to the Azure endpoint in Chennai. This is the closest point of presence for Azure network. And now the packet goes from, or the request goes from the Chennai data center to the Delhi data center on Azure's network, not on the public network. So this route actually reduces the number of hops. So instead of, let's say, 1, 2, 3, 4, 5, 6 hops, it will probably just do one or maybe two hops, depending on the ISP. And then once it gets onto the Azure network, this is like a gigabit network, right? It runs on 100 gigs. So your net number of hops get reduced and you get the content served to you faster. This is route optimization, right? Now, this is specifically for dynamic content. Okay. Well, you can use Akamai as well. There is Akamai CDN that's available as a provider on Azure. So yes, Akamai is a CDN provider. Azure CDN is also a CDN provider. So it's all the same, right? So what we'll do is a hands-on right now on the CDN side of things. Now, since you already have a blob storage, I'm assuming you have not deleted it yet, right? So what we'll do is we'll create a CDN. We switch to mouse pointer, get rid of all of these tabs that I don't need. Okay, let's. So I'm assuming you would have the containers. Now, one thing I'd want you to do is any one of your storage accounts, just change the access level because we are using CDN. We can still use the same. That's absolutely fine. Let's just quickly look if we are able to access this image. I don't think we'll be able to. Its blob is set to false. Yeah. Anyway, we'll see the same error message there and then we'll see how to fix that or sort it. Okay. So again, how do you create a CDN? Simple. Search for that resource, type in CDN. There are two ways to do it. You can go to front door CDN profiles and create it. Alternatively, on your storage account, you should see front door and CDN right here, right on the left. Do you folks see it? You can go ahead and click on that, and we can create an endpoint from here directly. Okay, so we'll go this route, right? So on your storage account, you have two storage accounts. So pick any one of your storage account, and on the left, click on front door and CDN in under security plus networking. And in that, once you're on this page, now I wouldn't, while it is recommended to use front door, we are just doing CDN. Front door, we'll take a look at that in the networking module. So switch to CDN on the endpoint. So what we're creating is a CDN endpoint for this blob storage. Okay. So give it a profile name. The endpoint name. I think this will be globally unique. So choose this carefully. So whatever endpoint name you choose, this is the endpoint host name that you get. Okay. Now the origin. So what we are saying is the origin is our blob storage. Now there are multiple blob storages, right? But we are sticking with what we have. There's a pricing tier. Leave it as standard. Now the query string behavior or the query string caching behavior is there. For now, we'll just ignore the query string. If you want to bypass caching or use the query string, these are to set your rules. So we'll explore that later. So just choose ignore query string as your option for now. Okay, I'm pausing on this page for a minute. If anyone is not on this page, please let me know. Endpoint names up to you, Anupreet. Just choose the endpoint that you want. The endpoint name has to be globally unique, so please don't type in whatever I have typed in. Otherwise, I wouldn't be able to create this. Very specifically to the blob storage. Okay. So once you're done, click on go to resource. Right now, you'll see that there is a endpoint. Okay. So what we'll do is now this is the URL that I have, right? Where I'll just copy this on Notepad so that I can show you how to access this. Okay. Now this is my blob URL for my image, right? So to access this using the endpoint, what we'll do is I'll just copy the endpoint, which is the one that we've just created, Azure Story, Azure Edge.net. So this URL I'll replace with azureedge.net, right? That's what I've done. So in simpler terms, what I'm doing here is this, I'm just constructing or changing the URL. I've removed the blob.core.windows.net and whatever, and I'm just pointing this to my CDN. Okay. Now let's try to access. What I'll do is I'll try to access this here. It is not ready yet. Check in a few minutes. Okay. This will take a while. Let's wait. Okay. So once you click on the profile itself, you'll see status is running, the location is global, optimization type is general web delivery, right? So once you've clicked on the endpoint, you'll see in the settings there are quite a few options, right? The first one is of course the storage account itself, right? So you've got the origin. You can create origin groups. Again, I don't want to dive into all of this, but I just want to show you the options that are available. So you can add multiple storage accounts in here. Okay. There's custom domains. So you want to add your own domain, you can, right? So you can give a custom host name. There's compression options that are available, right? Uh, so if you switch on compression, then it's going to reduce the size and improve performance. And this is for different types of content, right? The content can be a font, it can be a JavaScript, it's a JSON, an XML, you name it, right? So there's text, plain text, whatever. The caching rules are what we talked about earlier, right? Now we said ignore query strings. Now you can cache every unique URL, you can bypass caching for query strings, right? This is typically, if you're a developer, you'd know how to play around with these. The other important thing is there's geo filtering as well, right? So what you can say is, I can choose to block if the request is coming from a specific country. I can block if I choose these based on the IP addresses. If someone's on a VPN, we can't help it, but at least geo-filtering is something you can enable to say, okay, if request is coming from another different country, I do not want to show them the content, right? Optimization options are available. This is pretty straightforward. It's all for general web delivery because we are using static content. Then there is rules engine. Now you can add multiple rules based on the header. You can add conditions, based on the device type, on the version, request cookies, post argument, request method, URL path. You can add multiple rules for your caching engine. Locks is common. I mean, we'll not talk about resource locks. We've already discussed, right? You can add a delete lock and whatnot. Let's see if this is back up and running. Yeah. So you see, now I'm running into the same error, which is fine, right? If I use my blob URL, also I'm getting the same thing. If I'm using my CDN content, I'm getting the same thing. So if you want to access, what would you do? You'll create a SAS token and append it directly at the end of the URL. I think I already had a token, but I kind of killed it somewhere. I'll just generate another one. You won't find the image inside the CDN. The image will be fetched from the origin. Remember, CDN is just content delivery. It does not manage content itself. The content, the source of the content is always your storage account, right? So once I've passed in the SAS token, again, how have I accessed this? I'm hitting the CDN URL. I'm not hitting the blob storage URL, right? Now this content will be cached in CDN, right? Depending on the kind of rules that we have set, whatever, right? If you try to load it 5, 6 times, or even it is now loading faster, right? Even if you try a newer incognito window or a different browser, you'll see that compared to a storage account, again, there are multiple parameters to it. My storage account is created in East US. Still, in private browser or an incognito window, you can see the pace at which it is opening. Now, the same thing I can show you if I hit a different URL. There you go. Take the link. Okay, cells out. Right now, if I use the I need the SAS token. Copy the SAS token. Right. Now I'm hitting the blob URL. You see how long it is taking? It takes a while to load, right? Because this is not coming through the CDN endpoint. And this is exactly what we say, talk about latency, right? If you want to see that again, let me use a different browser window. Okay, I'll close this. I'll open another incognito tab. Now this is my blob URL. You see the time it is taking to load. Now what I'll do is I'll hit the CDN URL. So the difference is very, very, very much evident, right? Imagine you have a website with loads of images, high definition images, right? It's going to impact your page times by quite a bit. Okay. The CDN, like I said, all you need to do is go to your CDN profile. In the CDN profile, you will see the endpoint. This is your CDN URL. This is your endpoint. What you do is this is the blob URL, right? How you access the image. All you need to do is replace this blob.core.windows.net with your CDN endpoint. Yeah, which of these storage services can be mounted on a desktop as file storage? Let's move on to the second one. Which of the following access tiers should be used for low latency access? Hot, yes. Which of these services is used to store structured data? Table storage here. All right. Next question. Which of the following is a type of key used by Azure Table Storage? The partition key is the right answer. So it's a composite key made up of partition key and row key. So in this module, right, so we've looked at storage, we looked at all possible options. Now we'll dive into compute. So in compute, we'll start with what a virtual machine is. What a virtual machine is, we'll look at what an Azure virtual machine is, different types of configurations, the data disks that are available on Azure. There was a time when you had to create a storage account specifically to keep your virtual hard disk for your virtual machines, right? VHD files, VHDX files, whatever those might be. Then they came up with different types of storage, managed disk, unmanaged disk. We'll talk about all of those, right? Uh, Azure virtual machines, network interfaces. Again, that's probably touching a level 100 of networking, right? On the NICs or network interface cards. We'll look at scale sets. We'll look at why we should be using scale sets. Automating deployment is a touchy subject, right? This topic or this session or this workshop actually does not deal with automation. So we'll only look at that at a high level on ARM templates. Again, we look at templates that are available on the portal. We are not going to create or write any templates, right? But if you're interested, I can point you in the right direction and you can go figure it out, get your hands dirty, right? Then we look at VHD templates. VHD is short for virtual hard disks. We look at custom images. Of course, we're going to build custom images, stand-up VMs, whatnot. We're looking at We'll also look at backing up of Azure VMs. Again, backups will go back to the recovery services vault topic as well. So we'll be touching those briefly. After backup, of course, you want to test restoring a VM, Azure Site Recovery. Again, that is a tool available which is also used for migrations, right? While it's a site recovery option, but it's also used in migration scenarios. We look at app services, and then we look at Azure Container Registry, which is ACR, and also Kubernetes service. Again, remember, we're not diving deep into Kubernetes. We are not setting up multiple clusters and playing around with them, but if you want, we can deploy a sample app. Again, through automation, it's available on GitHub. But like I said, there's going to be a lot of hands-on that you might want to do yourself. I can point you to the links and you can go from there. Okay? So that will be the compute module. Then there is storage, then we've got networking, followed by, I think there's logging, monitoring, and others as well, right? So let's get started. What is a virtual machine? What I'm sharing right now is a virtual machine, which is not on the cloud, of course. It's running on my physical machine, right? So this is a virtual machine. So what is a virtual machine? Emulation of a physical computer, right? So virtual machines can not only run on the cloud. So in short, a virtual machine is an emulation of a physical computer system. You get the three important things: CPU, memory, and NIC, and it gives you the same experience as if you were on a physical device. So if I look at this, I don't know what's wrong with my, maybe I need to restart this guy. It's been a while, right? It'll give you the same look and feel of a physical machine. Let me just restart this guy, turn it off, turn it on, right? And the way it looks is also similar, right? So if you look at the console access, it the boot also looks very similar. However, you won't see all of this on the cloud, right? You would see it only if you had console access. One thing to understand, right? While the cloud and everything, we've discussed this in the introduction, right? Virtual machines are what virtualization is what help us build the cloud and to bring it to where we are today. But you have to understand on-premise virtualization or virtualization on physical machines is different than the virtualization that's available on the cloud from a console perspective, right? So what you just saw, where the OS was booting and whatnot, right? You do not get console access of your virtual machines on the cloud, right? But if you were, now what I'm using right now is Hyper-V, right? And I've got multiple virtual machines running on my desktop. So you can access the console only on if you own the virtualization layer. When it comes to the cloud, right, the virtualization layer is not something that is shown to us. What we are shown is only a web-based interface where you can connect to your virtual machine using either the public, using a public IP or using the other options that we'll discuss, right? Now, a virtual machine does not, the look and feel as you're seeing on screen, it's exactly the same as a physical machine, right? So with that knocked out, again, now we've talked about this. VMs can also be created in the cloud, right? Now, what we mean by that is they are available to us over the internet. Now we've talked about the options there, right? Each cloud service provider has their own version of virtualization. They provide us that. The interface that we have is the portal, which we have been accessing over the past few sessions, right? We've created things like storage accounts and whatnot. We'll go ahead and create a virtual machine from there as well, right? The thing that we can, like I said, the primary difference on virtual machines running on the cloud versus the virtual machines running on-prem is the level of control that you get, right? Again, not all use cases will need us to worry about console level access, right? There are multiple ways to recover virtual machines on the cloud as well. Okay. So these VMs can be created anywhere. It can be on your physical device, it can be on a different server or a different host machine, or it can be on the cloud, right? Now, why would you use a virtual machine? Again, it's pretty common infrastructure as a service available. Why would you want virtual machines? The advantages, as you can see here, I've got three virtual machines, each running a different operating system on the same physical computer, right? That is a huge advantage. So I'm running Windows, but if I want to run any Linux workload, I can run that on my Linux on my virtual machine on the VM, right? So multiple operating systems. Now the one that we ran earlier was Ubuntu. I've just booted the RHEL. So this is how this will be Fedora. This is, you can use multiple, this is RHEL 7. So you can use multiple virtual machines with different operating systems and run all of them on a single physical machine, right? So it brings in a lot of advantages. We've already discussed about those. I'll let this boot. That's fine. Again, you can create single purpose servers without having to set up a whole physical VM, right? Now I can, if I want to, run database on this and run my web on this, right? It's all going to be the same. So this is RHEL. You can log in, you can run a specific workload on this, another specific workload on the other, and it's all on the same physical resource. And these can be purpose built. Okay. Last field login. I'm still failing. I don't know what's wrong. Or maybe it logged in and it's just a little slow. There you go. So it's as simple as that. You can run. The reason I prefer Ubuntu over RHEL is the display scaling. There are not drivers enough on the RHEL, but there you go. And then you can also create high availability clusters, minimize downtime, whatnot. You can do a lot of things when it comes to virtual machines. Very specifically, you'd be able to efficiently utilize the capacity, the physical server capacity that you have, right? Now, what an Azure virtual machine is a little different. Now, this is where I think few of the definitions that came in earlier will help. Now, Azure virtual machines are the ones that are hosted in Azure. It's as simple as that. What is an on-prem virtual machine? This is an on-prem virtual machine. Now, you can run the same virtual machine on the cloud, right? Now, this VM that is running, and where's the other VM? Dead. And this VM that is running, these are running on my machine, right? But instead of, if these were running on the cloud or specifically on Azure, you'd call it a Azure virtual machine, right? This is an IaaS offering, infrastructure as a service offering from Azure. So these are the basics of compute, right? The first thing that we need, we consume from a compute perspective is a virtual machine. Again, you don't have to worry about buying, maintaining physical hardware, whatnot. And that's kind of common across any Azure service that you consume or any cloud service that you consume. Now, Azure offers different types of VMs based on certain criteria. It can be memory, it can be compute, right? What does that mean is, if you look at the way I am running things, right? I have, let me look at these properties. I remember showing them earlier as well, right? So in the settings, what you can see is I have 8 GB of RAM assigned, okay? And I have, where's my CPU? I've got two virtual processors that I've assigned, right? So the configuration of this is 2 core, 8 GB RAM. And I've got a hard disk, which is, I believe, 127 gigs in size, right? Now, this is the configuration that I have set up, right? Now, there are multiple permutations and combinations available for the size of the virtual machines that you want to create, right? The categories range from a general purpose use, then you have one for high processing power, you have one for high compute workload, you've got one for large storage, you've got one for, which is optimized for memory, right? There are quite a few, and these keep getting updated very frequently, right? So you might see newer sizes pop up based on use cases. There are high performance compute machines. There are the ones for graphics as well, for graphics processing as well, right? There are quite a few sizes. All of these broadly are categorized into multiple series of VMs. Now, I'll not want to go through this slide. Rather, I would want you to see this on the Azure portal itself, because that is where you'd find the latest and greatest information, right? So I just look those up. Now, what these are called are SKUs or SKUs in short, right? A SKU is short for stock keeping unit, right? SKU. In short, you'd call it SKU. right? VM SKUs or sizes are available here. So if you look at the categories, you've got these are the broad categories. You've got general purpose. Okay, general purpose series are like this. So you have an A series, a B series. These are burstable. We'll talk about these in a bit. The there's multiple naming conventions, right? One thing I'd say in short is general purpose is A and D, A, B, D, right? Again, there is a naming convention to these as well, right? So they start with A, B, C, D all the way to F, okay? The way they are used. General purpose are A, B, and D series SKUs. Now, if I click on one of these, you'll see the different sizes that are available in these series, right? So you can see that DCS V2 series, these have these are confidential SKUs, right? So these protect confidentiality and integrity of your data, blah blah blah. You can look at what these are actually running on. These are backed by 3.7 gigahertz Intel Xeon processors, Coffee Lake, right? And they give you max turbo boost up to 5 gigahertz. So they also talk about the physical servers behind each of these queues. These are the most common ones, right? DSV2 series. These are running on third generation Intel processors, right? So again, not all of these are specs. For some use cases, you definitely want to explore that, right? If you want to understand what is your VM actually running on, right? Now, if it was my scenario, if I had to tell what I am running on, my VMs would be running on the hardware, which is, where is this? CPU. Yeah. So I'm running on Intel Core i5-10400 at 2.9 and up to 12 cores of processors, whatnot. So this is how I would say what kind of processor, the host processor, the VMs are running on. Similarly, Azure as well. Not only Azure, right? Any CSP is going to tell you what is the hardware each series is running on and what are the different sizes that you have in it. So you can start from one core, 3.5 GB of RAM to 16 core, 56 GB of RAM, right? 16 core, 56. Now these are DS2 or DS3. Each series has multiple sizes, right? So you see this standard D64 is running 64 cores and 256 GB of memory, right? So the first one is general purpose. Now this is for most common workloads. You can run web servers on it. You can run file shares, file servers, anything, right? General purpose, as the name suggests. The second ones are compute optimized. Okay. Compute optimized are the workloads or are the virtual machines. The configurations are very specifically tuned to workloads that are compute heavy. So, for example, web servers, your firewalls, right? These are the ones that you would use typically on the compute optimized SKUs. Now, there is a virtual machine selector tool also that is available. It is pretty new, right? So you can find it by workload type, whatever, but I'm not a huge fan of the selector. I'd rather choose it myself, right? Now these get higher turbo clock speed if you see, right? Why is it compute optimized? You can go up to, multi-cores, you can go up to 3.4 gig or a maximum single core turbo frequency of 3.7 gigahertz, right? Now, this is where these are the SKUs that you'd want to use. An FSV2 series or an F series is what you would use for your firewalls because there's going to be a lot of packet inspection. It has to do a lot of decrypting, encrypting of the packets and send it for your website because if you want to run any server-side workload to serve your web applications to multiple users, you need compute optimized machines, right? So compute optimized are typically used for your web servers or your firewalls. Again, multiple sizes that are available. They can go up to 72 cores and 144 gigabytes of memory. So one thing you have to understand is based on the type of optimization you're choosing, all that is changing is the cores and memory ratio, right? So 72 cores, 144, this gives you about approximately what, 2 cores per 1 GB of RAM, right? So it's like 1:2. And that ratio will be maintained across, right? 4 cores, 8 GB, 8 cores, 16 GB. 16 into 2, 32, 32 into 2, 64, right? So what changes across all of these multiple SKUs is the CPU to memory ratio, right? Of course, there are other things to worry about, like the number of NICs you can do, what is the maximum bandwidth that you get, what is the maximum throughput that you can get on storage. But primarily, what's important to understand is all of these are just different varieties of ratios on CPU to memory. Okay? If you look at general purpose ones, right, each series will have a different CPU to memory. This is like 1:4, right? There's more memory. Okay. So 1:4, compute optimized is 1:2. Memory optimized, on the other hand, you get a lot more memory for lesser number of cores, right? Memory optimized SKUs are the ones that you would typically use for memory heavy or memory intensive workloads. One example is any database server, right? It's memory intensive. Here, if you see, the ratio is 1:7, right? 2, 14, 4, 28, 8, 56. It's 7 times, right? So memory optimized SKUs have more RAM for each core, right? General purpose is kind of balanced. Compute optimized is lesser RAM, more cores. You don't need as much memory. And then there's storage optimized. Now, these are very specifically for storage servers, right? Where you have the ability to attach NVMe disks. So you get a lot of NVMe storage, faster storage. You can attach a lot of disks. You look at the throughputs that is available. You get up to 400,000 IOPS with more than 2000 Mbps of speed. Again, the ratio is like 1:8 on CPU and memory. Okay. Now, there are other options as well. One thing you have to remember, general purpose compute and memory optimized are widely used. Storage optimized are very specifically for scenarios like creating Exadata servers, Oracle servers, whatnot. So yeah, there's a question I need to drop off. What time does the class finish? The class finishes at 11 p.m. Sayed, if you're in India, or in the next half an hour. Uh, Feel free to drop off. You can listen to the recording, right? That's fine. All right. The next types, these are rarely used, right? But we'll still go through them, right? Storage optimized is L, right? Memory optimized are uh, E series primarily and M series. Okay. Now, there is GPU or accelerated compute. These are all N series. N series are for graphics. Now, you'd see there's be larger, heavy SKUs on this, right? These are supported by NVIDIA CPUs and have graphics cards as well. There's graphics memory in there as well. Now, you'd use these for rendering or building. Uh, uh, Mostly the gaming companies kind of use these kind of heavy SKUs, right? So if you're rendering lots of frames, you're building out a 3D animation, 2D animation, whatnot, right? So you can use the graphics or GPU optimized SKUs. Now these are also available FPGA SKUs. Now these keep changing more often than not. This is again for graphics as well, but I haven't dived into these much. I don't know what FPGA is. HPCs. Now, these are interesting, right? These are high performance compute workloads. These can be specifically for running your AI tools or your big data clusters or your machine learning algorithms, right? For example, things like ChatGPT would need a HPC SKU to run. And trust me, these queues are huge, right? They run on large cores, and these are more often than not dedicated, right? If you look at HPV3 series, performance series, they go up to 120 cores, 448 gigs of memory, right? So these are for large scale or high performance compute kind of workloads, right? Now, each of these queues have benchmark scores for different types of operating systems, right? Each SKU, each family has its own benchmark score. So you can understand how these virtual machine SKUs compare in terms of a benchmark. right? So each queue has its own underlying hardware, right? So if the hardware changes, so does the benchmark. So you can't expect the same kind of performance always. Okay. So again, same thing here on the slides. Like I said, there'll be more series that keep getting added. So your single source of truth is always what is there on the Azure portal, right? So what we have here is again the different series which we looked at: A series, D series, general purpose, right? F series VM is more on compute optimized. G series is memory optimized. H series, we've looked at high performance computing VMs. L series are storage optimized. M series memory optimized, just like the G series VMs. N series virtual machines are GPU or graphics enabled VMs. This interesting graphic. Okay, we've just looked at these. We've talked about these. Compute optimized, you probably use in medium traffic web servers. Network appliances are actually firewalls. You can use them for batch processing and application servers. Memory optimized, preferably, typically used in relational database servers. So it can be SQL server, it can be your Oracle, it can be your MySQL, whatever. Storage optimized, again, they give higher disk throughput, right? Apart from the CPU to memory ratio that we saw. GPU optimized, as we discussed, high graphic performance for visualization workloads. HPC, primarily for AI kind of workload, modeling and running simulations. Let's go ahead and create a VM using the Azure portal. So let's get to our portal. Again, search bar is your friend. Type in virtual machines. You'll see the first service light up. You can click on that and then in create, choose the first option, which is Azure Virtual Machine. Okay. So once you choose that, you'll see a page. You would already have your resource group. I don't have one. Okay, I'll have to switch to this. Oh, I deleted all of mine. Okay. So if you don't have one, just click on create new and you should be able to create one real quick. Give your VM a name. Choose your region. One thing you'd want to switch is the security type. Just choose standard. Don't use trusted for now. Now the image is where you can choose the operating system that you want. All data centers will have physical. I mean, without a physical server, you don't have a virtual machine, right? Now, what cloud providers do is based on newer hardware, they keep generating newer series of VMs, right? So the VM can sit in any physical host. So eventually, it's all physical servers somewhere where you can run multiple VMs on. Let's just choose Windows because it's easier to log in. You can choose Windows 10 or 11 as well if you want to, but I'd stick with Windows Server 2022 Data Center Edition. Is it not available? Yeah, it's available. Yeah. So I'm just choosing the Windows Server just because it is easier to remote desktop into, right? Rather than worry about SSH. If you are okay, comfortable with Linux, go ahead and host a Linux machine. That's absolutely fine. The next important thing is the size, right? This is where all the SKUs that we saw will show up. You see, um, this is showing you what are the most used ones, but you can just choose whatever SKU that you want. I'm going to choose probably something which is at least 4 cores, primarily because Windows servers take a bit of time to load. And there's also a cost that will come up. So if you see it's saying 15,249 rupees per month, it's expensive. Um, Let me choose something lower. And this is fine. Oh, this is even larger. Okay, I'll just stick with it. Remember, turn off your VMs or you're going to burn your credit like there's no tomorrow. Okay. Once you choose your size, you need to provide a username and password. Remember, this is your admin username and password that you will use to sign in. One other thing to understand is keywords like admin or administrator will not work because they are reserved, right? Admin and administrator don't work. So choose something like a test admin or Azure admin or whatever. Choose your password. Okay. Now, one thing is it can be different, depends on the region. I have chosen Asia Pacific. If you're using some other regions, it'll be cheaper. It can be cheaper, or it can be higher. We, for now, leave public inbound ports as the default that are showing up. Now, you need this because it creates a security group or a firewall. So leave it as default. We'll understand or deep dive into all of those when we talk about the networking topic. Okay. And that's it. Let's not worry about anything else. Networking disks, it's going to create a network for you and whatnot. So that's all the inputs that we will provide. I can show you what is happening on the disks section as well. Right. OS disk, you can choose the size of your OS disk. Right. We are leaving it as image default. OS disk type, you can choose other options. I'm just leaving this as default. There is delete with VM option checked. So if you check this box, if you delete the virtual machine, the OS disk also gets deleted. Okay. In the networking section, you'll see that it's basically creating a new virtual network for you, right? We'll talk about VNets a little later. It creates a network for you, it creates a subnet for you, and it creates a public IP for you as well. Okay. So we'll not mess with any of these. We'll leave it as is. There are options for managing your VMs, right? You can log in with Azure AD, you can enable auto shutdown, enabling backup, etc., etc. You're not doing any of these, right? So once we're done, once you've chosen everything, Azure detected that there are other region size and zone recommendation. What is it? Region Central India. Oh, it's telling me that there is a cheaper option. Okay, thank you. I'll choose that. It doesn't matter because I'm going to delete it anyway. But yeah. All right. Click on Review plus Create. Now it is telling you that you've got your ports open to the internet. It's fine because it's only for testing. So we're not changing anything. Again, enterprises do not deploy using the portal. No enterprise is going to have a public IP. That's okay. We're just getting our hands dirty. So go ahead, click on Create. So in the basic section, if you have chosen the default values and are not messed with it, you should see it. Let me open up another tab. It'll always show up. I mean, there's no reason why it shouldn't. So if you scroll down, it'll show you public inbound ports. And if you have chosen Windows, of course, it'll show you RDP. If you have chosen Linux, it'll show you SSH, HTTP, HTTPS, whatnot. So pick your poison. If it's deployed, you would see that the status is running. So the way you can check if it is deployed or not, and if it's running or not, machine agent status not ready. That's fine. Just refresh the portal. No, you should be fine. Now let's use remote desktop, and you'd use this IP, okay, to remote into the server. I use a different client, but if you are using Windows, just click on start, type in remote desktop, and all you need to do is key in the IP and you would be able to log in. Choose any client that you want, a remote desktop client, you should be okay. Then it asks you for the username and password. Remember the username and password that we keyed in when creating the VM. We will use that and log in. So for for you folks who are not using any other client, you would use the Windows Remote Desktop connection. It will look something like this. Paste in the IP address of the server that you want to connect to, that you have created, right? The public IP address. And once you click on connect, it will prompt you for the username and password just like this, and you can connect, right? So once you connect, you'll see Windows Server will be up and running, right? You can do whatever you want to on this, right? You can run basic commands if you're interested, set up IIS, whatnot, right? But once the server is ready, it's up for grabs, right? You can do whatever you want to do with it. So you can see the specs of the server here as well, right? What we have deployed. So it says the hardware is Microsoft Corporation virtual machine. It's running 16 GB. And this is where you'd see the type of processor as well, right? So this is running on hardware, which is running Intel Xeon Platinum, right? So the four cores, you've got 16 gigs of memory, about 158 gigs of space. If you look at Task Manager, more details in the performance section, you can see what we have. So you have got four virtual processors on a single socket, right? It's a virtual machine tagged as yes. The memory is 16 GB, and you have network as well on this. And there are DNS names and other things that Azure, there's an IP address tied to it, there's an IPv6 address tied to it, right? You can explore all of these options that are available. Again, if you know what you're doing, you've done this a couple of times, then choose your client. I use a different client to connect. So this is called Royal TS. It's free. You can connect to multiple VMs and play around with them if you want. So what we look at on the portal again is a few things, right? Specifically around the virtual machine configuration. Okay. So the few things that we were asked, it's still deploying. Go ahead, Praveen, let it deploy. You can listen in. Once it's ready, just try to log into the VM and just check if you're able to. Okay. So trying to understand the basics, how to increase memory on existing. You can't just increase memory, Sri. You'd have to change the SKU, right? And that is, I'll talk you through that, right? You just can't change only memory or only the CPU. You have to change the entire VM size. Let's coming back to the configurations, right? Now, the basic things that we need, the minimal information that we need is, of course, you need a subscription, right? So we all have an Azure subscription. That's the first thing that we need. The second thing that we need is what? The resource group, which we already have, right? We created a resource group. The next thing is the region where we wanted to choose, right? So we've chosen a region to deploy, right? Now, the second thing that you'd notice is the disks. Now, we did not create anything specific, right? We went with the default. So under the settings tab in disks, you will see that there is a OS disk that is created, right? Now, if you want, you can attach multiple data disks. Now, the best, I wouldn't call it best, but the recommended practice always is that your applications should always be on data disks and never be on the operating system disk. Okay. So in terms of VM configurations, apart from the basics like a subscription, a region, a resource group, you would need to define the disks. At a minimum, you will get an OS disk. And the other thing that you would have observed on your VM, let me just go to the VM, is disks is storage. Well, disks are disks. Eventually, they are storage. Yes, there is an operating system disk and a data disk, right? So if you notice on the VM, there is the Windows or the C drive, the disk. This is the OS disk, which is 127. And you also see that there is a temporary storage, right? A temporary storage comes as part of all virtual machines, right? Temporary storage, you see there is a data warning, read me. What it is saying is, this is a temporary disk. Any data stored is subject to loss and there is no way to recover it in capitals. So they're basically shouting and telling you that. So don't use this disk for storing any personal or application data. Okay. So you get two disks, right? These are the two, uh, any virtual machine will come with at least two disks. Okay. OS disk is mandatory. Now, this is what comes as part of your, this is where your image is. This is where your operating system is, right? And the second is temporary storage. One thing really important to understand is if you were, let's say, installing an application or creating an application. So, for example, let me just set up IIS on this and I'll show you what I mean. Okay, setting up IIS is very straightforward. If you haven't done this, it's easier to know. So all you do is add roles and features, and then we'll do a role-based installation. Just keep doing next, next, next. And then in server roles, we select web server. Now you can choose any other server. You can create an ADCS, Active Directory Domain Services, Federation Services, whatever. But just do next, 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 finish. I just want to install a basic IIS to show you what I mean by application sitting in a different disk altogether. Right. So while this is installing, one thing to understand, you see on the portal, I do not have data disks here. Okay. We haven't created one. You can go ahead and create and attach a new one. That's fine. Each virtual machine comes with at least two disks, right? You see the OS disk only on the portal. The temp disk is always attached to the VM, right? Again, you wouldn't store your application data on it because it is, if you reboot your VM or you resize your VM, that storage will get lost, right? Apart from the basics, the second important thing is to understand is the disks that you have, right? They are separated specifically by the OS disk. You can only have one OS disk per machine. You can have n number of data disks, right? And the number of data disks is also depends on the size of the VM that you choose. Okay. The third important thing, again, compute piece we have sorted, which is the size of the virtual machine. Storage piece is this, right? The OS disk and data disk. The other important thing is network, right? So if you click on the networking tab, you'll see that there is a network interface that gets created and there is a private IP and a public IP, right? Also, there is a virtual network and other things that are created, right? So if you want a public IP or not, if you see here, there is a public IP that is what we've used to connect to the virtual machine, right? The next is management. So you can choose to automatically shut down the VM or automatically back up the VM, etc. Right? So those are listed as part of our operations here, right? So if you look at auto shutdown, you can enable auto shutdown on a specific time. It is going to auto shut down your VMs. This is not what you would use in an enterprise, right? But on a dev test workloads to save cost, you can shut down the VM, right? You can also run updates of your operating system, right? You can choose, there's an Azure Update Manager that you can choose. You can automate and whatnot. You can also do a backup for this again. We'll deal with this later in the upcoming sessions, right? You can back up your VM as well. And now there are a few things called guest configurations. So what you can do is automatically set up configuration of the virtual machine, right? The way you would do that, or why you would need to do it is, or does this all add to the cost? No, auto shutdown, all of these won't add to the cost. Disks will add to the cost, and the VM itself and the license will add to the cost, right? Now you can add extensions to run custom scripts, right? You can use semantic extension, whatnot. You can use Azure AD based login, right? Now these are all trying to get your VM to a state which you want. So for example, I just installed IIS that you can do using an extension, right? And of course, as usual, tags are something that we can attach to the VM. All of these are the basics, the VM, Azure VM configuration basics, right? Now I'll quickly show you what I meant by application being on a different thing. Now that IIS is set up, right? So IIS will always have the application sitting in this folder, right? inetpub ww root. What does that mean? The moment, let me just launch this, I'll show you. If I type it, so you see this, if I type in localhost, now this is my web page, right? This web page is actually sitting in the C drive in inetpub ww root. Now, if you have an application, you don't want your application sitting on the C drive, because if anything happens to the OS, you lose your application as well, right? And of course, you don't want it on the D drive as well, because D drive by default is the temp disk, the temporary disk where there is a data loss warning. Now, there are scenarios where customers or enterprises use the D colon drive for other scenarios. In such cases, there are ways where you can change the drive letter of the temporary storage to something else. Okay. So overviews, we've just talked about these, the VM configurations, basics, disks, networking, management, guest configuration, and tags. Okay. If you're done, if you have successfully logged into your VMs, we are good now. Two recommendations: either shut down your VM or delete it. Either way works, right? I prefer to delete just in case the shutdown doesn't work. So at least a quick recap, right? So when we create a VM, what we would get at a minimum is at least two disks on the virtual machine, right? One of those is the OS disk, which is usually attached to the VM, and we can see this on the portal, right? And the second disk that is available for us to consume is the temp disk. Now, the size of the temp disk would vary based on the VM's SKU, right? A D series, E series, we've looked at all those models, right? So any VM will have at least two, okay? So at least two disks. Now, the reason why, now, if in case, the recommended practice always is to ensure that your applications, right? So if you have your web app or your application code, whatever, this application should never be on the OS disk, right? The reason for this is to ensure that even in case there is an OS update or a OS patch or even a disk failure, your data is always secure. So for that, the option that we have on Azure are for the Azure VMs is data disks, right? So we can create and attach multiple data disks onto the virtual machines to make sure that your applications or any of your database, right? So it's an application, you would want it on the data disk, or if you need your databases, any workload, right? So I'd call this any workload that you want, which is related to your application or your database or your middleware or whatever, all of those workloads should always be on data disks. You will never put them on the OS disk. The default drive letter for OS disk is C, right? The default drive letter for the temp disk is D. right? Now there is of course options where you can change this. You can switch the drive letter in case you have hard-coded applications where you're migrating from on-prem, and if your applications are expecting a D drive, you can definitely expect to, you can definitely change the drive letter. Okay. So any workload will always be on data disk, not on the OS disk or on the temp disk. So a quick recap, right? Virtual machines will use disks. Again, there's two disks that we talked about: operating system disk and the temporary disk, right? Now, the OS disk is exclusively for the operating system only, right? We never recommend to put anything in there uh, for production workloads, right? Of course, dev test, you can choose to do that, right? Temporary disk is relatively faster storage, but then the data in the temp disk has a very high chance of being lost in case the VM is rebooted or in case the virtual machine is stopped and started. Okay. Okay. So question is, when you're hired on by a company and they want about 2000 storage account with limited time, 2000 storage accounts, that's interesting. But yeah, you can definitely automate that person. Just run it, run creating storage accounts in a loop, and you should be fine. You'll definitely be throttled at an Azure level. It's not going to be easy. So if Azure has protections on that side, right? So there's a limit on number of storage accounts. So if you really plan to run 2000 storage accounts, you can create a script, but then there are guardrails on Azure to make sure that you're not eating up resources like that, right? Especially these large numbers, right? So 2000 storage accounts, you would definitely want to reach out to your TAM first, right? So if you have a enterprise account, so there would be a dedicated technical account manager. You'd reach out to them, you'd ensure there is capacity. You will let Azure know that you're spinning up 2000 storage accounts, and you can spin them up. Now, your question, Kwasi, you're saying limited time. So, I mean, I'd rather question the premise. Why 2000 storage accounts? Why not just 2000 folders in a single storage account, right? So, anyway, it's getting into architecture, but yeah, you can script it out. All right. So, OS disk, temp disk, we've talked about this. Temp disk is only for data, where you want to probably run some, and it's relatively faster. So, temp disk, you can do processing of your data, but you can't really store any data. Again, so the same thing here on the slides. So the OS disk is created from an image. It's stored in the Azure storage account. Again, we'll talk about that storage account bit in some time. Right? There's only one OS disk per VM. It's always labeled as C drive for Windows and dev/SDA for Linux by default. And you can have a maximum size of 2 TB. I believe it has now changed. You can take a look at it on the portal, right? So any limits or any additional things that might have changed, I would recommend you to always take the truth from the portal, right? Not from these slides, right? Slides are old. Slides can, get old. The cloud changes faster. So your single source of truth is always the Azure portal. Okay. Temp storage, as we've discussed, there's no extra cost to it. Size of the temporary disk totally depends on the virtual machine type or SKU that you have chosen. The disclaimer, as always, data on disk will be lost if you resize, shut down, or restart, or if the VM is moved to a different host server, right? Again, remember, all of these are virtual machines, right? And so virtual machines will run on a host machine, physical server. The temp disk that you get is local to that host. And that is the reason why the data can get lost. And that is also the reason why you get faster performance on the temporary disk for you to be able to do any sort of data processing on it, which would probably need heavier IOPS. During a standard reboot, the data should persist, but again, there is a risk. Is it possible to customize the partition instead of assigning the total space to root? Again, there's no partitioning. Again, you're on a virtual hard disk. So why do you want to partition? Rather, just provision the size that you need and add additional data disks. So partitioning is not something that you would want to do or you would do on a virtual machine. Physical disks, yes. Virtual disks, no. Right? So the solution for from Azure to place in your data is, they are data disks. Again, these are virtual hard disks that we assign, that we attach to the virtual machines. Now, usually, again, as everything in Azure needs a storage account, all of these virtual hard disks or VHDs, they also sit in a storage account. Okay. Even your OS disks, right, which is a VHD, they will also sit in a storage account, right? Typically, they all consume your blob storage, right? They all sit in a storage account in the backend. Now, initially, when Azure was new, there was, you had to create a storage account for yourself. In that storage account, you would, point your virtual hard disks, your VHD files. You could have multiple VHDs, an OS disk, a data disk, VHD, multiple data disks, right? N number of VHDs, and all of these would be used for your virtual machine to be spun up, right? This scenario, again, there were limits, like you could not go beyond 500 images in a storage account, etc., etc. And you had to always keep a tab on the amount of storage that you were consuming in the storage account, right? This kind of model where you manage the storage account and you point and you handle the VHDs in the storage account. This model, or if you created a disk where you manage the storage account, the disk was called an unmanaged disk, right? So an unmanaged disk was a scenario where you create your own storage account and you create your VHDs or save your VHDs in your own storage account, right? Eventually, as Azure grew, you had the concept of managed disks. What this meant was you wouldn't worry about where your VHD sits. You wouldn't worry about your storage account, right? All of this gets managed by Azure. And that's the reason why it's called a managed disk, right? So these were the two types. I'm not sure if we have the slides on them, but this is an important fact to understand. Managed disk versus unmanaged disks, right? Managed disks are where the end user manages the storage for the virtual hard disks or VHD files for those disks. And managed disks are are a deployment where basically Azure manages the storage behind them and also the VHDs. So one, virtual hard disks, we already talked about these, right? The number of data disks, you can attach n number. The max number totally depends on the size of the VM, right? So if it is a DS V2, we've looked at the sizes, right? D series, E series, uh, F series, L series, right? L series are storage specific SKUs. So these SKUs typically will have large numbers. So you could probably attach up to 100 disks or more, depending on how much cores and memory you're taking. Okay. The other thing to understand, the maximum data disk capacity that you have is up to 4 terabytes per disk, right? Now, of course, you can use storage spaces if you are familiar with that concept or not. It's a Windows Server feature. So you can add multiple disks to go up to 16 terabytes, multiples of 4, right? Or 20 terabytes or 24 terabytes. But the maximum file size you could have will only be 4 terabytes, right? Because unless you are sharding your files, but that's, I don't want to get into that. Like I said, each topic has a tangent, right? One thing to understand from a limits perspective, data disk capacity, maximum capacity is 4 terabytes. The number of data disks that you can attach depends on the size of the virtual machine, right? And that there are two types of disks. One, unmanaged, these are legacy. Two is managed disks, right? Unmanaged disks are where you manage the storage account for where the virtual hard disks are going to be stored. Two managed disks are a scenario where Azure manages the storage account for you and it manages the virtual hard disk file for you. Okay, a few things. So data disks, the facts we've discussed again, data disks are designed for a 5 nines availability, right, which is 99.999. Temporary disk is the local storage. We've discussed about that. OS disk and data disk are implemented as blob storage in a storage account, right? So, like I said, anything storage will always go to a storage account, right? Data disks will get you persistent storage for your applications and data. This is important to understand, right? OS disk, you have an option to detach it. If the VM does not boot up, you can just spin up a new VM and attach your data disks and then get the workload running, right? So if you need persistent storage on your virtual machines, data disks are the way to go, right? Of course, managed and unmanaged disks. So like I said, unmanaged disks, you would be creating the storage accounts where these unmanaged disks will reside. The maximum number of storage accounts per region is limited to 200. And when using the standard storage with unmanaged disks, the advantage, this is actually an advantage with unmanaged disks, is when you're using standard storage, you only pay for the space that you use, right? So the managed disk, again, Azure platform controls the placement, where they sit, it manages the storage, right? There's no limit on the storage accounts. However, there is a limit of 10,000 managed disks per region. Now, of course, you can get that increased, by having a conversation with Azure. It depends on the account and the kind of thing you probably talk to your TAM and get that sorted, right? With managed disks, you pay for the full capacity of the disk, right? Whether or not the disk is in use. So let's say you provision a 100 GB managed disk, you'll pay for the entire 100 GB, whether or not you use them. But in an unmanaged disk, let's say you created a 100 GB disk, but you're only using a 5 GB, 5 GB file store, you only pay for 5 gigs. OS disks, we are only talking about OS disks are managed or unmanaged depending on how you create them. Typically, as of today, OS disks are always managed. You can choose to have your own VHD as well. Okay. So the next topic we have is network interfaces specifically, right? So for this, it's easier if I showed it to you on the portal rather than anywhere else. So let me create a virtual machine. So if you want to use an unmanaged disk, you would have to do it through the command line, right? It's not, I don't believe it's an option that's available for you here. Again, you can see here the maximum size of the OS disk that you can choose is 2 terabytes, right? Now you can create additional disks or you can attach an existing disk, right? If there is existing disks, if you create a new disk, now this is where for unmanaged, uh, this is where you can choose an unmanaged disk for your data, for your data disks. So you can say point it to a storage blob and point it to your VHD here. Okay. Networking. Yeah, I wanted to see the NICs. It cannot be reserved keywords like admin or administrator, but you could choose any other name as well. You can put in your name as an admin account. That's absolutely fine. But there are only reserved. There are a few things like like reserved keywords like admin and administrator. Those are, you cannot use those. Except those, anything else is fine. If it's asking for an upgrade, we can upgrade, Praveen. I mean, not sure if I can do anything much. Okay. So while the VM is getting created, right, let's understand, from a networking perspective, what does a VM need, right? So to be able to communicate, you would need a network, right? A virtual machine needs a network. Now, what we are seeing when we create a VM is that Azure, based on the portal, or if you try to attempt to create a virtual machine, Azure actually creates a virtual network for you along with a network interface card or a NIC, right? So by default, Azure will create only one NIC when you're creating things through the portal. However, you can have more than one network interface card on a VM, right? But at a minimum, you would need at least one, because without that, you wouldn't be even be able to connect to your virtual machine. The other thing to understand is that the location of the NIC should be in the same region. When I say location, the same region. So both the VM and the NIC should be in the same location and in the same subscription. Same location is same region. However, they can be in different resource groups. That's absolutely fine. But they need to be in the same subscription and same region, right? So when we look at the NIC, now NIC typically, where once the VM is provisioned, I'll walk you through that. Okay, so now that we have the virtual machine, the way to look at all the resources that are provisioned. So in the networking section, now let me actually get to the resource group. So in the resource group, you have to notice what all are created when you've created a VM, right? So you would see there is a disk. This is your OS disk. This is your network interface. You can see that in the type. There is a network. We'll talk about NSG and network a little later in the networking section, and a public IP address, right? So virtual machine compute, you have your network, which is coming through your NIC, and you have storage, which is your disk. So if you click on the network interface, or NIC in short, you will see that it has certain things. It gets a private IP address and a public IP address. Now, this public IP address is what we used to connect to the VM earlier, right? In an enterprise scenario, you probably would not have public IPs, right? It'll all be through private IPs only, right? So you can assign multiple IP addresses. You can make them static, right? You can assign a static IP address. IP forwarding is one thing that is very specific for virtual appliances, right? So if you don't enable this, your Barracuda firewall or your Cisco firewall or your Checkpoint virtual firewall, whatever you're provisioning, right? They might not work. So IP forwarding, yes, public IP and private IP are assigned to the same NIC. Azure handles the NAT for you. NAT in short is network address translation for you. Private IP will be very specifically for your consumption only. Sorry, public IP, right? So if you hit that public IP, you can assign a DNS to it if you're running an IIS server or whatever. In the current scenario, you're using it only to remote in, to connect to your virtual machines. But you can, of course, play around with it and add in a DNS name for it and set up a web application and whatnot. So all of those will also work. So again, DNS servers, NSGs we'll talk about in the network, but without a NIC, a VM cannot exist. Now it can have more than one NIC, which is okay. You can add two NICs, one in one subnet, one in another subnet, right? Now that is typically how firewalls are created, right? So if you are experienced with firewalls, they typically have three or four NIC appliances with each NIC sitting in a separate subnet. Okay. IP forwarding is very specifically for network virtual appliances. So IP forwarding again is very specifically for network virtual appliances, which means like things like firewalls, right? Or if you want to forward traffic from this NIC, right, this network interface to another network interface. So if you want to use things like load balancer on the server, right? If you want to use Nginx, for example, right? So all of those are available in the marketplace, right? So one thing that you can explore is uh, the marketplace, and that's where you'd understand what are the things that you can create with the virtual machine. So if I now search for Nginx, right? So there is Nginx. You can create Nginx load balancer directly, right? So this image comes from Nginx themselves. So you can start with a preset configuration. It's going to set up Nginx for you. Again, similarly, there are things like you want to set up a SQL server, you don't need to install SQL on it, right? So if you search for SQL Server, there you go. You have SQL Server on Windows Server 22, on Windows Server 2019, right? You name it, you've got it. So if you look at compute scenarios, yes, all of these are fully managed. In compute, you have SQL Express, SQL on Ubuntu, you have SQL Server. There's a lot of options. You can create a SharePoint server, you can create an Active Directory server. There's a PostgreSQL server. On databases, you've got loads of options. You just need to search for them, right? More or less, there's a lot of vendors available with their images. So if you look at analytics, so the marketplace has a lot of things that you can deploy, right? So if your question is what can you do with a VM, specifically on the cloud, you'd have to worry less because there's typically licensing also included as part of the Azure marketplace. So going and trying to hunt for someone or trying out a new software, right? All of that's not needed, right? Everything's available here. So if you see containers, you've got quite a few modernization assessments, blah, 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 blockchain, mixed reality. On networking is probably where you'd find a few firewalls. This is Nginx on Ubuntu, things like Barracudas, the next gen firewalls. There are Cisco firewalls and a lot of good stuff, right? So with virtual machines, there's a lot that can happen or that can be done for an enterprise, right? So when we say virtual machine, it's just not create a blank virtual machine and then install everything on it. So that's the bit on the NICs, right? Depending on the image, depending on the vendor, they might have more than one network interface card or more than two network interface cards, right? But at least what a virtual machine needs at a minimum is one NIC to work. What is a scale set? Scaling, right? As the name suggests, scale sets are the ones. Scale sets are a resource. A VM scale set is a resource which we would use to create and manage a group of identical machines, right? The number of instances can automatically increase or decrease in response with the demand, right? So in the first session, we were discussing about how you kept on adding new servers as the load kept increasing. And while you added all of these at a point, let's say this is your baseline load, right? When all of the increased load subsided, you still were paying for these extra servers, right? So scale set, on the other hand, the advantage is you define a minimum. You say my minimum is 3, and based on the load, right? We look at the properties of what types of loads it can be. But I say, let's say if the CPU is going beyond 80%, I will say keep on adding one node, right? And you can go up to letters. You can also define the max count, which I'd probably say, 10, right? And if the load decreases, let's say the CPU goes down, then you would delete all of these and run your minimum number of nodes. So it will never go down the minimum. It can never go down or go above the maximum, right? So we can configure that. The resource that helps you do it on Azure is called a VM scale set. In short, it is a VMSS. Okay? So these are the terminology that you'd use day in, day out. So VMSS or a VM scale set is something that helps you increase or decrease the number of instances, and these will be identical instances, right? So you would choose the type, whether it is a D series or a DS2, V2, whatever, right? Whatever type you choose, all of the instances will be of the same type. Okay, and they can increase or decrease based on how you configure them, or you can also do it on a defined schedule. So you can say morning 9 to 5, scale out to 10 instances, and after 5 p.m. bring it down to 2 instances, right? So you can do it on a defined schedule, or you can do it in response with the demand. right? Now, what that demand is, we'll take a look at it when we do the hands-on. Azure uses scale sets for a lot of instances, right? For PaaS services, it uses scale set. For Azure Kubernetes services, it uses a scale set, right? So the scale set, while you might not see it directly, but in the backend, there is a lot of use for PaaS services where scale sets are implemented, right? Again, why would you want to use? One is you can create and manage multiple virtual machines, so you can scale out without, you can manage hundreds of virtual machines. You don't need to worry about additional tasks, additional configuration tasks, or additional network management tasks. You can use to, run the multiple instances of your application, which is exactly why we need one, right? You would load balance traffic across your scale set. So high availability is something that you get. Automated scaling, we just discussed about that. You can increase, decrease time, the number of VMs as per the application demand. Again, working at large scale, you can go up to 1,000 instances if you are using Azure-based images, right? The default ones. But if you are using your own custom image for your operating system with the application on it and whatnot, then you would be limited to 600, right? Again, the limits, I would always suggest please look at the portal. But for now, we'll take a look at it. But I think 1,000 VMs, 1,000 instances per scale set if you are using Azure images. So you can go up to 1,000 VMs and up to 600 VMs if you are using your own custom virtual machine image. And all of these are purely metadata that you'd want to know. But before we get into a hands-on, where to find on the portal about the limits? We'll look at it. Look at it. I think it is then the portal. These kind of limits for scale sets might possibly be only on Azure documentation. But let's take a look at it when we go to the hands-on. Okay. So what we'll do in the hands-on is this, right? So we'll create a scale set. We'll set the default value for minimum maximum of number of VMs. We'll scale out at 75% of CPU usage. We'll add one VM. And if it is less than 25%, we'll delete one VM. Okay. So now what we'll do is search for VMSS and you'll find virtual machine scale sets. So click on that. Once you click on that, click on create virtual machine scale set, choose your resource group, choose your scale set name, choose your location. And see, one advantage that you get while deploying scale set is you can choose which zones you want it, right? So you can choose all three zones. What this is going to do is when you create three VMs, it will make sure that the first one is in zone one, second in zone two, third in zone three, again, fourth in zone one, fifth in zone two, sixth in zone three. So in that way, you are able to leverage multiple availability zones for your workload. Orchestration mode, flexible or uniform, right? Now, if you have stateless workloads, you choose uniform, but you want high availability at scale. That is when you would use flexible. So for now, we'll keep the orchestration modes as flexible, right? So security types, switch this to standard. Do not use trusted launch VMs for now. Image, I'm choosing a Windows Server. Okay. Now, one thing that you'd notice is, there are CPU limits that I'm hitting. So what I do is probably switch this to something lower. This is fine, right? So this is the type of the virtual or size of the virtual machines that will get created within the scale set. Now, scaling mode. Now, this is where what we want to do is we want to use auto scaling, right? So choose auto scaling. Yes, choose Windows image for this as well. So in auto scaling, click on configure. Once you click on configure, you'll see the default condition, right? Let's edit this condition. Now, what you see here is what is the initial instance count. Okay. So we don't want two. I'll keep this to one. Okay. So the initial instance count is one. The minimum instance count is also one. Maximum, I'll go up to three, right? Again, to save costs, we just want to test this out, right? So Based, what's our conditions that we have? We want to scale out with when we have 75% of CPU usage, we will add one virtual machine, and we'll scale in or we'll decrease if our CPU usage is about 25%. All right. Initial instance count 1, minimum count is 1, maximum count is 3. The threshold is 80. Let's correct that to 75 and a scale in at 25. So if the CPU threshold is greater than 75%, then I'm increasing the instance count by 1. If the CPU threshold is less than 25%, we will decrease the instance count by 1, right? And this query we can run every 5 minutes. 10 minutes is too long. We'll use 5 minutes. Okay. So once we use with this, we should be good for with our auto scaling configuration. So every 5 minutes, we'll check if the CPU threshold is 70, is it going above 75? If it goes above 75, we will increase the number of VMs by 1. If the threshold is less than 25%, we'll decrease the VM count by 1. Okay. You can click on save. So now you see this is our condition. CPU threshold is 75, 25. Instance count minimum 1, maximum 3, initial 1. Click on save here again. Provide your username and password just like you did for your virtual machines. Okay, so once your username and password is done, you can look at other options. So networking specifically, right? Uh, in the networking section, choose the VNet, choose the network. You already have one. There's no need to create a new one. Choose the same network. You would already have a network which was created when you created your virtual machine earlier, right? So if you call it test VM, you'll see it as test VM hyphen VNet. So just choose that network. Okay. Don't choose any other network because you'd not be able to connect to it, right? So choose an existing network which will already be in your resource group. And that is the only thing that we will worry about. So we've configured the basics. We've configured the networking. Click on review plus create. Basics are simple. So Praveen, again, for you, all you need to choose is a flexible orchestration mode. Choose auto scaling, scaling conditions. So in networking, if you're getting a validation failed, choose load balancing options as none. Okay, we are not load balancing now. Scaling out, scaling in. Okay, so what are we doing when we are scaling out? We are adding a VM. That means we are increasing the VM count. Scaling in is decreasing the VM count, right? So you would scale out when when your load increases and you need to make sure that your workload's response time is good. You would scale in when the load has decreased and you don't want as many instances running. Okay. So we'll let the VM scale set create. Might probably take a while. Meanwhile, what you folks can do is remote in to the VM that you had already created, right? Which has a public IP. So the test VM or whatever you've created, just remote desktop into it. Okay, let's see if the scale set is ready. Okay, deployment succeeded. Okay. So the way what we want to do is actually log into what the machine in the scale set, right? So once you click on the VM scale set, if it's deployed, okay. So you see the settings here that you've already configured. Right now, if you click on the instances on your left, right, it shows that there is one instance that is running. Okay. So if you click on that instance, still has a public IP. I don't know why is this, where is this getting a public IP from? So this is the VM scale set. This is the first instance. So if you have a public IP, you can remote directly into that, right? From the first machine. Ideally, it should not pick up the first machine. I don't know what has happened on this report. Let me check. There's only one public IP on the test VM IP. VM scale set has picked it. That's fine. How you open the VM created? Yeah. So please click on the VM scale set, the virtual machine scale set resource. Once you click on that, you would see the overview page. On the left side in settings, there is instances. You'd see that there is no public IP address, right? So maybe I've chosen to create a public IP. So let's ignore that for now. Okay. So on the left side, you'd see instances. If you click on instances, you will see that there is a VM scale set instance, right? Test whatever is the scale set name that you have given underscore grid. You can click on that. Once you click on that, what we want is the private IP address. Okay, just pick up the private IP address, which is 10.0.0.5. Okay, so once you pick up that IP address, what we will do is on the VM that you've already logged in from within that, click on start, click on remote desktop connection, and type in the IP address. Okay. Same thing, use your credentials. So here you'll see that what we are doing is using the VM that we have deployed, we are using that to connect to our VM scale set instance. Okay. So in scenarios where you don't have public IPs or whatever, typically this is how a jump box or a jump host or a bastion host will work. Right. So what I have logged into is the scale set instance, right? So I'll show you that once server manager pops up. Okay. So this is my scale set instance, whatever 624CD, blah, blah, blah. Okay. So what we need to do is load this up, right? Okay. There is a reset password available for your VM, is what you said, right? So try it again. If it's not working, you should be able to reset it using. So if you click on the virtual machine on the left, you should be able to see. There you go. Reset password under the help section. So if you've forgotten your password, you can try that. All right. Okay. So now what we want to look at. So, you have the virtual machine scale set and everything, right? What we'll do is actually look at the current CPU utilization of the scale set, right? How can we do that? Once you click on the overview section, there's a monitoring tab, right? Now you would see all of these are coming in by default. Okay. So this is the CPU percentage is what we are interested in, right? Because that is the metric on which we have configured the auto scale. Okay. So the current CPU is hovering somewhere around, I don't know, 20%, right? So what we'll do is we will put some load on the CPU. I think there are quite a few websites who can do that. Let me see, CPU stress test. Yeah. CPUX.net. Yeah, this is an interesting way to load, right? I can probably run 2 threads. Okay. So I'll load this up to what was our threshold? 75, right? So let me do 80%, maybe 85% on 2 threads, and then start CPU stress test. So let's see. Fair enough. It's at about 83%. Should go beyond that actually. I wanted 85. Let me increase it further. Increase the number of threads to 4, power to 90. Yeah, perfect. This is at 100%. That's fine. Right. So what I'm doing is increasing the load. So it's currently at what? 100% CPU. So what we'll do is look at this on the portal. This is done on the instance, Praveen. Yes. So the way to look at that is again the monitoring section. The metrics are here, right? So you see this in, let me change this to the last, right? So the percentage CPU, the average CPU on the scale set is currently 24.1915, whatever. So now that we've added some stress, we will wait for it to load. Okay. So what I'm going to do right now is stop the test, right? So this should free up my CPU considerably. So now please pick up the private IP address of the VM instance in the scale set. And so you are on this VM, I'm assuming you've logged into the VM. So use remote desktop connection again and type in the private IP address of the VM instance, the scale set instance. So clear, perfect. What I've done is I've stopped the stress test, right? So we'll give it a few minutes and see what's happening on our scaling. Okay. So currently the run history, if you look at it, so auto scale up has happened. Let me look at what's happened with the scale set. It should be down to one instance. Yeah, it's down. So you see, auto scale down is initiated twice. So I'm now left with only one instance that's running. All right, back to, all right. Next topic is availability sets. Think, okay. So when we were talking about, the way physical data centers are constructed, right? So we talked about data centers having racks. You folks remember that? Excuse my drawing. Don't seem to have straight fingers nowadays, right? So we have racks, servers here, server 1, 2, 3, 4, blah, blah, blah. All of these are servers, right? Each rack is connected to power and network, right? So to ensure that the power outage does not kill all racks at once or all networks at once, right? Any power failure on this side or here, wherever, each rack is complete is connected to multiple or different power and network sources, right? So in this example, it's exaggerated, but I'm just showing you an example, right? So in this scenario, let's say this is a data center, right? This entire thing is a data center, which means this is a availability zone. Okay. And to this availability zone, we have three sources of power, P1, P2, P3, and three sources of network, network 1, network 2, and network 3. Okay. So power 1, network 1 are for rack 1, power 1, power 2, network 2 for rack 2, power 3, network 3 for rack 3. Okay. So this type of connectivity, right? Let me get rid of, right? So power 1, network 1, the combination of the power and network for each rack, right? Separating these out just to make sure that even in case of one being down, only these servers go down, but the other two racks are available, right? All of these are called racks, rack 1, rack 2, rack 3, right? Usually they consist of a few hundreds of servers, okay? It's not just 5 or 6 as I'm depicting here, right? So imagine this at a large scale. So this kind of setup is called, each of this is called a fault domain, okay? So fault domain 0, fault domain 1, fault domain 2, right? So in each availability zone, right, locally within the data center, you have fault domains, right? Fault domain 0, fault domain 1, fault domain 2. What is a fault domain? it is the combination of power and network, right? So fault domain 0. Now let's say there are only three sources. If there is a fourth rack, for example, rack 4, it will again be fault domain 0. There is rack 5, fault domain 1, rack 6, fault domain 2. So fault domain is basically sharing, these rack 1 and rack 6 share the same fault domain, which means they share the same power and network connections. Okay. Second is an update domain. Now what happens is all of these are physical servers, right? All of the servers here, server 1, 2, 3, 4, 1, 2, 3, 4. All of these are physical servers. Not all of them, Deepak. They are spread across 2 or 3 fault domains. It depends. I mean, you cannot have thousands of power sources, thousands of network sources, right? So you probably have 2 or 3 fault domains, and your racks will be spread across all 2 or 3 fault domains. Fault domain not clear. Fault domain is basically, you understand this structure, a rack sharing a power and network switch, a power source and a network switch. Okay, this way of organizing things, right, is called a fault domain. A fault domain essentially means a combination of power and network, a power source and a network switch, right? So if you have three power sources and three network switches, you can arrange them like this. So power 1, network 1 together is fault domain 0. Power 2, network 2 is fault domain 1. Power 3, network 3 is fault domain 2. Okay. Yeah, now you can add racks. Rack 1 will be here, rack 2 will be here, rack 3 will be here, rack 4, rack 5, rack 6, rack 7, sorry, rack 8, rack 9. Each rack can have a few hundreds of servers, right? X number of servers, physical servers, right? Now it's clear. So what a fault domain is basically a combination or the racks which share the same power and network sources. Now, this is at a rack level. Okay, a rack can have a number of servers. Now, what's interesting is all of those are physical servers, right? So, let us say all those physical servers need updating regularly, right? So, they might be rebooted, they might be whatever. So, let me draw out an image of, so let's say this is fault domain 0, fault domain 1, fault domain 2. This is server 1, server 2, server 3, server 4. Same scenario here. Now, if you want to update, now these are physical servers, so they need kind of OS updates or patching or whatever, right? And at some point, they might have to be rebooted. Now, would you want to reboot all of these at once, or all of these at once, or all of these at once? Probably no, right? You want to ensure that your reboots are spread across, right? So what you say in that scenario is, let's say I will reboot this, this, this at the same time. Or I can say I will reboot this, this, this at the same time, right? 3, 3, 3, 4, 4, 4. Okay. So the way I categorize, again, these are 4 servers, but use your imagination. Now this can be again 1, this can be 4, this can be 3, whatever. So the ones that get rebooted at the same time will be this. Oh, sorry, too bad. This guy, and this guy. These will get rebooted at the same time. These will reboot at the same time. These will get rebooted at the same time. This combination is called, you know, update domains, right? Update domains or UD. So what this ensures is not all servers get rebooted at the same time. I will have separate servers in the same fault domain reboot at different times. Okay. So all of these servers put together, it can get very ugly. Give me a minute. And it is too colorful. right? So this combination, right? This combination is what is called an update domain. This is another update domain. This is another update domain. Does this make sense? This is another update domain. Clear? The difference between a fault domain and an update domain? So update domains ensure that your resources are isolated. So let us say you had only one virtual machine, okay, within a zone or in a data center. In one zone, you had one VM. Oops, you had only one virtual machine, right? If you have only one virtual machine, and if it is sitting here, let us say in this location, so it has a risk of risk of going down if this fault domain has a problem, or if it is part of the update domain where this host server one is getting restarted, right? Of course, it will migrate, but there's going to be a blip, right? So for high availability, what is usually recommended is to choose a combination of fault domains and update domains. And the ability on Azure, or the way you can do it on Azure, is using an availability set, right? So you can deploy VMs across fault domains and across update domains, right? So what I've done here, I've deployed a VM here in fault domain 0, update domain 1, one VM in fault domain 1, update domain 2, one in fault domain 3, update domain 3. So in this case, I get high availability within the region, sorry, within the zone. And I can ensure that unexpected reboots or host updates are not bringing my service down. Update domains don't share anything, Venkat. Update domains are a group of servers which will get patched or updated together at the same time. So basically, you can say that they share their update cycle or upgrade cycle. This availability sets were something that came up before the availability zones came up. Because at that point, essentially there was only one data center in a region. Now, with availability zones, the advantage is I would only deploy, instead of worrying about all this crap, right? Update domain, fault domain, whatnot. I will deploy one VM. So this is within the same region, okay, or within the same data center. We discussed about availability zones, right? So here I have DC1, DC2, and data center 3. I will deploy one VM here, one VM here, one VM here. I don't care about fault domain, update domain in DC1. So whatever happens, even if the entire data center is down, I still have two more up, right? And again, by rule, data centers are not all upgraded at the same time, right? The updates don't happen at the same time. So if this is down, let's say there is an update that happened and this VM went down, I still have two more available in two different zones, right? If an upgrade is happening here, the upgrade is finished here. Let's say the upgrade started here. This goes down. I still have two more available, right? So high availability and resiliency within the data center or within a region is how these differ. Okay. So if someone asks you, what do you do to ensure, again, I wouldn't call it high availability, right? This is a little trickier term. Now, if someone asks you, hey, how do you ensure resiliency within the data center? Then you talk about fault domain and update domain. If someone asks you, how do you have resiliency within the region? Then you talk about AZ1, AZ2, AZ3, right? You talk about availability zones. If someone asks you high availability across regions, that is when you say, I'll deploy one in region one, one in region two. Be very clear on what the question is. So if it is within the same data center or in the same zone, we talk about an availability set, right? If it is across, within the same region, then you talk about availability zones. If it is across regions, this is geo. This is more like a DR kind of scenario, right? Again, you can use the same terms. People often use high availability, resiliency hand in hand. It doesn't work that way, right? So high availability or HA can be split into three parts. Within the data center, it is availability set within DC. Within the region, it is availability zone, and across regions, you can, this is geo replication. So this will be a little tricky, but within the region versus within the zone, you would either use an availability set or an availability zone. Again, you can call it resiliency or high availability. People often confuse with these two terms, right? I can even call this high availability, right? High availability within the data center, high availability within zone, high availability across geographies. So resiliency is basically fault tolerance, right? That's what the actual term is. High availability is a result of you having a resilient architecture. Guess not. Okay. So same thing. What is the last one? Resilient architecture. Yeah. See, availability and resiliency. Resiliency is basically fault tolerance, right? That is what we mean. Even if there is anything wrong, you still have your service up and running. So having a resilient architecture means you get high availability within a scope. A highly available application within a data center would mean you deploy it again if it is a virtual machine, right? If it is on virtual machines, then a highly available application within a data center, you would want to deploy it using an availability set. A highly available application across, within the region, you would deploy it in three availability zones. Okay. Next is ARM templates. Again, like I walked you folks earlier, a template, what's there on this slide is not the way it is done, right? You can save a deployment. Yes, you can, but in an enterprise environment, you wouldn't do it this way. You can definitely see a sample of that in your on the portal. Let me show you. So on the resource group, right, anywhere, right, whatever resource you choose, if you scroll down to template, the export template option, right? This generates a template. Again, what is ARM template? We talked about what is ARM. ARM is Azure Resource Manager, right? Azure Resource Manager works on REST APIs. This is one of the inputs to the REST APIs, right? So there are templates for inputs. This is usually a JSON file, right? And this is how it looks like, right? But you never ever generate an ARM template uh, from the portal, right? Unless it is like a dev test scenario, right? If you want to play around with ARM templates, so you can use these, right? Now you can definitely consume the templates from here to deploy and test and play around with things. But ARM templates are hardly used nowadays. Nowadays, most of them, what you see is here you go, the Azure deploy.json. So this is how a template is, right? You can fill in the parameters here. This is JSON. ARM templates are JSON, right? Terraform, Bicep, those are all YAML, all right? Eventually, no matter what you do, you are just feeding information to the REST API. It's as simple as that, right? Whatever you use is just trying to make your life a little easier, whichever tool you choose. So if you want to play around with ARM templates, I don't think any organization is today. There might be a few. You can explore this quick start templates. If you want to explore Terraform, your better resource is the Terraform registry, which is this, the Azure RM provider, right? You want to get started, there are guides, explore it. Okay. This is YAML, right? Now, whatever this YAML is, this YAML eventually feeds a REST API call. Okay. They're all the same. So pick your poison, fortunately. And it's an interesting topic. It's not part of our session, so I'll worry less about it. But all right, see, all of this gets exported. The auto scale settings, right? Whatever we have defined on the portal go in as an input to an ARM template. So the way Azure portal works is on the ARM templates, right? Enterprise scale automation is typically through Terraform, primarily because it helps you keep a state of where things are, right? All of these, you see, time window, this is 5 minutes. Time grain is 1 minute, right? Time aggregation, average, operator greater than. All of this is what we defined in the UI, come up as inputs here, right? What is the scale action? Direction, increase, type, change the count, value by one. What is the cooldown time? 5 minutes, right? All of these are the inputs that we provided when we were doing it through the portal, get eventually fed into a template, right? So that's what is ARM template. But remember one thing, never ever, I mean, in an enterprise scenario, you'd never save a deployment as an ARM template and use that to automate. Okay, that's not how it works. Yes, it is an option in case you want to, take a look at how things are done. Uh, but you would not do it this way. But that's where that's what an ARM template is. Like it's a JSON. It defines the structure, and you'd be able to automate. Before we dive into what a VHD template is. So VHD template. So does anyone know what a VHD is? I know I've talked about this or I've ranted about this quite a bit. Virtual hard disk template for creation. Simple, right? A copy of a VHD or a template, right? With which you can create similar virtual machines, right? So if you're familiar with on-prem or images, right? OS images, you can treat this like that, right? It's like an image that you have from which you can create multiple virtual machines. So straightforward. So a VHD template, what a VHD is basically a managed disk, right? You can create with templates, you can create a template out of a virtual machine. You can save it, right? The current templates that we have used so far, you've seen all of these, right? The ones that we created VMs with. So if you, the moment you chose a virtual machine and you're creating one, you see here, right? It asks you for an image, right? Now, these are all templates that are provided by Azure. There are templates that come in from vendors, which we saw earlier, right? WordPress, this, that, whatever, right? You can create virtual machines out of these images, right? Or templates. The other option is you can also upload a virtual hard disk from your on-prem. Let's say you're running Hyper-V or VMware, whatever. VMware, of course, the VMDKs, you would want to convert them to VHD before uploading them, but you can definitely even copy those VHD files and create your own virtual machines on Azure, right? So that's virtual hard disks or VHDs in short, right? What we would do with this is primarily create custom images. So custom image, for those who don't know, is, let's say you want to install certain, whenever you bring up a server, you want to make sure you have Chrome installed on it, or you want to have XYZ software installed on it. So instead of trying to do that over and over and over again every single time you create a, a new server or a virtual machine, you create an image template, right? You create a template that the OS image itself. So when you take a snapshot of an operating system after you've installed, again, snapshot's not probably the right word, but it's more of an analogy, right? So if you create a virtual machine, you install, let's say, three, four, five different things on it, and then you take a snapshot, or you can create an image, right? And if you use the same image to deploy another VM, everything is going to be pre-configured, right? The way you have, right? So that is custom image. Now, custom image, the way to understand it is it's just a copy of a virtual machine, which might contain, which will definitely contain the operating system, any data files or any application. So let's dive into creating a custom image and creating a VM from a custom image. So you've got your VM run available, I hope, right? So let's do this. Let's turn that back on. What we'll do is we'll create an image from the same VM. We'll let it start. If you don't have a VM, go ahead, create one. If you have a VM and you've shut it down, restart it. If you have not shut it down, great. Keep it. Log into it. Once you log into it, I'd say go ahead and install any software you like. I probably to keep it easy, I'll just there is Edge already, so I'll install Chrome and I'll also what I'll also do is I'll start. I'm downloading Chrome, downloading and installing Chrome. What I'll also do is create a folder here, and inside that folder, I'll create a file also. Chrome's here, it's on my desktop with this, and I'll create not a folder, yeah, new text document. Hello world. Now, this in an enterprise scenario would be something like installing additional software, probably an antivirus, this, that, whatnot, right? So in our scenario, what I've done is I've installed Chrome and I have a test folder with a hello world text document on this, right? Now, what we're going to do, so creating an image is very simple, straightforward. All you need to do is on the VM overview page, click on capture. Okay. So that shows the create an image page. So you can share the image to Azure Compute Gallery. This is okay. So what it is going to do is publish this image for you, right? Target gallery, what we'll do is create a new Azure Compute Gallery. So what this means is you're creating an image gallery. So if you are an enterprise, you have multiple images, like an Ubuntu image, an RHEL image, a Windows Server image, or a SQL Server image, or a web server image, whatever it might be, right? You can create all of them. You can save all of them in a shared image gallery, right? I'll call this, well, not exactly, yeah, it is kind of a folder, but very specifically for images, right? So the advantages you get with image galleries is you can publish multiple versions of the image, right? So you'll have versioning enabled, and then you can pick and choose a specific version when you want, right? So we'll take a look at that as well. So click on image gallery. This is fine. Now operating system state. This is very specific, right? So there are two options to choose from. One is generalized and one is specialized. Now, specialized are in scenarios where you want to bring up the VM with the same username, password, host name, whatnot, right? But the best practice, I wouldn't say best, not to use that term, recommended practice is to typically generalize your image. So what that means is you get to choose when you're deploying a virtual machine with this image, you get to choose the host name, you get to choose the username, password, and everything, right? So use generalized. Okay. Make a note when you're capturing an image, your VM will not be usable, so which is okay. Now, what you need to create is an image definition, right? Click on create new. So I'll call this Windows image with Chrome. Give it any name that you want. That's absolutely fine. It doesn't matter. Okay. So image definition will talk about, oh, I've got trusted launch. I shouldn't have, but that's okay. So the publisher, offer, and SKU, right? Now, image definition is the one that will define how your images can be used, right? So you can publish metadata. If you are a third party who is publishing your own application image or your own product installed on this, right? So you can have a license term, link, a description, a release notes, right? And you also specify that what are your minimum specs, right? The recommended specs. You can define those, how many minimum CPUs you need, what is the VM memory, right? What are the excluded disk types, and when does this image go end of life, right? You can specify all of that, right? So publisher, I'll probably say test publisher. I'll not call this Windows, right? Offer is Windows, sorry, Windows Server with Chrome 19.10 or whatever, right? Q, up to you, right? So that is the image definition. Image definition basically describes a lot of metadata about the image. Okay. Now, version details. This is interesting, right? So version details will always follow a major minor patch kind of format, right? So 1.0.0 is, this is a first image. So you do that. If there is a patch version, you do a 1.0.1, right? If there is a minor version upgrade, let's say upgraded Chrome, you'll probably say 110, right? We'll start with 100 as 10.0.0 as default, right? You can create update the end of life date, whatnot, right? Now, this image gallery can have replication. So it means in the backend, it's still using a storage account and replicating images, right? So you can choose a default storage queue for your image gallery. I'm just choosing standard hard disk because it's cheaper, no other reason. Okay. Now you can have this deployed to multiple regions, right? Whichever region, if you're using two regions, you can publish your image to two specific regions. Okay. If you're creating zone redundant, you choose that option. Just LRS is also fine. Guess not. Okay. Go ahead, create your images. It's going to take a while to create the image. So what this process will do is create an image and save it in the image gallery. Azure Compute Gallery is created. Image definition is created. Image version is created. Then we'll get the image itself. Let's give it a couple of minutes. So whenever this is done, right, the easiest way to verify while we wait is, and the way we get to it is once you go to your resource group, you'll find your image gallery that is published, right? Azure Compute Gallery. So you can choose once you select it, you'll see the name of the image that we've created, right? So whenever this is done, the easiest way to verify is just select that version and just click on create a virtual machine, right? So what you'd notice is that the only thing that changes is the image here, right? So we are not choosing the default image that is available from Azure. You're picking up the image from your own image gallery, right? And once you spin up a VM, it is going to have Chrome and whatever you've installed, right? That's going to be available for you out of the box as soon as the VM is ready. So it's a straightforward hands-on. Once this is complete, you can test it out by creating a VM using the image and just validate. Oh, this is done. Creation succeeded. So I'll just create a quick VM. Oh, this whatever. Create a VM and check. Still creating, but the intent is it's straightforward. So once it's done, you can go ahead, validate, check if the Chrome or whatever things you've installed are already there, and that should be straightforward. Okay, right. So Backups, right? So backups on Azure are typically managed using a recovery services vault, right? Just like we have a custom image, we have a resource like web app. There is one resource on Azure which primarily manages the backups, and that is called a recovery services vault, right? Now, the reason, so for any backups, whether it's going to be backup of your SQL databases or backup of your VMs, right, you would be using a recovery services vault. That's the single resource to help us do any kind of backups, right? So recovery services vaults, again, the way they work, they're just like any other third party service that you might have, right? So in your organization, you might have seen things like Commvault or things. There are multiple other players, but natively within Azure, what you have is the recovery services vault, right? This in short, is it recovery service vault, right? In short, these are just called vaults, right? So anyone who talks about recovery vaults or RSV or recovery service vaults, this is where the backups typically get stored, right? So this is what handles one, it handles the storage of your backups. Two, it can also handle the scheduling, right? So it's like a full-fledged PaaS service available to consume for backups, right? Now, as when we're talking about backups and we're talking about recovery services, the one important thing that backs this up is the storage account, right? So everything goes into a storage account, and depending on how you are backing up, depending on how you configure your retention. So retention is the other thing also that you can handle, right? What does retention mean? Is, let's say, based on certain compliances, you might say, there might be an ask saying the daily backup of a VM, or a database or whatever, daily backups need to be retained for 30 days. I'd say weekly backups, you need to retain for 1 year. Yearly backups you'd want to retain for 7 years, things like that, right? So these are retention policies. Retention policies typically are based on either the organization's requirements or based on a certain compliance standard, right? If you're in finance or healthcare, there are certain standards that mandate that you'd have to retain your backups for a certain period of time, right? So recovery services vaults uh, handle, so based on these compliance policies, these retentions, recovery services vaults push them into archive storage or cold storage. So it handles the backups for you, right? Uh, Also, there is always a storage account in the backend, right? So when we deploy a recovery services vault, we will also choose what type of storage account that we want, right? Whether we want a GRS, whether we want an RAGRS. Now, since these are backups, you would be safer going with a GRS or an RAGRS account, right? Because you'd want to ensure that your backups are not lost, right? There are multiple ways in which we can configure backups using recovery services vault, right? So uh, uh, most common types, there are two common types. One is a file system or file consistent and an app consistent, I believe. Yeah, app consistent. I'll take a look. I keep forgetting these. So an application consistent and a file system consistent backups. If there are other terms or newer terms, I'll let you know once we do a hands-on on this. But yes, point-in-time recoveries are possible, right? Typically, for virtual machines, backups are usually done on the OS disk only, right? This ensures that in case your upgrade fails or whatever, you still are able to get back into a last known good configuration, right? Data disks can also be backed up, right? But you would, if it's an application server or a web server or a middleware where mostly your data is consistent, you are okay. You can use, recovery services vault to back up your data disks. But if it is a database, never back up a data disk directly. You would rather want to back up the database separately, right? So you could use the SQL DB backups very specifically to back up your databases, right? So you could do a full backup and store them, and you can probably choose to ship your logs every 15 minutes, right? So it totally depends on how your policy is available or how your policy or whatever the compliance states. The recovery services vault is what we will use to create backups or take backups of anything, everything on Azure, right? It's a PaaS service. There are few limitations and as to what it can back up, we'll take a look at those, right? For a virtual machine specifically, we would use recovery services vault. It's a PaaS service. There is storage that it consumes in the backend. You can schedule your backups. You can schedule your retention periods, right? The combination of these two is something that is called a backup policy, right? So you can schedule it, the retention, etc. So you can create a backup policy and assign that to your virtual machines. You can do it on Azure files. You can do it on your SQL Server on VMs, right? So a lot of other options. We'll take a quick look at those as to what is possible to be backed up using an Azure VM. Where attacks are more around OS hardening and the way you've written code, or you would want to run an antivirus or a web application firewall, right? That's primarily inbound attack, right? That has got nothing to do with backups. Again, yes, if you are attacked, you might want to restore, but then you never do that immediately, right? We'll be digressing into a security aspect, but there are forensics that needs to be done the moment there is a ransomware attack and your machines are down, or your service is down, and you are held hostage saying, hey, I'm going to get rid of your data or whatever. So even before trying to restore a service, what's more important is to manage the situation, right? So when we talk about security or get these kind of cyber attacks, that's totally a tangent. But of course, you will have an ability to go ahead and restore your VMs and your service if you want to. Uh, but then remember, if you're in a ransomware attack, something's been encrypted or being deleted, your logs might not also get shipped, right? So it's tricky, right? It's a case on case basis on how you'd want to handle it. Yes, you can restore your service, but that does not mean that the service that you restored will still work, because in a ransomware attack, someone's already on your network. They might even stop backups, right? They might even not let you log on to your VMs or once they are in the network, right? So there's nothing much you can do about it. And rule of thumb: never shut down a VM if there is a ransomware attack, right? You never shut down a service. There's a different process altogether on how you'd handle it, uh, and that would be followed. If we create a recovery services vault, deleting it is a little tricky, right? Because Azure is careful, so that accidentally no one deletes it. I'll walk you through how to delete it, but for now, let's yes, we can delete. Yeah, backup policy is not for 30 days. I'm just saying backup policies can be written based on the ask, either coming from your organization or coming from a specific compliance standard, right? So daily backups. Now retention, is something that will again come from the policy, right? As an example, what I said is, let's say you're taking daily full backups at 3 a.m. every night or every morning, whatever. So of course you can't keep it forever, right? You'd be paying way more on storage. So what retention period means is that you will have the last 30 days of backup available. Same thing, if you're taking a weekly backup, you can store them again. As an example that I've given here is for 1 year. Yearly backups, you can keep them for 7 years. So this can be X days, this can be Y years or Y weeks, right? And this can be Z years, right? It doesn't matter. How long you retain these is what is the retention policy, right? So the retention as well as the scheduling together form the backup policy. Recovery services vaults have the ability to, you can use Azure Site Recovery, right? So you can use recovery services vaults and Azure Site Recovery specifically for DR scenarios across regions or whatever, right? Or on-prem to Azure from a DR perspective, you can definitely use those. Well, you're totally talking on-prem language, Sayed. Things are a lot different on the cloud, right? You can have a point-in-time snapshot. You can take image snapshots. You can take full VM backups for your OS disk, right? Recovery points are different, right? Recovery points, again, like I said, app consistent and crash consistent. I think, yeah, not file consistent. Crash consistent and app consistent. is what you have in terms of recoveries, right? So if there is any OS update or whatever, you can schedule to have an app consistent or a crash consistent recovery point. So yes, there are recovery points, right? But these don't work like typical SAN backup solutions. Yes, SAN backup solutions like EMC or Commvault or others can be used on Azure. I believe they have offerings, right? But what you back up here is very specifically the VHD or the state of the VM, the last known good state of a VM. Okay. So again, Azure Backup Service, we've already talked about all of these, right? So Azure gives you flexibility to configure and modify a VM backup. Again, all of these are tied to a backup policy, right? So you can schedule a backup, you can schedule a time and you can schedule the retention periods for which are together called a backup policy, right? So that's the same thing, just in English. You can keep the backup enabled as long as you want. That's basically the retention policy, right? They're connected to a storage account, and you primarily don't need to worry about managing the storage, right? Recovery Services Vault, while it uses storage in the backend, it's a PaaS service, so Azure manages the storage, and you don't have to worry about it, right? The way you get charged is basically for the storage that you use on the Recovery Services Vault. Okay. So what we'll do, again, this is a standard or a pretty simple process when you can create a VM uh, based on the backup. You can create a VM from that backup, or you can restore the disk and attach them to a newer VM, right, or an existing VM, or you can replace the existing disk, right? So these would make much more sense when we attempt to do the hands-on, right? So what you can do is you can restore the disk, or you can, when you restore the disk, you have an option to create a new VM out of the disk, just like we created, or when we saw in yesterday's hands-on where we could create a VM from an image, right? So this is also very similar. So you have two options. You can, using the snapshots or the backup, create a new VM, right? Once you restore the disks, what it will do is it will create those disks and you can see them in your resource groups. You can use that OS disk to go ahead and spin up a virtual machine. Alternatively, if you know which VM you are uh, restoring, you can replace the existing disk of the VM to bring it back up, right? So it totally depends on what the use case is. If you're trying to restore and you don't want to create a new virtual machine because probably your host name, your application's worried about the host name. In such kind of scenarios, you will not create a new virtual machine, but you would probably replace the disks. But if you just want the service up and running and you're behind the load balancer, it doesn't matter. In such kind of scenarios, you just create a new VM. Yeah, it will change the IP if you create a new VM, but that's the point, right? It depends on your system architecture. Is your application dependent on IP addresses? Bad code, right? It, of course, it's technical debt that you'd have to fix, but no application should depend on IP addresses. There should be no hard-coded IP address, right? You would, you might actually want to use FQDNs, right, instead of IP addresses. It's not that such kind of code does not exist in enterprises. Actually, it does, and it's a pain when you're migrating applications or when you're trying to restore services. So if you want things like OS disk encryption, etc., it's easier to handle that when you're doing it using code. OS disk, once you click on the disk, you'll see encryption in the settings, right? So for now, it is always it is used. It uses a platform managed key, but you can switch that to use your own key or your own agent. But you rather want to do it this way, right? So you create a disk encryption set, store it in the key vault, and that disk encryption set can come from your on-prem solution, right, as your master. You can also rotate them every 1 year, depends on the policy that you have. Okay, so the two ways we can create backups, right? The easier way, which is again not something that I would recommend, is to look at on the overview of your VM under operations, you'd see backup, right? So once you click on that, basically what it is doing is the same thing, right? It's attempting to create a recovery services vault and do the backup. So this is one way to do it. For now, we'll go ahead and do it this way. That's absolutely fine. Okay. The other way is you search for vaults or recovery services vaults. You can also, once you click on those, on that, when you click on create recovery services vault, you'll see a similar page, right? You create a vault name and in the vault properties, and then we go ahead and enable the VM backups, right? Now, typically that is how things will be done. For now, what we'll do is we just want to look at backups, right? We just want to create a backup of this VM. So under the overview page, scroll down to the operation section, click on backup. You can use the defaults. That's absolutely fine. One thing you can see is it's saying enhanced. The reason this is enhanced is I've created a VM with, I've created a trusted VM, right? And that's why it's not showing me the option to enable standard, right? Now, the backup policy, right? We talked about the backup policy. So if you click on edit this policy, it's going to open up a window and you'd see what the schedule is, right? So what is happening here is the frequency is hourly, starts at 8, runs every 4 hours, right? And it takes a backup on this schedule and it retains the instant recovery snapshots for 7 days, right? The retention for daily backup point, which you are defining here in this schedule, is, you can choose these. So you can say retention of backup points for daily backup point is for 30 days, a weekly backup point for X number of weeks, monthly backup point, you can do a week based, day based. Again, this is self-explanatory, right? Basically, what you're choosing is how long you want to retain the backups for. We're not changing anything. I'm just trying to show you where this is. We'll do an initial backup, so it doesn't matter what the frequency is. You wouldn't want to do hourly backups. I mean, daily is best. Daily at what time? Weekly, if you choose, then it'll ask you which day of the week, what time. If you do an hourly backup, it'll ask you what time do you want to start and how many hours do you want to keep it running, right? So if you say 12 hours and every 4 hours, you'll probably get 3 backups. Okay. So I'll just leave this as is, not make any changes. No, temporary disk is never backed up. There's a disclaimer on that, right? There's no backups on temporary. Okay. So I'll leave this as is. I'm not making any changes to the backup policy. So it'll show you here what you have defined, right? The backup frequency is every 4 hours, starting 8 a.m. for 12 hours, instant restore, instant recovery snapshot are retained for the last 7 days. The daily backups are retained for 30 days. Okay. So once this is done, there's nothing much, just click on enable backup. What this is going to do is actually create a recovery services vault. It will create a backup policy and it'll assign the VM, it'll assign the backup policy to the VM, and that's what happens in the backend, right? So if you see, it's deployed a recovery services vault, it's created a policy, and it's created a backup item. So you can click on the vault, it'll take you there. And on the left, so we'll wait for it to deploy and then I'll show you what's happening. Okay. What is this consisting point? What point in edit policy? We'll take a look. Give me a second. Let's go to the vault. Let's look at the backup policy. Yeah, so standard is grayed out. It's visible on your end, then it's fine. You can choose that. For trusted VMs, there would be no green checkbox, right? It shows you everything. There will be a green checkbox on the left which says what is available on standard versus what is available on premium tier. Okay, so once you've deployed, click on your vault, right? On the left, scroll down to protected items section and click on the backup items. You will see a list of all backup types with one showing up beside Azure Virtual Machine. So you can click on Azure Virtual Machine and you will see your virtual machine, which resource group it is in, right? And the backup recheck has passed and it will say that the initial backup is pending. Okay. So you can click on view details. That's going to show you the system types. So crash consistent, application consistent, file system consistent. That's the third one, right? I think I mentioned only crash and app, right? So the type of backups taken is what Vault will decide, right? So what we'll do is initiate or do an initial backup, the first backup. So it shows that the initial backup is pending, right? So unless you do the initial backup, it's not going to kick off the policy. So we need one backup. What we'll do is trigger this manually. So you can click on backup now on top. Since you are initiating this backup yourself, it's going to ask you for a retention date. I'm just leaving it as default. This date will, the initial backup will only be stored or retained until this date, right? Since you are triggering this manually and it is not part of the backup policy, it will ask you this question. So you can see if it's triggered, right? You can, on the overview page, scroll down and under monitoring, you can see backup jobs. I tried to trigger it again, that's why it failed, but there is a backup that's in progress. Okay, so we'll let this run and we'll come back and attempt to restore the backup after it's done. I don't want us to wait and keep watching at the portal for no reason. Okay. The other option that's available, as we talked about, right? So on the recovery services, okay, what happened? Yeah. So when you're on the vault, right? So you'll see an option which is called site recovery. Okay. So if you click on that, what you can see, so this is primarily called Azure Site Recovery. Now you can prepare or you can use Azure as your disaster recovery site for your physical or virtual servers on-prem, right? So what you can do is enable replication if it is Azure virtual machines. It's pretty easy and straightforward. And you can use site recovery to replicate your VMs into another region. And even the cutover is kind of automated, right? So you can enable replication and you can manage your recovery plans. So for Azure VMs, it's very easier and straightforward. The second option is for your VMware machines on Azure, VMware machines to Azure. So you can leverage, all you need to do is at the VMware level, you'd install an agent and that's going to, and you choose which ones, which VMs to replicate, right? So that is all part of the prepare infrastructure phase. If you want to explore that, you can click on the link and it'll give you the instructions. So primarily it's going to give you a VHD, which you can go ahead and deploy, right? That is what you do in preparing the infrastructure. It gives you an OVA file. If you know VMware, you know this is going to be an image. You can go ahead and set up the create an image or create a VM on VMware. And once you log in, you would need to register with a key, right? So what this key does is it'll make sure that using that appliance, you're able to talk to your recovery services vault. And after that, things will show up here. Your VMs will show up here. Once you select your source, you can choose which VMs you want to replicate for your DR scenarios, right? There's also an option for your Hyper-V machines. So you can start replicating those as well. So you get a similar thing for Hyper-V. You need to ensure bandwidth, whatnot, and this is going to still give you an agent to configure. If you have a single instance to move to the cloud, then you use the physical server option. So you'd have to install an agent and then start enabling replication, right? So a single VM, you still can move by installing the agent, uh, and that's going to replicate, right? So typically, again, as the name itself suggests, this is primarily a site recovery operation, right? Or it's typically used for site recovery. Yes, there are people, I mean, earlier, uh, Azure Site Recovery was also used for migration scenarios, right? Because it replicates the VMs on Azure and you can do a cutover, etc. So such kind of migrations were called lift and shift migrations, right? Uh, Very specifically for virtual machines, right? Nowadays, it's all bundled into Azure Migrate. That's the service. But essentially, in the backend, it uses site recovery and replication. Okay. Let's look if our backup is complete. The backup. It's still running. I'll let it run. We'll keep moving on. Ah, it's complete. Taken a snapshot. Now it's transferring the data to the vault. Snapshots. Yes, it's taken. We can check what kind of snapshot it is by going into backup items, clicking on the virtual machine. Last backup status failed. Yeah, it's an application consistent snapshot that we have, right? So here there are two options. You can, using this snapshot, you can restore the VM or you can restore the files, right? So if you click on restore VM, it'll ask you to choose a snapshot, right? We can choose the existing snapshot. And this is what we were talking about. The restore configuration, you can choose to create a new disk or you can replace the existing disk, right? So if you choose create new, it's going to create new disk or it can create a new VM for you, whichever works for you. You can either restore disks or you can create a new virtual machine. If you choose to restore disks, you create a virtual machine yourself that gives you more control. Alternatively, you can choose to create a new VM entirely, right? You can give this a name. And one thing to understand is you need a staging location, right? So what does a staging location mean? Just as the name suggests, you need a scratch space for Azure to copy or to fetch the files from the recovery services vault and place it somewhere so that it can do its operation, right? The rest of the things. So it will fetch the VHD from the vault, it will place it in a storage account somewhere, and that is what is the staging location. So once you provide it a staging location, the process continues where it picks up the VHD files from the staging location and creates a virtual machine for you. Okay. So let's go ahead and attempt to create that, right? We can create, I don't have a storage account. So storage account is deployed. So now let's attempt to restore. Select your restore point. When even if your backup is still happening, just go ahead and create a storage account. So the option I'm choosing right now is to create a new VM altogether. I'll call this backup VM in the same resource group. I'll choose the same network and the same subnet, and you can choose the staging location. And all we need to do is hit on restore. So what this operation is going to do is basically fetch the backup from the recovery services vault, right? It'll fetch the snapshot. It'll copy that snapshot as a VHD onto the staging storage account that we have provided. But if you want to use the same hostname and same IP, you choose the other option, the one which says restore disk. So it's going to restore the disk on the same VM. So you don't have to worry about changing the host name or IP. Now, if there is really a need of host name and IP, then I'd act or let the app team know that it's a technical debt they'd have to solve, right? Because ideally, applications should not depend on the host name of the VM or its IP address. It should rather depend on a DNS entry, right? An FQDN or a fully qualified domain name. Yes, I'm not saying some applications, I mean, you don't need it, but if they do need it, then you can just restore the disks instead of creating a new VM. Let's see, triggering restore. The restore is in progress. DNS based? No. So you're talking about, Anil, what you are talking about is the DNS entry for the server itself. What I am talking about is actually the DNS of, let's say you're running a web server. I'm talking about the DNS of your application. Yes, it will be pointed to the IP address of your server. But if you are using a CNAME or if you are using a load balancer, your application has got nothing, should not ideally have anything to do with your underlying infrastructure, right? You can run your app on one server or 10 servers, or your server might die. But if the application is really focused or Even if your DNS entries are very specifically on the server itself, it's really bad design from a system architecture perspective. Again, like I said, I don't want to digress there, but yeah, if there are things like that, they need to be sorted, right? If you're part of a app support team or a support team, you might want to tell the application folks to switch that design because. So we'll wait for this to finish. Um, Meanwhile, we can proceed and we can come back and take a 127 gigs. Let's take a look at the resource group. And there you go. The backup VM is ready. It has its own NIC, it has its own OS disk, right? So that's how you restore. Backup is in progress, that's fine, right? So whatever that might be. All right. So the next topic we have is app services, right? App services. So we've discussed about VMs in the compute area, right? So we've covered VMs in their entirety. We've played around with VMs. We've created, tested them. We've looked at scale sets. We've explored scale sets. We've created custom images. We've deployed VMs using custom images. We have looked at backups, right? Of course, backup of few of you still in progress, but we've backed up a VM, we've restored a VM, right? Now, all of this at scale uh, needs a lot of planning. However, these are the fundamentals. So we've explored Azure Virtual Machine. The second compute resource we're going to talk about is Azure App Services, PaaS. Yes, perfect. So this is a PaaS service, right? So how is this different? So primarily is you don't need to worry about creating a VM. You don't need to worry about installing Apache or Tomcat or IIS or whatever, right? And then putting in the code, deploying, configuring all of that. PaaS services, you can just choose the environment, choose the type of compute you need in terms of CPU and memory, and what you get is an endpoint, right? We'll see that in our hands-on, right? You can just upload your code and it's going to help run your web application, right? Now, these are primarily the way we call these app services. There are similar kind of services available for, right? If you want to sum these up, right? The first thing someone talked about availability, right? Scale, right? What comes with cloud is always scale and availability, no matter what service anyone's using. The first thing we talk about when it's cloud is high availability and global scale, right? There are multiple languages and frameworks, so you don't need to worry about setting things up, installing, I don't know, Node.js or Ruby on Rails or anything additional, right? Everything is taken care of when you initially choose your environment, right? Uh, you only pay for the compute time that is used. Again, this serverless is specifically for Azure functions, right? I wouldn't call this something for Azure app services, right? Paying only for compute time is for Azure functions, and that is specifically serverless, right? The other advantage is around DevOps optimization, right? So in this scenario, you don't need to worry about creating your infrastructure, maintaining your capacity, etc., right? It's all, since everything is in the backend managed by Azure, you can easily integrate this using any DevOps tool, set up any CI/CD environment. And the best part in app services is you are able to stage. You get multiple environments. You get to use a dev environment, a pre-prod kind of an environment, and a prod environment, all on the same app service, right? So you can stage your code. This makes life easy for SREs, right? SREs are site reliability engineers, right? It makes the life easy, and you can actually build an entire end-to-end deployment pipeline, actually an entire CI and a CD pipeline to go ahead and deploy your code, right? Application configuration is minimal, right? If anyone here has been part of SREs or DevOps, more often than not, you'd see issues with, the dependencies that you want to install, right? Be it SDKs, whatnot, right? All of that headache vanishes when you use an app service plan. And if you have written the application in a nicer way, that is. So App services, there are two things to understand. One, when we create an app, for an app service that we want to create, if you remember in the first hands-on, we created a static web app, right? So we'll create a web app, but what you need is an app service plan in the backend, right? So we create an app service plan. What this app service plan defines is the set of compute resources that are required. Now, this is important. So this is where when you create an app service plan, you choose, hey, how many cores I need, 2 vCPU or, probably 8 GB of memory, whatever, right? Again, you can also choose auto scaling based on application loads, whatever. Like I said, VM, the first thing that was built on Azure, right? From a compute perspective, there is VM scale set, which was built on top of the VMs, and PaaS services like app services are built on top of virtual machine scale sets. Right? So app services is one, Azure Kubernetes AKS is the other, right? And all of these are PaaS services, right? So the way PaaS services are built, so underlying is always an IaaS service, right? And under all of this, there is a physical layer. So this is the bottom up approach, right? Now, a SaaS service, we also discussed this in the intro, right? A SaaS service can be built either on IaaS or PaaS, it doesn't matter, but you get the gist, right? VMs and VM scale set are the foundational elements for a lot of PaaS services, right? So what we choose, when you create an app service plan, what we define is the set of compute resources, right? We look at the configurations in a bit in the next slide, right? Now, what this means is basically you're building a conventional server farm, right? This is what they call it, right? So you've got n number of web servers. This is typically how hosting companies run, right? So you can build an entire server farm and you can host your app one, app two, you can host multiple apps on this, okay? All running on the same hosting environment, which is your app service plan. Again, all of these will be same type of applications, right? Same technology stack. If it's .NET, you'll have one stack. If you have Linux, you'll have another stack, right? I wouldn't say Linux, but maybe PHP or something, right? So that's an analogy, but that is how typically an app service plan works. So you define your compute resources in the app service plan. Apart from that, what you also define, of course, the region, the number of instances. Remember, these two, why are they coming in? Because eventually in the backend, it is a VM scale set. That's why you're defining what is the minimum number of VMs that you want, right? How many instances you want to create. Of course, the size of the VMs that you'll choose, just like we chose yesterday when we were creating a scale set. And then there is a pricing tier. Now, this pricing tier for an app service plan defines a lot of things like, your staging environments that we talked about, right? So staging environments will only be available, I believe, starting basic premium or premium V2, right? So a free plan, you might not get staging or deployment slots, as they call it, right? So a deployment slot, you can have multiple deploy. We'll take a look at this in the hands-on. But in the deployment slot, you can have a dev slot, you can have a pre-prod slot, and you can have a prod slot, right? Based on environment. So you can always deploy your dev code. Your developer can do a lot of testing. Once everything is fine, you can just promote that, push that code onto pre-prod, test everything. If everything is okay, you can just move it to production, right? So this is how DevOps optimization is easier when it when you are consuming the Azure app services. Okay. So from an app service configuration, there are four things that we have. One, of course, the region. Two, the number of instances. Three, the size of the instances, and the pricing tier. All right. So staging, the deployment slots, right? So as I mentioned earlier, deployment slots are again, I believe, for a specific pricing tier, which starts from premium or basic premium. We'll take a look at that when we do the hands-on. So you can swap these tiers. So you can have multiple instances. Let's say you have a newer version of the application running, right? Let's say there's V1 that is running in production. So V2, you can test it in, let's say, a pre-prod environment, right? You can easily swap these. You can swap this to this or this to this. This makes it easier to promote your code. You can also do an auto swap. Uh, Traffic redirection is nothing is hindered, or everything is taken care of by the app service itself, by the PLAS service itself, right? You can also get back to your last known good site, etc. So you can have multiple deployment slots, which are basically multiple versions of your application running at the same time. Let's say in V1, uh, let's say, yeah, V1 was running, and then in V2 you added two additional pages, right? V3 you added three pages, added one additional page, right? So if you each of this is a deployment slot, you can configure them as a deployment slot. Again, what I'm giving you is an example. This is probably a very crude example, but quick use case or a simpler architecture diagram. Again, this is nothing fancy. Uh, Very straightforward, right? Don't worry about what Azure AD is doing here. Don't worry about Azure DNS for now. Let's assume traffic is coming in. You've hosted your website here. There's storage blob that you're using. This is for your static content, right? Your app is using a database in the backend. It's calling an Azure SQL database, right? A very straightforward architecture. What Azure Active Directory is doing here is actually providing authentication, right? If your website is probably a public facing website, then you wouldn't worry about Azure Active Directory. You might probably just have a username password screen for your user coming in, right? Azure DNS, again, if you are hosting your domain, or if you're hosting your public DNS on Azure, you can use Azure DNS. Alternatively, you could use something like Route 53, uh, right? Or any other DNS, GoDaddy DNS, what have you. Public DNS, there are multiple hosting providers for you, right? But this architecture is primarily for a cloud native Azure web app solution. So where it's saying, and that's why you have these dotted lines here, right? So you may or may not have these. It can be there, it need not be there. This can be there, this need not be there. But your web front end is hosted on a app service plan. The static content is hosted on a storage or a blob storage, and then you have your database. Now this is a PaaS version. Alternatively, you could probably just have a SQL Server VM, two VMs running on a always on availability group as an option, right? But this is a very basic architecture. So let's get our portals up. Again, search bar is your friend. What you would choose is type in app services. You will see app services here. Click on that. Under create, click on. Now there are multiple options, right? If someone wants to create WordPress on app service, you can go ahead and do that, or just choose a web app. I know we've created a static web app earlier, right? So folks who are comfortable with DevOps, or even if you are not, it's fine. Let's go ahead and create a web app. You want to try out WordPress, try it out whenever you're free during the rest of the week. Again, I wouldn't walk you through all these basics. Uh, Choosing a resource group name, choosing a instance name. So remember one thing, whenever you're trying to create anything on Azure, when you see this page, anything with a red star is mandatory, right? So please fill in those details. If you need input on anything, please let me know, right? So publish, you can run a code, you can publish the code, you can publish this using a Docker container, or you could do a static web app. So I'm just choosing code. Please choose code. What kind of app are we creating? It's up to you. If you have a hello world image or a hello world code, you can use that. Uh, Choose anything. It's absolutely fine. The code that I have, I believe it's PHP, so I'm just choosing PHP 8.2. Okay. For those who do not have a hello world code, or you're, You can explore what kind of versions are available, right? And what kind of environments are available. So choose any of the environment. It wouldn't matter if you're not deploying code. If you are deploying code, of course, you should know which runtime stack you need. Okay. I'm deploying this in central India. Yeah, simple HTML page is also fine. Now, if you look at this, be careful on the pricing plan. Okay. So there are multiple options that you see here. There's a free plan for folks who are cost conscious. Choose the free plan. I'm choosing a premium one primarily because I want to show you how the deployment slots look like. So the cost is also visible here. It says about 9,400 per month, whatever. I'm choosing the premium slot, premium pricing plan. You can choose free or basic. Uh, if you're not deploying code, I'd just say go ahead, choose free. That's absolutely fine, right? Zone redundancy, I'm not enabling it currently. Okay, so I'll leave it as is. Okay, so the deployment tab, what I want to do here, again, if you're comfortable with this, do it. If you are not, you might as well just go ahead, click on review plus create and create it. If DevOps makes sense to you, and if it makes sense to you, then you would understand what I'm trying to do here. And if everything is okay and your validation passes, go ahead, create your web app. Right? If you have not chosen to deploy any code, it's absolutely fine. You will still get a URL, and if you open it, you'll still get a web page. If you are deploying code, your website will open. If you're not deploying code, absolutely fine. No harm, no foul. What I want. Oops, sorry. GitHub. Okay, let's see. So what it does is actually trigger a, okay, it's already here. It's queued. So it triggers a pipeline, right? So what's actually happening is a build. Now that my web app is deployed. So since I have continuous integration, it's going to build. The build is successful. Now it's going ahead and attempting to deploy this. So these are pipelines, right? And I've already configured this to deploy into production. So it's using Git actions. So the moment I've created a web app, I've integrated it. So any code change I make, it'll follow the same pipeline. So in short, whatever has happened, build is CI, deploy, this is CD, right? They are now put together, and that's why you're seeing this happen. So we'll wait for it to complete. But for others, for whom, if you have deployed the web app, all you can just choose the URL. Once you click on go to resource, choose your default domain. It'll be XYZ, whatever is your name.azurewebsites.net. What I have done is primarily I've tied that to a GitHub project, right? So what my project is nothing fancy. It's pretty straightforward. All it has is a index.php page. It just says hello world. Nothing fancy. Okay. If you want, you can choose the same one. I can give you my GitHub link and you should be able to do it. I believe it's a public repository, but yeah, that's fine. If you have and if you've seen it, it's fine. If it's waiting for content, yeah, that's the intent, right? You should be okay. What I have done is I've used deployment center. So it shows successful on my last deployment. It's GitHub actions. All my website shows is hello world, right? It's Pretty straightforward. Now, one thing I'd like to show you here is on the left under deployment, you'd see deployment slots, right? Now, in deployment slots, you can see that there is currently just one slot and it is tagged as production, right? So this is where my production code is running and 100% of traffic is going to this. Now, what I can do is click on add a slot. This time I'll need to choose a different name. I'll call this test. Okay. I can clone the settings as is and then click on add. Now what this is going to do, now ideally someone asked for a branching, does this look similar to branching? So if you're aware of Git of DevOps, yes, you can have a different setting altogether and point it to a different branch. But all of these slots, you can test them directly on the same app service environment. Okay. So now I've created a new slot. This is the test slot. Now this will probably trigger another build. It hasn't yet. Yeah, no deployments found. I haven't created a deployment for it. Now let us say this was another version running, okay, in my deployment slots. Okay. Now one way, what you can do, the moment I click on swap, it will ask the source and the destination, right? So source and target. If you swap these, you can also choose to run different traffic percentages here, right? So this is purely from a DevOps perspective. We are trying to show you how it makes your lives easy. It is kind of like a blue-green deployment, yes, right? But otherwise, I would recommend, if you want to understand deployment slots better, if you read up a bit on DevOps, at least level 100, this would make much more sense. So you see also on the app service plan, you've got scale up, scale out. Okay. So here you can choose what types you want. Now these are for your app service plan itself, right? Cores memory. You can scale out also onto a different plan. Let's just check. Yeah, here you go. So you can, so this scale out actually is exactly similar to what we have done on the VM scale set, right? Now you can do a rule-based scale out, right? Rule-based scale out is very similar to what we've configured, CPU, memory, whatnot. You can choose automatic. Again, this is very new. It's in preview. Enterprises wouldn't use it, right? Again, you've got a limit, always ready instances, max burst. These will all make sense if you've understood VM scale sets properly, right? Again, please understand cloud, the number of services that keep coming on the cloud, as long as your fundamentals are clear, anything would make sense. Everything would make sense. Okay. So again, the way it makes life easy, app service plan, you wanted to set up a PHP application, simple, just configure it, point it to your source code, run your deployment, all good, right? That's how simple and straightforward an app service plan is. But yes, you can configure your own, you can bring in your own custom domain in here. Um, you can bring in your own certificate. You can add your certificates here, your public key certificate. You can bring in your own PFX files. You can use managed certificate. You can add them as well if you want. I don't have a custom domain, so that's fine. But yes, you can do a lot of good things here. There are quotas, if you are providing this as a service to your internal applications, you can, define the quotas, you can put in alerts. Waiting for content page. Okay. Either people have done it or you have not, and
Just a quick info, guys. Intellipaat offers Microsoft Azure course training and certification. Through this course, you will be able to prepare for AZ-104 Microsoft Azure Administrator exam and much more from the top industry experts.
With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of Microsoft Azure Cloud.
Now what we have in this video is a list of top 30 questions that will give you enough solid understanding of Azure to tackle real world interviews and feel more confident with the Azure Cloud. But before moving any further, if you want more such content, then make sure to hit the like button and subscribe to Intellipaat's YouTube channel. Now let's take a look at our agenda for the day. We'll start with the basic Azure questions, including the comparison to AWS and GCP. Then we will cover service-specific topics like BLOB and table storage, virtual machines, app services, auto-scaling, traffic manager, and database services. And that's all from my side. And now I'll let one of our Azure professional take it from here.
First, let's look into what is Azure Cloud Service. So, what is Azure Cloud Service? Microsoft Azure is an ever-expanding set of cloud services to help your organization meet your business challenges. Azure offers services on a pay-as-you-go pricing model in computing, web services, data storage, analytics, etc. etc. So there are so many different domains in which Azure is providing services. So to be very simple, Azure is a cloud provider, a public cloud provider, as well as you can get private cloud services and hybrid cloud services from them. So first of all, Azure is Microsoft owned. Azure is a cloud provider. So after AWS, Azure is the most popular cloud service in the world. So when an interview asks this, you can be basic as well as advanced. I would suggest you just give the apt answer what exactly it is. Microsoft Azure is a cloud service which provides you various different services in various domains like computing, web services, data storage, and you can access those services via an internet device. So you can access them through a laptop or a desktop or your mobile device, anything with an internet connectivity, you will be able to access Microsoft Azure. Okay, so we've seen what is Azure Cloud Service. Okay guys, now let's look into the second question, which is how does Azure compare with AWS? So first of all, AWS owns 32.3% of the market share in the public cloud industry, but Azure owns only 16.2%, which is just half of what AWS owns. But Azure is currently the fastest growing cloud network, and also it has 54 different regions in which it has availability zones, but AWS has 69 availability zones across only 24 regions. So regions in the sense are geographically located regions. For example, Azure has regions like South India, North India, East US, West US, Central US, Europe, Central Europe. So there are so many different regions like that. So like that, there are 24 different regions, but within those regions, AWS has 69 availability zones. But Azure has 54 regions. In 54 regions, it has 54 availability zones, and it's currently growing. So this basically shows Azure is better in availability zones, that is data centers, because it has a wide range of data centers in various regions. Next, comparing the services, if you already know about cloud, AWS and Azure, then this would be easy. EC2, S3, RDS are AWS services. The same exact service, EC2 is equal to virtual machine, Azure virtual machines. S3 is equal to storage, blob storage. RDS is equal to SQL databases in Azure. So EC2 is used to launch and create servers, same as VM does. And then S3 and blob storage are for storing objects. RDS and SQL databases can create relational databases running on the cloud. So you can distinguish between different services. And then finally, the pay per hour model and pay per minute model. So this is one of the important difference you'll have to note down. Because AWS does not have a pay per minute model yet, it charges you for the hour which you used, but Azure will charge you only for the minute. For example, if you're running a service, let's say you're running the same server, Linux server in AWS and Azure for 5 minutes, in AWS you will be charged the hour. For example, if the hour charged in both AWS and Azure is $5, so it would be $5 For 60 minutes, if it's $5, so you will be charged for the whole $5 in AWS, but in Azure that would be not the same because you will be charged per minute. So if it is $5 for the hour, that is 60 minutes, so that will be reduced to 1 minute, so that would be multiplied into 5. So you will be charged very less in Azure compared to AWS if you are using services for a very less period of time. So if you're using some service for 2 to 10-15 minutes, then go with Azure because that will not charge you as much as AWS. Okay, so we've seen the second question. So I think you can coagulate into an answer and give it. I'm just explaining you the differences, but you'll have to provide it more of a answer.
Okay guys, a quick info. Intellipaat provides an end-to-end training course on Microsoft Azure, and if you want to take it up, you can check those details in the description. Now let's continue with the session.
And then comes the roles implemented in Microsoft Azure. So there are three main roles: the web role, the worker role, and the virtual machine role. First, the web role. This gives a web solution, that is the front end. This is like an ASP.NET application, while under facilitating, Azure provides IaaS, which is basically a web server, and required services. So web role provides a web solution. Basically, it's a front end. It can be a website's front end. The worker role is a solution for background service. It can run long activities. For example, if you have a log activity, if you want to monitor the log activity, you can use a worker role. And then finally, a virtual machine role. So this can act both as a web and a worker role, and this is executed by virtual machines. The virtual machine role gives the client the capacity to modify the virtual machine on which the web and worker roles are running. So for example, web role only contradicts to the website, the front end. Worker role only contradicts to the business logic, which is the background or the back end part. So in virtual machines, you can run both a web role and a worker role, which means you can have a website running as well as a background process running. So these are the three main roles which are implemented in Microsoft Azure. So I think you get the point of this. So basically in Azure, mostly it is used to launch applications. So for an application, obviously there will be a web role, which would be the application itself hosted, and then the worker role, which is background processes. For example, if a person wants to retrieve an image from the website, so they'll enter the information, click a button, and a background code will run. So that code would be your worker role, and these both can be run on a virtual machine, which makes it a virtual machine role. So these are the three most basic roles. And the next question is, so this might be a question which may be asked, but this does not have a certain answer. I'm just giving you the three most popular and commonly used services. So talk about the three principal segments of Microsoft Azure platform. Okay, so first of all, compute and storage comes by default because they are the most used. Compute services and storage services are the most used services in any cloud platform, and then you can choose one as per your need. For example, you can choose databases, or you can choose monitoring, managing, governance. You can choose anything. So here I've chosen databases. For example, you can tell the answer like this. So the principal segments of Microsoft Azure platform it can be basically anything, but here the most commonly used services comes under the compute and storage platform. And I also would say databases, because every single application needs a compute, needs storage, and also database. So for example, in compute there is virtual machines, app services, and function apps, which can be used to develop an application and also host that application with the backend code. And then there is Microsoft Azure storage, where we have blob storage, table storage, where we have file storage, we have Azure queues. So we can use all of them to store objects. We can use them to store images, videos, audio files. We can use them to store NoSQL data. And finally comes databases, where we can store, record, or structure information. And also there is a Cosmos DB, which is for NoSQL. And also if your application needs a analytical database, we have SQL data warehouses for that purpose too. So compute, storage, and databases, I would say they are the three principal segments of Microsoft Azure platform, because they provide so many different services. Pretty sure even Azure uses them for their own benefit. Okay, so this is the fourth question. So we have seen 4 questions up till now. So the fifth question is, what is the distinction between Azure queues and Azure Service Bus queues? Okay, first of all, storage queues and service bus queues are different. So first, what are storage queues? Storage queues featuring a simple REST-based get, put, peak interface, providing reliable, persistent messaging system within and between services. Service bus queues are part of a broader Azure messaging infrastructure that supports queuing as well as publish or subscribe and more advanced integration patterns. Okay, so the simplest thing you'll have to know is, if your application needs to store more than 80 GB of messages, go with storage queues. But if it needs only lesser than that and it won't exceed 80 GB, you can go with a service bus queue. So the thing is, storage queues are mainly used to move messages between services or to an end user. So you can see it is a REST based get, put, peak interface. Basically, you can get a message from it, you can upload or send a message through it. And in service bus you can do the same, but also you can integrate advanced patterns. For example, you can integrate a queuing system which basically filters multiple messages according to their priority, and that does not come with storage queues. Also, storage queues are very easy to use. You can use it between services, you can create a queue within minutes. Service bus has a broader usage in Azure itself. So these are the main 2 differences, that if you want to use an application for your own personal use, go with storage queues. If it is a bigger application which needs shorter message storing, go with service bus queues. So the main distinction between them is, storage queues are simple, REST based get, put, peak interface, but service bus queues is involved with the Azure messaging infrastructure itself, and this supports queuing as well as normal publish and subscribe, which comes with storage queues as well. Also, you can integrate advanced integration patterns, but which cannot be done in storage queues, where you can filter different messages according to their priority and various other features and factors. Okay, so the next question is, what is table storage in Microsoft Azure? So Azure Table Storage Service stores a lot of organized information. Azure tables are perfect for putting away organized non-relational data. It is a NoSQL data store which acknowledges verified calls from inside and outside the Azure cloud. So basically, table storage is a NoSQL data store where you can store non-relational data. That's basically NoSQL, non-relational database. Okay, so now what exactly is table storage? First, let's look into what exactly it is. First of all, a table is a collection of entities. A record can contain numerous tables. Basically, when you create a table, you can have multiple tables or a single table, and it is a collection of entities. So what are entities? Entities is an arrangement of properties like a database row. An entity can be up to 1 MB in size. So basically, an entity is an item within the table. For example, if it is a table for shoes, and inside that every single shoe name would be a entity. Next comes properties. A property is a name value pair. Every entity can incorporate up to 252 properties to store data. For example, let's say in entity we have 3 different shoe types. One is Adidas, one is Reebok, one is Nike, and inside Adidas you can have 252 properties like color, type, shoe model number, and so many different properties under that entity which defines that particular entity. So inside a table there can be any number of entities, and inside those entities there can be 252 different types of properties to store data. So that's what Azure Table Storage is used for. It is a service used to store a lot of organized information in which you can store non-relational data. It is a NoSQL data store which acknowledges verified calls from inside and outside the Azure cloud. That is, you can integrate it with Azure services inside the cloud as well as third-party services from outside the cloud. And table is a collection of entities. Entities is basically the main item inside a table, and properties are the basically a property explains what an entity is, and the entities completely explain what a table is. So that's it. That is what table storage is.
Okay guys, a quick info. Intellipaat provides an end-to-end training course on Microsoft Azure, and if you want to take it up, you can check those details in the description. Now let's continue with the session.
The next question is, what is auto-scaling in Azure? So, what is auto-scaling in Azure? Scaling by including extra instances is frequently referred to as scaling out. So, this is a commonly used term which is called scaling out. So, Azure likewise supports scaling up by utilizing bigger role rather than more role instances. An auto-scaling solution reduces the amount of manual work engaged in dynamically scaling an application. So this is pretty simple, guys. So let's say you have a virtual machine which has let's say it has a website running on it. Now there are a lot of users using it right now, but that one particular virtual machine is able to handle them. So let's say there are 20 users. Now right now this particular virtual machine is able to handle all the 20 users and the website is not crashing. But suddenly your website has gone viral and there are 200 users. Now your virtual machine will not be able to handle because there are more users and the CPU utilization will go high, the traffic, the overload of your server will go high. Because of that, the usage also will increase and then your website might crash. So what you'll have to do, you'll have to again start up a virtual machine or another server. Once you have done that, you will have to configure your website and make it run again. So this will take some time. Until then, you would have lost a lot of users. So instead, you can start off with using auto scaling. So for example, you can see the image in the right corner below, in which to the left there are two virtual machines which is written as minimum 2. That basically means let's say you have a website and right now your website has two virtual machines and that is the minimum number of virtual machines and it will never go below that. Even a virtual machine is let's say even a virtual machine has been terminated accidentally, it will launch one more virtual machine within a span of a minute and that will be ready for your website. So now to the right side, you can see virtual machines as needed and maximum is equal to 5. So the maximum number of virtual machines you will get is 5. The minimum number of virtual machines running will be 2. And there you can add or subtract 3 virtual machines. For example, if you have 2 virtual machines right now, you can add 3 more or 2 more or 1 more, or you don't need to add at all. But you cannot go below number 2 or you cannot go above number 5. You can use auto scaling solution to do this. For example, right now you have 2 virtual machines and the work overload goes very high. So right now you want 1 virtual machine, so it will launch 1 virtual machine. Now it will monitor all of the 3 virtual machines. Again, if the user count is completely increasing, it will launch 1 more, and again if the users are increasing, the traffic is overloading, then again it will launch 1 more virtual machine. So here the maximum is number 5, so it will launch up to 5 virtual machines. After that, even though the user base is increasing, it won't go above that. You'll have to change that in the configuration. For example, max is equal to 10, so it can launch up to 10 different virtual machines. Okay, so got it? So I think you understood what exactly auto scaling is. So you can explain it simply. For example, you can tell auto scaling solution reduces the manual work engaged in dynamically scaling an application. Instead, we can set up an auto scaling solution in Azure where it gives you the number of required instances, as such as whenever the traffic increases, it will give you more instances. When the traffic decreases, it will reduce the number of resources being used, which is also cost optimized, and this will reduce your billing cost. So now let's look into the next question, which would be, what are the features of Microsoft Azure? So what are the features of Microsoft Azure? So there are so many different features. So let's just look into 3 features. So first, Azure App Services enables designers to assemble the sites utilizing various different programming languages. You can use ASP.NET, PHP, you can use Java, Python, and send these websites utilizing FTP or Git. Basically, you can use GitHub to have this code and you can integrate it with Azure App Services so that Azure itself will launch your website for you. It will maintain your website for you. You just have to work on your code. Next comes SQL databases, formerly known as Azure Database, broadens and scales the application into the cloud utilizing Microsoft SQL Server. So in SQL databases provided by Azure, you don't need to scale out anything. For example, if you have set up a maximum size, whenever the size of the database increases, it will automatically scale the storage, and also you can manually scale the compute. And finally, this is Microsoft's platform as a service that supports multi-level applications and automated deployment. That is, Azure is Microsoft's platform as a service because they are giving you a platform to work on various different services. Even though services like virtual machines are infrastructure as a service, it comes under IaaS, but Microsoft Azure as a whole is a platform as a service because they are giving you a platform which you can work on different cloud services. So these are some features about Microsoft Azure. You can talk about them. So next question is, what are the difference between a public cloud and a private cloud? This is one of the most basic questions. You can easily answer them. So look at the image at the top. So first of all, public cloud, elasticity, utility pricing, leverage, expertise. And then private cloud, total control, regulation, flexibility. So let's compare this. First of all, elasticity, that is, you can launch any number of services. It can go up, it can go down. You can have any number of users. You can provide the access to users. You can cut off the access whenever you want. So it's more elastic. And then coming to right, it's total control. You can mention the administrator and only they will have control over the private cloud. So this basically increases security in private cloud, but public cloud is widely used. And also you can see leverage expertise. That means if you're using Microsoft Azure as a public cloud, then you will be able to leverage expertise because they have so many different security professionals working for Microsoft, and they will be guarding your virtual machines because you have taken a virtual machine from Azure itself. And coming to private cloud, you'll have to maintain, monitor all of that. And then comes utility pricing and regulation. So utility pricing in the sense you only pay for what you use. In private cloud, you will pay for everything you have taken up. And also regulation in the sense you can stop someone to access something. You can stop a service overall. You don't need to use a service. So in private cloud, you have the whole control. In public cloud, you have partial control. Okay, so now let's look into the most basics of them. A public cloud is utilized as a service through the internet by users, so anyone can use it, while a private cloud is deployed within specific limits like firewall settings and is totally overseen and checked by users dealing with it in an organization. So a public cloud is used for launching applications for public use, that is end user use. Private cloud is mostly used for deploying applications within a specified limit. For example, within an organization, you can launch applications. So you can do that using private cloud. So this is the basic differences between public and private cloud. So the next question would be hybrid cloud. What do you comprehend about hybrid cloud? So basically a company can use both public and private cloud. So a combination of them is a hybrid cloud. So hybrid cloud is a blend of internal and external cloud services. So internal in the sense within the organization, external in the sense for users. A mix of private cloud joined with the utilization of public cloud services. This kind of cloud is most appropriate when you need to keep the classified information at your vicinity, private cloud, and consume alternate services from a public cloud. For example, if you have mission critical data, you can store that in the private cloud, and the application itself can be running on the public cloud because the application does not have any important information, and even though there is a security breach, there can be nothing taken from that, but your mission critical data and code is stored in a private cloud which only you can access. So this is hybrid cloud. And the next question is, what is a storage key? So your storage key access keys are similar to a root password for your storage account. Always be careful to protect your access keys. Use Azure Key Vault to manage and rotate your keys securely. You can view and copy your account access keys with the Azure portal, PowerShell, or Azure CLI. The Azure portal also provides a connection string for your storage account that you can copy. For example, if you're logging into your storage account in Azure portal, it's pretty simple to log in. You can just enter as such. But if you're trying to access your storage account from PowerShell or Azure CLI, you will have to use your storage keys. So it's basically an entry point for your storage account. So you can use that. Also, Azure portal provides a connection string for your storage account that you can copy and use it in your Azure CLI or PowerShell. So to be simple, it is similar to a root password for your storage account, and it is a key which you can use to log in into your storage account to check out the storage containers like blob storage, table storage within the storage account itself. So it's pretty simple, storage account. And then comes what is Microsoft Azure Traffic Manager. So it enables users to control the distribution of user traffic of installed Azure cloud services. There are 3 distinctive load balancing strategies provided by Azure. The manager who uses on traffic applies a routing policy to the domain name servers, questions on your domain names, and maps the DNS courses to the apt instances of your application. So let me explain to you in simple words. So first of all, Azure Traffic Manager is a DNS based traffic load balancer that enables you to distribute traffic optimally to services across global Azure regions while providing high availability and responsiveness. So basically, Traffic Manager uses a DNS to direct client requests to the most appropriate endpoint on traffic routing method. So basically, let me explain to you this. So let's say you are trying to access a website using a website's URL name. Now when you type that, your first point of entry would be the Traffic Manager. So once you hit that, the Traffic Manager will use DNS and it will check to which IP address should this particular URL name is should be redirected. So when it finds that, it will redirect the client request to the most appropriate service. For example, in Intellipaat.com, we have Intellipaat.com, which is the main page, and Intellipaat.com/blog. So for example, I'm searching for Intellipaat.com/blog. Now this will go to the Traffic Manager. Once it hits the Traffic Manager, it will check out the IP address for this particular URL. Once it gets the IP addresses, it will transfer me to the blog page, not the main Intellipaat.com page. So that's what Traffic Manager does, and it's pretty simple to use it. So you can start off with Traffic Manager even now. So you can combine Traffic Manager with auto scaling so that it is better to use. So if you're using Traffic Manager with auto scaling, basically what you do, you will be able to launch and terminate multiple virtual machines, as well as you'll be able to launch multiple applications in different virtual machines and connect two auto scaling groups together, in which the Traffic Manager is the first entry point. And for example, in one auto scaling group there is app 1, in another auto scaling group there is app 2. So now it hits the Traffic Manager. If you're trying to access app 2, it will take you to app 2. If you're trying to access app 1, it will take you to the app 1 auto scaling group. So this is how you can use Traffic Manager. The next question is, what is Microsoft Azure Portal? This is again a basic question. So Microsoft Azure Portal is the website which you are logging into when you're using Azure. So view and manage all of your applications in one unified hub. You can view your web applications, your databases, your virtual machines, your network, storage, and VHD projects. Now it is easy to keep tabs on current and projected costs. So Microsoft Azure is not just for managing all your applications and services. It can also be used to manage your current and projected billing costs. So Azure Portal automatically calculates your existing charges, as well as it will forecast your future or monthly charge, even if you're managing hundreds of resources across several applications. For example, if you're using only one service, still it will give you the billed amount for right now and also the projected bill. If you're also using hundreds of services, again it will do the same thing for you regardless of the scale. So Microsoft Azure Portal is the website which you're using to access Microsoft Azure services. That is more than enough. If you want to tell more, you can tell it's a unified hub to manage all the Azure services. It also provides cost management services. You can say it has a different web page for every single service. You can access every single service directly from the portal itself, and also manage, monitor, and do everything else through Azure Portal itself. And also you can access Azure Portal from any internet connected device. Okay, so we've seen that. The next question is, what is Elastic Pool in SQL Azure? So we already saw what exactly is an SQL database. So now Azure SQL Database Elastic Pools are a simple, cost-effective solution for managing and scaling multiple databases that have varying and unpredictable usage demands. Databases in an Elastic Pool are on a single server and share a set of resources at a set price. Okay, let me make it simple for you. So right now you want various databases for different applications, and all these databases need to have a different set of specifications. Now what you can do is you can launch an elastic pool, which is basically a single server with different sets of resources within it. You can launch multiple databases and you can specify the required set of resources for a particular database within the elastic pool itself. You can launch any number of databases within that server and how much that server can handle, and all of the databases is shared, will use shared resources, and the price for that will be the same even though you're using any number of databases. So let's say you can have 10 databases within that elastic pool, or you can have 5 databases, or you can have only one database, but you'll be charged the same because you are sharing the same number of resources across all the databases. So this is elastic pool.
Okay guys, a quick info. Intellipaat provides an end-to-end training course on Microsoft Azure, and if you want to take it up, you can check those details in the description. Now let's continue with the session.
Next is, what is Azure SQL database? So an SQL database is just an approach to get associated with cloud services where you can store your database into the cloud. If you already know about SQL databases, for example, MySQL, PostgreSQL or MS SQL database, you will understand this easily because it is basically the same relational database on your local system hosted on a cloud system and given remote access to you. So you can tell it pretty simply, SQL Azure database is a database server running in the Azure data center and to which you are given remote access to so that you can access that SQL database. Microsoft SQL Azure has a similar component of SQL Server, that is, it provides high accessibility, versatility and security in the core. Microsoft Azure SQL database has an element, it makes backups of each active database automatically. So this feature does not come with a local database because it does not take backup. It has only one storage where the data is actually stored, and if that is lost, your data is lost. But in Microsoft Azure SQL databases, it's not the case. You can enable automatic database backups. So if your database is active and new data is coming in, it will automatically back it up. So even though your database has been terminated, you can use the backup to launch a database with the same existing data set. So this is Azure SQL databases. Now let's look into the next question, which is, what are the different types of storage areas in Microsoft Azure? So there is blobs, there is table storage, there is queues, and there are still more, but you can talk about 3 maximum. So there is also file storage, which is basically a shared access file storage. So you can also talk about that if you want. But right now we'll be looking into blob, table and queues. So queues we already looked into. Now we'll just look into blobs and tables. Even table storage was a separate question, so you can also answer that. So first of all, what is blob? So blob is the most commonly used storage type in Azure. So the full form of blob would be binary large objects. So you can see that BLOB, which is basically binary large objects, blobs. So blobs are a component for storing a lot of content or binary data. You can store pictures, audio, visual documents, you can store video, you can store any type of data. They can scale up to 200 terabytes and can be acquired by utilizing REST APIs. Very simple to start off with blob storage. You can create a storage account and create a blob container in which you can upload images, videos, documents, anything you want. You can store any type of binary data within blob storage. So that is one of the main area in Microsoft Azure. Next comes table storage, which is a non-relational data store where you can store organized information, and also you can store them using a format which is table, entity, and within entity you can have properties. So that we saw. Next is queue. The sole target of a queue is to empower communication among the web and worker role instances. They help in storing messages that may be accessed by a customer. So as told, queues can be used to connect multiple services as well as services with the end user. So these are the 3 main storage areas. One more is a file storage, which is basically a shared storage access which you can use to connect the same storage to multiple virtual machines. So every single user in every single virtual machine will be able to access the same data store, which will save you a lot of storage as well as cost. Next question is, what is the concept of blob storage? I explained to you what exactly is blob. So let me just go into that more. So blob, as told again, it is binary large objects and includes text files, images, audios, and videos. Azure Blob is a service that stores massive unstructured data that can be accessed from any place via protocols like HTTP or HTTPS. So how does this work? How can you access these objects using HTTP or HTTPS? So it's pretty simple. Whenever you upload an object like image or audio into the blob storage, it will have a URL. So it will be provided a URL and you can use that URL to access that particular object. For example, if I'm uploading an image, that image will have a URL for that image itself. Now you can use that URL to access that particular image. So how will you access that? Using protocols like HTTP or HTTPS. So now what else you can use Azure Blobs for? Storing data for disaster recovery, backup and archiving, also storing files for shared access. Shared access in the sense, if you upload an object and you have a link for it, you can share that link with multiple users so that they all can use that particular blob storage as a shared storage. So that can happen. Also, you can use it for disaster recovery. That is, you can store data in different regions in blob storage itself and use it for backup and then also archiving data. So this is blob storage. Now let's look into the next question. So now this question is, what is Azure DevOps in Microsoft Azure? So if you are already familiar with DevOps methodologies, then this would be easier to understand. If you're not, I'll explain to you what exactly is DevOps in a few sentences. So first of all, DevOps is not a tool. It is a methodology which companies follow and implement in their software development lifecycle to automate the entire lifecycle. So Azure DevOps is not a methodology, it is a service. You may be confused by the name, but DevOps is the methodology, but Azure DevOps is a DevOps service provided by Azure and it is developed by the Microsoft team. It was previously called as VSTS or Visual Studio Team Services. Azure DevOps provides easy automation by having predefined build options for the deployment of applications. For example, if you're trying to launch an Angular application, it already has build options for it. It has npm packages in build. You can have a build. You can basically create a build in a matter of minutes. For example, if you're also launching a Java application, it has a Maven build option. You can use that to build that application. So that's why they are saying it provides you easy automation and also predefined build options. And finally, it also monitors your tools and it uses monitoring tools to monitor your application or your project which you have launched within Microsoft Azure DevOps. Okay, so Azure DevOps has various different tools. So let me explain to you those tools. So one tool is Azure Repos, which is a repository like GitHub. So it's pretty similar. It's basically the same. And then comes Azure Pipelines. Pipelines is the tool which you use to implement a CI/CD pipeline. A CI/CD pipeline is the one which you use to automate the software lifecycle. And then comes test plans, which is basically used to test the application. And then comes Azure boards, which is a Kanban board, which is basically like Jira, where you can implement work items, you can implement sprints. And then finally you have Azure artifacts, where you can store the packages like npm NuGet in the same place so that it is easier to access them. Also, finally, you get an Azure dashboard where you can access and also create and launch widgets which will be helpful for your application. For example, you can see how many builds have been succeeded, how many have failed, how much time it is taking to build a particular project, how many times it has been deployed, and how many users are using our application right now. So all these widgets can be used in Azure DevOps. So you've seen that. The next question is, what is Azure App Service? We already discussed this, but still I'll explain it to you once again. So to be very simple, Azure App Service is a completely managed service provided by Microsoft Azure. So within Azure, Azure App Service is a completely managed platform as a service, not infrastructure as a service, but a PaaS. It is a PaaS offering for proficient developers that conveys a rich arrangement of abilities to web, mobile, and integration services. So if a developer wants to just concentrate on the code which he is developing and doesn't want to manage the servers and the other side of it, that is the backend part of it, so what he can do, he can opt for a Azure App Service where he can launch one and he can just upload his code into Azure App Service, which will take care of provisioning servers, uploading the code within the server, and also serving that website, and also provide you an URL which you can use to look into the website. So you can do all of this using Azure App Service, and you don't need to manage anything. Azure will manage everything for you. It will launch, as told, it will launch servers. It will also monitor and manage them for you. And if you want anything else, if you want to scale it up, again you have an option for that. If you want to look into the server which it has launched, again you have a shell option for that. Mobile applications in Azure App Service offer a very adaptable, universally accessible mobile application development platform for enterprise developers and system integrators that conveys a rich set of capacities to mobile engineers. So basically, using Azure App Services, you cannot just launch websites, you can also launch mobile applications, and they are very adaptable and universally accessible mobile application development platform. For example, you might be using Android Studio or Xcode. So in this, you will be able to launch both of them and they will run successfully. So next we'll look into CMD let in Azure. So it's a pretty simple answer. So CMD let is a command, basically it's a PowerShell command, and this is utilized as a part of the PowerShell environment. So CMD lets, command lets are summoned by the Windows PowerShell to automate the scripts which are in the command line. For example, you have created a script, now you want to automate the script, you can go with command let. Windows PowerShell runtime additionally invokes them automatically through Windows PowerShell APIs. You can also automate CMD let commands which will automate other scripts using PowerShell APIs. So to be pretty simple, CMD let is a lightweight command which you can use in the PowerShell environment, and it is used to automate scripts. For example, if you want to launch virtual machine at a particular time, or if you want to monitor a virtual machine at 5 p.m. in the evening every single day, you can launch that script and you can automate it using CMD let, and it will run that script every day at 5 p.m. Okay, so the next one is Microsoft Azure Scheduler. So Azure Scheduler enables you to invoke activities, for example, calling HTTPS endpoints or presenting a message on a storage queue on any schedule. With Scheduler, you make jobs in the cloud that dependably call services both inside and outside of Azure and execute jobs on demand on a routinely repeating schedule or assign them for a future date. So in the name itself, you can understand Microsoft Azure Scheduler. So it basically schedules certain things for you. But what does it schedule? It schedules jobs on the cloud. So it can be within Azure or outside of Azure, and as mentioned, it will execute those jobs on demand, and it can be done on a repeating scale, that is, for example, every day or every week, or you can assign them for a future date to run only once. So that you can do using Microsoft Azure Scheduler. For example, it can call an HTTPS endpoints, or it can present a message on a storage queue on any schedule. So you can use the scheduler for any service on Azure or outside of Azure. So it's pretty simple. It is explainable by name itself. So to be simpler, you can tell this Microsoft Azure Scheduler is a service which you can use to schedule a certain task in Microsoft Azure or outside of Microsoft Azure to execute a job on demand, which can be executed repeatedly, or it can be set to a future date for execution only once. So the next question is, how can you create an HD Insight cluster in Azure? So let me explain it to you in a very simple way. So you can tell this because this is an interview, you will be asked questions, you will be able to answer them with words. So to make an HD Insight cluster, first of all, you'll have to open Azure portal, then click on new, you can select data services and you can click on HD Insight, or you can just search HD Insight and get into it. So once you get into it, you will have multiple options. You will have Hadoop, you will have HBase and Storm, and more options as well. So Hadoop is the default, and native execution of Apache Hadoop, and HD Insight provides you Hadoop as the default option. And then comes HBase, which is an Apache open source NoSQL database based on Hadoop that gives random access and solid consistency for a lot of unstructured data. Storm, as such, it is a distributed fault-tolerant open source computation system that enables you to process data in real time. So the thing is, I'm not going to explain Hadoop, HBase, and Storm right now. I'm just going to explain to you what is HD Insight. So HD Insight is an analytics service which you can use to launch Hadoop on the Azure cloud or other Hadoop ecosystem services like HBase, Storm, or Spark on Azure cloud. So to launch HD Insights, it's pretty simple, but to work with it, it is a little tough. So to launch HD Insight, you'll just have to go to the HD Insight cluster, and you can choose the service which you want and you can launch it. So HD Insight, again, it's an analytics service, and you can launch the big data or analytics service which you want from it. Next question is, what is Text Analytics API in Azure Mission? So let me put it simply. First of all, Text Analytics APIs comes under cognitive services. So API, the application program interface. So this particular API is for text analytics, which can be used to search a particular word, or it can be used for keyword mining. Okay, now let us just read this once. The API can be used or utilized to analyze unstructured content for tasks such as sentiment analysis and key phrase extraction. Sentiment analysis, in the sense, let's say you have a complete page of content. Now you want to see the sentiment of that content, whether the statement is happy or sad or neutral. So you can check out that using various keys, and you can enter those words into the API so that when it runs, it will check whether it is positive or negative. So you can see it has a numeric score between 0 and 1, and when it comes near 1, it is highly positive, and when it comes near 0, it is highly negative sentiment. So that you can see. This for sentiment analysis. And key phrase extraction, in the sense, if you have a very huge document and if you want to check whether this particular key phrase comes inside it, and you can use the Text Analytics API to check out the entire document. The upside of this API is that another new model need not be planned and prepared. The user just needs to bring the data and call the service to get the sentiment results. So they are telling that the best part of this API is that you don't need to call another service to run this API. Instead, you just have to bring the data set and call this API to run on the data set and get the sentiment results immediately. So I think you got it. It is a text analytics API mainly used for tasks like sentiment analysis and key phrase extraction. You have two numeric scores, 0 and 1. Near 0 it is negative, and near 1 it is highly positive. It's basically sentiment, and the upside is you don't need to call any other service. You can directly call this API and upload a dataset, and it will give you the sentiment results. Next question is, what is migrate tool? So again, in the name itself, you can get this answer: migration, a migration from the on-premise setup to the cloud, or from the cloud to the on-premise setup. This is a central hub of tools to discover, access, and migrate workloads to Azure. So you can migrate any type of workload into Azure. So it provides support for key migration scenarios across servers, data, databases, web applications, and virtual desktops. It saves costs and migrate efficiently with free tooling and Azure Cost optimization. So you can use the Azure Migrate tool to migrate databases or servers or web applications from your on-premise setup to the Azure cloud seamlessly. So for example, if you want to migrate your database, you will have to provide the details like the endpoint, then you'll have to provide the username and password, and then the destination would be a Azure database. You can provide the details of the Azure database, and once you click start, it will migrate the data from the on-premise database into the Azure database, and it's very simple to start with. So this is basically Azure Migrate tool. You can easily explain this with 2 or 3 sentences. And we've come to the final question, which is, what is Azure Service Level Agreement? First of all, the SLA ensures that when you send 2 or more role instances for each role, access to your cloud service will be maintained not less than 99.9% of the time. Additionally, identification and recorrection activities will be started 99.9% of the time when a roles instance procedure isn't running. So let me explain to you SLA in simple words. It's an agreement in which Azure tells you that this particular service will be running for this amount of time. So for example, if you are using a service for 10 minutes, Azure provides you a SLA stating that your application will run 99.9% of the time in that 10-minute period. So your application can go down only for a 0.01%. That's very, very less. So like that, Azure will provide you. If you are using a free trial service, they don't mention an SLA because it's your free trial and they don't give you any benefit for you. But if you have a paid Azure account, if you're paying every single month, they will provide you an SLA for every single service, which will mention that this particular service will run for this amount of time. So for storage, it's basically high. For example, it would be 99.9999% of the time. It will be always up. It will never go down. So SLA is a statement which tells you this particular service will stay up for this amount of time and it will not go down. For example, if you're using it for 1 hour, it will stay up for 99% of the time and it may go for 1% of the time. It's not that it will go, it may go. So this is Azure SLAs. So we've come to the last question of this session, guys. I hope you understood all of the questions which we've taught.
Just a quick info, guys. Intellipaat offers Microsoft Azure course training and certification. Through this course, you will be able to prepare for AZ-104 Microsoft Azure Administrator exam and much more from the top industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of Microsoft Azure Cloud.